Did you know the IEEE, that is Institute of Electrical and Electronics Engineers, ranks SQL as the leading language and developers looking for job opportunities? If you're on the hunt for your dream developer position, then this SQL tutorial is exactly what you need. In this tutorial, we are going to break down the fundamentals of SQL for you. You will learn the difference between a database and an RDBMS and SQL. We will also guide you through MySQL from the basics to more complex topics like subqueries, views, and case statements. But we are not stopping at just MySQL. You will also get hands-on experience with Oracle SQL and PostgreSQL, along with understanding theoretical concepts which will give you a better understanding of these essential tools. To top it off, we have got a project in MySQL to help you apply everything you have learned in real-world scenarios. And that's not all. We have saved the best for last. We will explore how generative AI is revolutionizing SQL and how you can use GitHub Copilot to supercharge your coding. By the end of this tutorial, you will have the skills, confidence, and cutting-edge tools to tackle any SQL challenge that comes your way. Plus, we have also added timestamps in the description so you can easily find out what interests you and jump to your favorite parts of the video. Let's first understand what a database is. Imagine walking into a bustling city where every action, from buying a coffee to checking social media, generates valuable data. This is where databases come into play. A database is like a highly organized digital library where all this data is stored, retrieved, and managed efficiently. What is a database? A database is a collection of organized information that can be easily accessed, managed, and updated. Databases are structured to facilitate the storage, retrieval, modification, and deletion of data in conjunction with various data processing operations. Now, let's see an example of database management system, that is online retail store. Consider an online retail store like Amazon, where you actually order your products, right? So every product will be listed and every customer who is actually ordering the products will be registered by their mobile number or location or whatever it is. So every order will be placed and every review written needs to be stored and managed efficiently. So you will be giving your review in the review section and that has to be stored and that will be managed efficiently. That is what is all about. So the products. So the database stores information about each product such as name, description, price, and stock level. So any product you go and search in your Amazon website, you will find its name. You can search a product by its name or by its description, right? So that is all about product. And the customers. Customers' details like name, email, address, and purchase history are stored securely. So all your information will be stored once you buy a product from Amazon. Orders. Each customer orders, including products purchased, quantities, and transaction details is recorded. So whatever you order today will be recorded. So they can just go back and check the database to get to know what the orders are. Reviews. Customer reviews and ratings for products are also stored. So anytime they can go back and see the reviews and they can work accordingly to make the product better. Why is learning about databases important? Understanding databases is crucial because they are the backbone of nearly every application and service we use today. They ensure that data is stored securely and can be retrieved quickly and accurately when needed. By learning about databases, you can, first thing, enhance efficiency. Design systems that handle large volumes of data smoothly. Second, improve decision making. use data to make informed decisions in businesses, healthcare, finance, and more. Third, ensure data security. Implement measures to protect sensitive information from unauthorized access. Now, let us look into some of the factors to maintain a database management system. To ensure that a database management system runs efficiently, there are several factors that has to be considered. We will see what those factors are. The very first one is the data integrity. So, data integrity is nothing but the accuracy and the consistency of data over its lifetime involves enforcing rules and constraints to prevent invalid data entry. For example, the product's price are always the positive numbers. It can't be negative, right? So that has to be maintained. And that email addresses follow a standard format. So email addresses also should be in the specified format, right? It can't go wrong. So all these data should be stored correctly and efficiently. So the prices can't be negative costs, right? So that is all about the data integrity. Next is your security. Protecting data from unauthorized access and breaches. So this involves setting up user authentication and permissions, encrypting sensitive data, and regularly updating security protocols. For example, only the authorized personnel can access customer payment information. So here, security is very important, right? You are buying a product from online and you are making the payment online. And what if that payment goes to a third person who is actually hacking the payment website? So all this has to be taken care, right? So whatever you pay for the product should actually go to the particular website or Amazon person, right? So this is all about security. Next is your backup and recovery. Regularly backing up data to prevent loss due to hardware failure, software issues, or any disasters. Having a recovery plan in place to restore data from backups quickly. For example, you have ordered something and you have made the payment on the Amazon website. And what if some disaster happens? Some software will fail or some hardware issue will occur. And what if they lose your order list and you don't receive your product? It's very bad, right? So they get negative reviews and they get into problem or trouble. So in that cases, they have to have a backup of what the data is or what orders are placed by a person or customers, right? That is the importance of backup and recovery. So daily backups of the database are stored on a secure cloud server to prevent the data loss. Next is your performance. So performance optimization. Ensuring the database runs efficiently with fast query response times and minimal downtime. This involves indexing, query optimization, and regular maintenance. So, every now and then, if they maintain based on a regular intervals, then the performance will definitely increase, right? Or else, if they don't have the regular checks or intervals, there are chances where the problems might occur, right? For example, using indexes on frequently searched fields like product names to speed up search queries. So if they maintain the database or check the database regularly and make the alternative solutions for a product, then the sales also will increase for a particular product. So obviously, simultaneously, the performance also will increase. That is all about performance optimization. By understanding and managing these factors, you ensure that the data remains reliable, secure, and accessible, enabling you to harness its full potential effectively. Whether you're building a new app, analyzing large data sets, or securing sensitive information, a solid grasp of databases is essential. Now that you have a solid grasp of what a database is and why it's essential, you're on your way to mastering the fundamentals. Ready to take your knowledge even further? But before that, subscribe to our channel to stay updated on the latest insights and techniques in database management. Up next, we will explore the key differences between a simple database and a Relational Database Management System, that is RDBMS. Understanding this distinction is crucial. We will discuss how RDBMS enhance data organization and management through relationships and structured queries.
The first thing that we really have to talk about in the world of DBMS and RDBMS is to take a quick introduction to understand what they are for the people who are not familiar with these concepts, right? Now, a database management system, or as it's called in short, DBMS, is basically a system where you can organize your data and work on your database in a structured fashion, right? So considering this, the major thing that always comes into mind is how the data is stored. That is where the heart of the difference lies between DBMS and an RDBMS, right? For example, even how the data is stored is a huge difference. Take a look at the DBMS side of things, where it says data is stored in a hierarchical order, while a relational database management system, or an RDBMS as it's called, is again another type of database management system which will give you the features of a DBMS alongside having to work with data in a different way, because here each of the data points, right, be it columns or be it tables in a database, these tables have entities or specifiers, right? They're called as keys, and I'm sure you might have heard of it: primary key, secondary key, and what all, right? To quickly give you an example of where DBMS is used, think about how Windows stores files, right? That is a very good example of DBMS, even XML files and more on those note. Now, if you're talking about an RDBMS, think about all these Oracle servers, think about MySQL, and think about the other flavors of SQL that are in existence, right? Because SQL stands for Structured Query Language, and it is a very popular offering to be used when you're working with a relational database management system, right? Fantastic. Coming to the differences between a database management system and a relational database management system, here are some of the most important points that you guys really have to know about, right? The first point, since we're talking about databases, we really have to talk about data storage. As I already told you, the way the files are stored in these databases are super different, right? In a DBMS, a traditional DBMS actually stores its data in the form of files for an application to be used. Each individual file will be stored and used, right? Sometimes it can be stored as JSON files, other times it can be stored as other files like XML or anything else as well. Coming to the RDBMS side of things, here the data is not stored in the form of individual files, but it is stored in the form of a table. Now, you might have seen databases with multiple tables in it, and if you have realized that these tables have a connection in a way where they can be linked with each other to add more functionality or to add convenience, right? Again, the use of primary key, secondary key, and all of that is just because that we can have this kind of a leeway where we can link two tables or two data elements together and use them to perform any operations we require, right? That is an important point. All right, coming to the next difference, we really have to talk about normalization. Now, normalization lies deep in the heart of the entire concept of databases as we know it, right? Because here, with respect to DBMS and RDBMS, there is a huge difference. A database management system does not offer any sort of support for normalization, be it 1NF, 2NF, or Boyce Codd normal form. All of these is not supported in a traditional database management system. But if you're looking at a relational database management system, yes, you do get the flexibility of working with normal forms, right? So normalization is basically an operation of how you would efficiently want to group and bring the data together in a way where it is not only more readable, but it is also efficient to be stored, right? There's multiple normal forms that are out there, be it 1NF, that stands for first normal form, second normal form, third normal form, Boyce Codd normal form, all of these things, right? So if you're working on a DBMS, understand that it does not offer any sort of support for normalization, while a relational database does offer, right? A huge difference. Now, the third difference that we're going to talk about is with respect to data integrity. Data integrity is very important, and again here the RDBMS has a slight edge over it, because with a DBMS you really don't get anything native to the database management system where it talks about data security properties, or where it talks about providing any sort of methodologies, any structure and policies that your data will have to follow if it is stored or worked with on the database, right? You don't have any of those features. features here. Of course, with multiple different flavors of DBMS, you can tweak around with having another software, another tool to maintain it. Of course, data security is still very good with DBMS, but then there is another add-on which does the part for it, right? It does not come native. Talking about an RDBMS, this is again the exact opposite of a DBMS, where you do get a certain properties. I'm sure you might have heard about it. They're called as asset properties, and this is used to define the entire aspect of data integrity, right? Alright guys, so for the people who do not know what ACID stands for A as in atomicity, C as in consistency, I as in isolation, and of course D as in durability of data, right? You see that these four properties, each has its own niche application. Each is a property which will govern an aspect of the data, right? This advantage you do get with an RDBMS that you do not with a traditional database management system, right? And then of course, coming to point number 4, we were talking about application itself. Where should you use a DBMS and where does an RDBMS work fine? Well, a DBMS, a traditional DBMS can work very well if your application is depending on one single user and maybe it is a part of a solution through a small organization setup that you might have, right? What I mean by that is you might not have the capability to handle large amounts of data effectively or have access wherein multiple users can work on the files simultaneously, right? So this complexity is in fact avoided rather than me saying that it is not supported, right? In the world of how we use data and store it, we usually prefer an RDBMS if we have a requirement which says, hey, you need more than one user to work on the data. And of course, the data set is really complex. So you are going to require a different management system, right? A different way of how you would store the data. So as soon as it becomes multi-user and it is a part of a big organization and a large data set, I really think you guys should look towards RDBMS there, right? And then coming to the last point in our comparison, this is a very important point because here we're talking about distributed databases, right? Now, distributed computing is something that is really taking off, and that can favor a lot here because if you're talking about a traditional DBMS, it doesn't really give you the chance of having your data stored in multiple databases in chunks and you having access to it, working with it, and thinking about everything else such as debugging, storage, addition, removing, backing it up, all of these things, right? These things become a point of concern where you'll have to spend some time to see how you will work around all of these limitations. But with an RDBMS, these systems do provide complete support for distributed databases. So in the domain of big data, or in fact in your own small amount of data can be stored in multiple databases, you can actually have a way of connecting these databases and having access to your data, right? Think about it like a master copy where you're trying to access the data from all of these databases, right? That's an analogy which will tell you how RDBMSs are slightly advantageous to DBMS in this point.
Now that you understand the differences between a database and an RDBMS, it's time to dive into SQL. SQL, or Structured Query Language, is the powerful tool you will use to interact with and manage relational databases. Through SQL, you will learn how to create, read, update, and delete data efficiently. Mastering SQL will provide you with the essential skills to perform complex queries and handle any database-related tasks with confidence.
So now that we've understood what exactly is a database, let's look at the type of data models. So what is a data model? Now in simple terms, data model is a logical structure of a database. So the data models can be divided into two broad categories. The first category would be object-based logical model and the second category would be record-based logical model. So when it comes to object-based logical model, you can consider this to be a blueprint for your database, right? So what you do in this is you set up a blueprint for the different entities which you have in your data. Now, let's say if we take the same example of your company database, then in that database, you would already have multiple departments. And apart from that, you would maybe have a table related to all the employees, a table related to all the managers, a table related to maybe the salaries and so on. So what you do is you set up a blueprint of how each of these tables are related. So maybe let's say if you have one employee table and one department table. So what you do is you create a blueprint of how the employee table is related to this department table. So this gives you an overview of different entities in the table or different entities in the database, and also what is the exact relationship. So when it comes to the entity relationship model over here, you could have many different types of relationships. You could have one-to-one, many-to-one, one-to-many, and many-to-many, right? So simply put, when it comes to entity relationship model, you can consider this to be a blueprint of your database. And then we'll head on to the record-based logical model. So when it comes to record-based logical model, you can consider this to be the implementation of your ER model. So that is why it is known as record-based logical model. So in record-based logical models, as the name states, obviously you would have records. And this would give you a data model where it will tell you how these records are related to each other. So in this, the primary data model would be the relational data model. And most of our databases which we use regularly are the relational data models. So what happens in relational data model is our data is stored in a tabular format. So when I say a tabular format, the data is basically stored in the form of rows and columns. Now, you can consider these to be two different things. You can consider each column over here to be indicating an entity. So one column could be maybe the name of the employee, another column could be the salary of the employee, next could be the department of the employee. And each record would indicate one complete entry. So let's say if you have one record, now that one record would tell you the employee ID, the name of the employee, the salary of the employee, where does the employee stay, and so on. So this is what a relational data model gives you. Now, after relational model, we have something known as the hierarchical data model. So in the hierarchical data model, we have these records arranged in a tree-based structure. So what you can understand from this is, you can consider there is a root node at the top of everything. And from that root node, you have multiple nodes coming down. So I'll just repeat it again. What happens in a hierarchical data model is you have a root node and you have multiple nodes branching out of that root node. So you can take an example where, let's say, the top node is maybe the different courses a student can enroll for. That is your root node. And from that, you would have multiple nodes branching out. So there could be one node branching out or one record branching out, which would have the ID of the student, the name of the student, and maybe the course which the student has taken. So similarly, you have multiple of these records branching out from the root node. And then next to hierarchical model, we have the network data model. So the only difference between network data model and the hierarchical data model is, while the hierarchical data model is a tree-based structure, the network data model is a graph-based structure. So over here, you can have more than one parent nodes. So these are different types of data models which come under a database. So over here, we have the ER diagram. So ER diagram is basically the entity relationship diagram, and this gives us this blueprint over here. So as you see, this gives us the blueprint of the different jobs across different countries, across all of the employees, and across all of the departments. So now that we've understood the different types of models, let's understand what exactly is a DBMS, and let's understand some of its operations. So DBMS stands for Database Management System. Now we already have a database with us, but to work with a database, we would need a management system, right? Now the perfect example for this would be, let's say, our laptop or our computer. So we have a computer, but to work with a computer, we would need some sort of operating system to work with the computer, isn't it? So this is where we have operating systems such as Windows, Linux, and so on. So these operating systems help us to work with the computer or the laptop. Now similarly, whenever we have a database with us, to work with the database, we would need a database management system. And in this session, we'll be working with the relational database management system. So relational database management system, for this, the data model would be the relational model. Now, these are different operations which you can do. You can add new files into the database. So let's say if you only have the employee table in your database and you'd also want to add the departments tables, you can go ahead and do that. Similarly, if you want to insert new data, now let's say there are 500 employees and in the next 1 year, you have made an assumption that there would be 500 more employees joining. So you'd have to insert data related to all of those employees as well. You can go ahead and retrieve all of the information related to all of the employees if you want to modify the data. So there would be cases where, let's say, the name of the employee is incorrect, or the age is incorrect, or maybe there is some sort of mistake. While we enter the data, we can go ahead and modify it. Similarly, we can, if we want, we can also go ahead and remove some data or remove the entire table or the entire file itself. Now let's understand the advantages of DBMS. So with the help of DBMS, we can share this data across multiple applications. Now, when you have a DBMS, you can integrate DBMS with multiple languages. As let's say if you are building a Python program or a Python web application, and this Python web application needs to have a database at the backend. So what you can do is the Python language itself would give you something, an API, or maybe it would have a syntax in itself to integrate it with the backend database. Right, so you can work with the database along with multiple applications. So this is what is known as sharing of data across multiple applications. And you also have enhanced security mechanism. Now, when you're storing data, and that too lots of data, huge amounts of data, your primary concern needs to be to make sure that the data is secure at all points of time. And that is the major advantage of a DBMS. You can also go ahead and enforce integrity constraints. So integrity constraints are basically some constraints which you would want to give while inserting the data or modifying the data. Now, let's say there are some things which a normal employee cannot change. So let's say the salary of the employee. Now, if you have the entire employee table accessible to everyone in the company, so everyone can go ahead and change the salary values in that particular table. So what you do is you go ahead and set some constraints with respect to that particular column in the table so that nobody or only few people can go ahead and make those changes. Similarly, we have something known as better transaction support when it comes to DBMS. So the perfect example for this would be a banking system. And now there could be multiple cases where people are performing multiple transactions. So in banking system, we basically either withdraw money, deposit money, or we check balance. So when thousands of these transactions are occurring at the same point of time, there could be cases where some of these transactions occur at the same time, or maybe there is some sort of discrepancy between these transactions. That is why you have to make sure that either these transactions are completed perfectly, or if there is any sort of error, then the transaction can be rolled back. And we also have very good backup and recovery features. So let's say if some of the data gets corrupted or some of the data is lost, then there is very good backup mechanism for us to restore the data through the DBMS. So we've got all of this overview of DBMS. Now let's understand what is RDBMS. So DBMS stands for Database Management System, and as I've already told you, RDBMS stands for Relational Database Management System. So as it is stated over here, a relational database refers to a database that stores data in a structured format using rows and columns. And this is what we learned in a relational model. So whatever data we have, we store that data in the form of rows and columns. And this makes it easier to locate and access specific value within the database. Now, let's say inside the entire employee table, I'd want to extract only those employees whose salary is maybe greater than $100,000, right? So these are very specific values. Now, if the data is stored in rows and columns, it becomes very easy for me to extract all of those records. And this RDBMS is known as relational because the values within each table are related to each other. So let's say the name of the employee would be related to the employee ID. Similarly, the age of the employee would be related to the name of the employee. And the relation could exist among multiple tables as well. So there is a definite relationship between the employee table and the department table. So one employee can work in only one department at a time. It's not that there is one employee who is in the HR department and is also in the tech department. That is obviously not possible. So all of these are certain features of RDBMS. Now there are some more features. Let's understand all of them properly as well. So every piece of information is stored in the form of tables, which you've already learned. And these tables have something known as primary keys. Now, these primary keys help you to uniquely identify each of the records in the table. So when you store data into a table, you need to understand that each record in the table is different. So if we take the same company database, now in that company database, if you have 500 employees, then you need to understand that each employee is unique. So let's say if there is someone known as Matt LeBlanc in your company, there can't be two Matt LeBlancs, right? So let's say if there are actually two Matt LeBlancs, then there need to be some sort of differences between these two Matt LeBlancs. So let's say if the first Matt LeBlanc, his age is 25, then the age of second Matt LeBlanc must be 30. But then again, let's say if the age is also same, then maybe the department in which these two work could be different. So maybe the first Matt could work in the HR department and the second Matt could work in the tech department, right? So with the help of primary keys, you can uniquely identify each row in your table. Now, this is with respect to one particular table. And when you're linking one table to other tables, right? This is what we're talking about, the relational in terms of multiple tables. So in this case, also there could be a lot of scenarios where there could be possibility of duplicacy. So this is where you use something known as foreign keys. And then if you have all of this data, let's say if you have a table with millions of rows and thousands of columns, then you'd have to retrieve information in a very quick way. So for this purpose, SQL provides you something known as indexes. And the best part of RDBMS is it gives you access privilege. So there are again a lot of scenarios where we have to ensure that only few people have access to certain parts of the database or certain parts of the table. This is where you can grant access to the user or revoke access to the user. Now let's go ahead and understand the difference between RDBMS and traditional approach. So the key difference is that RDBMS applications store data in a tabular form, which is what I've been saying from the starting of the session. Whereas in the traditional approach, applications store data as normal files. So this could be a file with any format. It could be a file with maybe a .json format, .xml format, .pdf format, right? But when you want data to be in the form of an organized structure, that is where you'll go ahead and store all of this data in the form of a table, and then you'll store this in a DBMS. And it is stated that there can be, but there'll be no relation between the tables like in a RDBMS. So we are talking about the traditional approach. So in traditional approach, data is generally stored in either a hierarchical form or navigational form. That is, if there is a single data unit, it will have 0, 1 or more children nodes and 1 parent node. But you will not have any table structure over here when it comes to the traditional approach. So those were all of the basics of database and database management system. Now let's go ahead and understand what exactly is normalization. So normalization is very important when you're storing data in a database. So again, whenever you're storing data into a database, you are storing a lot of data and there could be a lot of duplicate values, a lot of data which is redundant. So this is where you'd have to make sure that whenever you're inserting the data, all of this data is devoid of the redundancy. All of the data is atomic and there is no repetition in the values. And this is where normalization comes in. So as it is stated over here, normalization helps us to decompose larger and complex tables into simpler and smaller ones. So I'm just stating it again. So whenever you're storing data into a database, generally the raw data is extremely complex and it is and you can't really make sense out of it. So if you want a proper structure to the table, you will go ahead and use normalization and decompose that larger table into a smaller one. And now in normalization, you have multiple normal forms. So what you do is to have that proper structure, you go through these different normal forms. So we'll understand those normal forms in this session. So we've got 1NF, 2NF, 3NF, and then we've got Boyce Codd normal form, 4NF and 5NF. So out of these, we'll comprehensively understand the first normal form, second normal form, and the third normal form. So again, let's understand the need for normalization. So whenever we are dealing with database, it's very essential to have a database with a good design. We can't have redundant data in our table. And also if we have redundant data, then to either retrieve the values or to maybe modify the values, the expense of the operations would be a lot. So to minimize that, we would have to use normalization. And again, to avoid any unnecessary replication of information, we will go ahead and use normalization. So this is an example to understand the concept of normalization. So we've got this table over here. And as you see, we've got these 4 columns. We've got student details, course details, prerequisite, and result details. Now, if you closely observe, you'd find some fault in this, or maybe you'll find that the structure is not really proper. So inside the student details, we have the student ID, name of the student, and date of birth of the student. Similarly, in course details, we have the course ID, course name, and maybe this is the duration of the course. And then we've got the prerequisite of it, and then result details. So this could be maybe the date of the exam, the marks scored by the scored in the exam, and the grade of the student. So if we take these individual columns, if we take this particular column, then we have to make sure that every column, so all of these columns, the attributes, those are unique, and also there are no multi-valued attributes. So as we see, there are multi-valued attributes over here. So we have name of the student, student ID, and date of birth in a single value. So this is not a proper table design. And again, over here, we've got 3 things in the same column. Again, over here, we've got 3 things in the same column. So whenever we have multi-valued attributes like this, we'd have to go ahead and divide them into single valued attributes. So now to understand all of that properly, we'd have to understand something known as functional dependency. So let's say there is this result over here, which would give us student, course, course name, marks, and grade. Now from this, as it is stated over here, student and course together defines exactly one value of marks. And student and course determines marks, or basically it means that marks is functionally dependent on student and course. And similarly, as marks is dependent on student and course name is also dependent on course, and grade is also dependent on marks. So what I'm trying to say is, when you have a table as complicated as this, you could have a lot of dependencies. So let's understand each of these dependencies properly. So we've got student, course, and marks. Now, when you talk about these marks over here, these marks are obviously dependent on the subject or the course which the student takes. And the course in turn is dependent on the student. So the student, course, and marks are interdependent. This means that if you want the marks of the student, then you would have to know the student details as well as the course details. So this is the functional dependency which is occurring in this table. And similarly, we've got this functional dependency between the course name and the course. So this is the course name over here, and this is the course ID over here. So if we want to know what course is the student studying in, then we would obviously have to know the course ID. And similarly, if we'd have to know the grade of the student, then we'd have to know the marks secured by the student. So let's say if there is this grading system where if we grade somewhere between 80 to 100, so if the student gets somewhere between 80 to 100, then the grade is A. So this is the functional dependency I'm talking about. If we don't know the marks of the student, then obviously we won't be able to get the grade of the student. Now, let's understand this in a better way. So as it is stated over here, we've got 2 attributes over here, P and Q. So in a relation, so the relation is stated by R, P and Q are attributes. So these 2 are the attributes. And attribute Q is functionally dependent on attribute P if each value of P determines exactly one value of Q. And to understand that, let's again go back to this. So this is our attribute Q and this is our attribute P. And if we want to get the value of this, we would obviously need to know this. So this is P, this is Q, and to get the grade A, we would obviously need to know that the student has scored 82 marks, and this is the functional dependency. And there are two types of functional dependency. We've got partial functional dependency and transitive dependency. So let's start with the partial functional dependency. So in partial functional dependency, attribute Q is partially dependent on attribute P if and only if it is dependent on the subset of attribute P. So here we have an example over here. So let's see, this is the report and we've got all of these factors. Now, this is our attribute P and this is our attribute Q. So we can clearly see that marks of the student is partially functionally dependent on student and course. Similarly, course name is partially functionally dependent on the course. Now, to remove the redundancy in your table, you'd have to make sure that there is no partial functional dependency. Similarly, we've got transitive dependency. This would mean that if Y is dependent on X and Z is dependent on Y, then this would mean that Z is also dependent on X. So this is the relation which we have over here. So if course is dependent on students and marks is dependent on course, then grade over here is obviously dependent on the student. So this is the transitive dependency which we'd have to remove from the table. And now we've finally come to normalization. So as it is stated, the three types of normal form which we're going to look today are the first normal form, second normal form, and the third normal form. Let's start with the first normal form. So whatever table you have or whatever relation schema you have, it is in one NF if and only if all the attributes in the relation are atomic. That is indivisible in value and there are no repeating elements or groups of elements. So this is our original table over here, student marks table, and we'd have to ensure two conditions. So the first condition is all attributes are atomic. So all of these attributes have to be atomic. That means that all of them have to be single valued attributes and not multi-valued attributes. And there should be no repeating elements or groups of elements. This would mean that all of these values should be unique. Now, when we take this and convert this into one NF, we see that all of these multi-valued attributes have been taken or grouped into one single value. So over here from student details, we've got three separate columns. So this is taken as student ID, this is taken as student name, and this is taken as date of birth over here. Similarly, over here from this is taken as course ID, course name, and over here we've got the prerequisite. And we've got from this the result over here. So from the result, we can get the marks, grade, and the date of the exam. So this is how we have made sure that all of the data in this table is single valued and it is unique. So now we have converted the table into 1NF. We'd have to proceed it to the higher level, which is 2NF. So to ensure the table is in 2NF, we'd have to make sure that the table is in 1NF first. And after the table is in 1NF, we'd also have to ensure that there is no partial dependency between non-key attributes and key attributes. So you would not know what a non-key attribute is and a key attribute is. So let's understand this properly over here. So these values which you see over here, student and course. So these are the key attributes. Now what are key attributes? A key attribute helps you to uniquely identify a record which you were talking about. So let's say if you have the same company database and if you have different employees, if you have 500 employees, then to uniquely identify each employee, you would need to have the employee ID. So each employee would have a unique employee ID and that way we can easily identify him. So here we've got student, which is the key attribute. Similarly, we've got course, which is the key attribute. And apart from this, all of these would be non-key attributes. So we'd have to ensure that there is no partial dependency between these two. So what this means is, now the student table has to be separate, the course table has to be separate, and the exam table has to be separate. We have clubbed everything into a single one over here. So as it is stated, to get the second NF or 2NF from 1NF, we'd have to take three separate tables. So the first table would be the student table, second would be the course table, third would be the duration days and date of exam. So we'll take student name and date of birth into the student table, course name and prerequisite into the course table, and the rest would be the result table. So over here, we have got the 2NF from 1NF. So in 1NF, all of these columns were clubbed into one single table. Now, to get into 2NF, we had to make sure that there is no partial dependency between key attributes and non-key attributes. So over here, we had a dependency between student and course. Similarly, we had a dependency between course and the result, which shouldn't be the case in 2NF. So that is why we have separated out the student table, separated out the course table, and also separated out the result table. So this is also done. Now, after this is done, we would have to head to the third stage, which is 3NF. So for the table to be in 3NF, the first condition is the table should already be in 2NF. Now, after we make sure that the table is in 2NF, we'd have to make sure that there is no transitive dependency between non-key attributes and key attributes. So if we take a look at the result table over here, so we see that course is dependent on student, marks is dependent on course, and grade is dependent on course. But this shouldn't happen. So this is the transitive dependency which we see. So grade over here should only be dependent on marks and shouldn't be dependent on the student. So what we'll do is we'll separate out marks and grade and we'll create a new table out of this. So in the result table, we'll only have student, course and marks, and in the grade table, we'll have marks and grade. So this is how we can convert a 2NF table into a 3NF table. Now let's start off with an introduction to SQL. Now you would have worked with a lot of programming languages, let's say C, C++, and Java. But the problem is these languages would not explicitly help you to work with a database. So this is where the need arises to have a specific programming language which would help you to work with a database. And this is where SQL comes in. So SQL basically stands for Structured Query Language. So you have different queries which would help you to create a database, manipulate a database, and share or access data from that database. Now understand, let's three of these aspects properly. Now, when we say creating a database, it's very important. This basically becomes the primary part of SQL because you have to store the data somewhere. Let's say you would have an employee table or a student table or maybe a table with respect to all of the patients in a hospital, and you would have to store all of this data somewhere. So what you do is you go ahead and create a database, and in that database, you can store multiple tables. Now, the important thing to consider over here is you need to understand that a database is something which provides a proper structure to all of your data. So let's consider the college database. Now, let's say if you want to store all of the data related to some particular college. So what you can do is you can create a database named as college. And in that, you can have a separate table for all of the students, a separate table for all of the teachers, and maybe a separate table for the grades or the different departments in the college. So this is the creating part of the database. You can create a database and you can also create multiple tables in that database. So the primary thing to note over here is all of the tables which you store inside a database have to be similar. So this is the need of a database, of creating a database. Now, once you create a database, you can go ahead and manipulate the data which is present in the database. And this is the primary reason why SQL is so widely used. Now, let's say you have that student table in that college database. Now, you would want to know all of the top scoring students, or maybe you would want to know all of the students who failed in a particular subject. So all of this you can find out with just maybe one line of query or two lines of queries. So that is how SQL makes your task extremely easy. And also whatever data you store in your database, you can make sure that only some specific people have access to that particular data. So this is where the share and access part comes in. So you can ensure that only people who are important or only people, the right people can have access to that data, and it is shared among those people who actually understand that data, and this doesn't go out of the primary group. Right? So this is the importance of SQL. So now let's understand why do we need SQL. So SQL is widely popular, which we've already understood. Now let's look at some of the advantages of it. As it is stated over here, SQL allows users to communicate, that is access and manipulate the database, which we've already understood. Now SQL is the primary language to access a database. Now, you would say that we can also connect with the database with maybe Python or C, but what you fail to understand over here is maybe when you connect your programming language to a database, let's say if it's Python or Java, but to manipulate the data or to access the data, you are writing SQL queries in Python, or maybe you're writing SQL queries in Java. So SQL is the only language which would help you to access and manipulate the database at the backend. And that is why, even if you know all of the high-end languages, SQL is very, very important when you have to deal with any sort of data. And SQL, as it is stated over here, it would also help you to retrieve data from a database. So storing is one aspect of it, retrieving is the second aspect of it. Obviously, when you store a data somewhere, you would want to retrieve it and would want to have a glance at it, wouldn't you? Right? So storing and retrieving is done, and you would also want to update, modify, or delete whatever data is present over there. Now, time to time, there would be a lot of changes in the data. So let's say if we take the student table in that college database, that be new students joining, or maybe let's say there's some corrections in the grades of the students or the marks of the students. So all of this has to be updated. There are a lot of cases where there could be a slight error in the names of the columns. So all of that can be modified. And you can also go ahead and delete some specific rows, or maybe you can go ahead and delete an entire table. So let's say if you've lost some records, or maybe there's some discrepancy in the data, then you can go ahead and either modify the data or delete that data. So all in all, SQL is basically a language which would help you to define the structure of a database. And it is not just limited to that. Once you define the structure of a database, you can go ahead and create and access data in it. You can retrieve data from it, and you can also modify and data whichever is present in it. So all of these are advantages of SQL. So now that we've understood what exactly is SQL and why is SQL so important, let's look at some specific terms which are related to SQL. So the first term, the primary term which is so important in SQL is data. Now, my question to you guys is, what exactly is data? So think for a while. Now, what comes to your mind when you hear the word data? So in simple terms, data is just facts and figures, as simple as that. Now, let's say when you work with numbers such as 30, 500, 1000, all of these numbers are nothing but data. When you work with sentences or characters, let's say if you have a sentence such as my name is pizza, or I like pizza, or I'm going to Paris this Sunday. All of these are statements which again is data. Now, when you work with mathematical formulas such as a plus b whole square is a square plus b square plus 2ab, what is that? That again is data. And when you talk about computers in general, data for computers would be binary code, zeros and ones. So in simple terms, whatever facts you deal with, that is data. Now, when you have all of this data with you, you'd have to store it somewhere, right? And that is where a data comes in. So to sum it up, data is basically defined as facts or figures or information that is stored in or used by a computer. So in simple terms, whatever facts you have, whatever raw data you have, you can go ahead and store it in a computer, and that is known as data. Now, when you have all of this data, it becomes very, very important to organize it in a proper way so that you can retrieve all of this information whenever you want it. And that is where a database comes in. So as it is stated over here, a database is an organized collection of data or information so that it can be easily accessed, managed, or updated. Now, let's take the same example of the college database. So you would have a lot of data with respect to that college. As I've told you, there could be data related to students, there could be data related to teachers, there could be data related to the different departments of the college. Now, all of this data is present in a haphazard manner, and if you just store it in a random way, then retrieving it and finding information out of that raw data would be very difficult. So what you do is you go ahead and collect this data and provide some proper structure to it, and then go ahead and store it in a database. Now, let's say if you have all of that data, so what you do is first you find out whatever data is only relevant to students. You take that data and create a student table out of it, and then go ahead and store the student table inside that college database. Now, similarly, you will find out whatever data is relevant to all of the teachers. You will take this data and store it in the college database. Similarly, you will find out whatever data is similar with respect to different departments. Let's say if it is an engineering college, then you'll find out the data with respect to different departments, such as you would have a computer science department, you would have a mechanical engineering department, you would have a chemical engineering department. So you will have specific data with respect to all of these different departments, and you will store it in one particular table, and then take all of these tables and store it in a database. Now, once all of this data has a proper structure in the database, you can go ahead and use SQL and maybe modify the data or retrieve the data. So those are the basic terms in SQL. Now let's look at the different data types which we can work with in SQL. So first we have numeric data. So as I've told you, when you work with numbers, all of that is numeric. So these are different types of numeric data you can work with. You've got bit, tiny int, small int, and so on. So this is the different sizes of the data that you can store. It basically increases in size over here as you go from bit to big int over here. Now, it's just that you can store a number of a greater value in big int when you compare it with just a bit. Now, all of these would be integer values. And if you want to store decimal values, you have over here. So you can store decimal values in either decimal or float. So these are the different types of numeric data you can store in SQL. Similarly, you can store character or string data. A character would be, let's say, all of the alphabets. You got A, B, C, D, E, F, G, H, all of these characters. And similarly, you have varchar over here. Varchar stands for variable length character. So in variable length character, you can store different strings. Maybe you can store a string called as pizza. You can store a string called as Sparta. So whatever it is, you can even store sentences. So I love Sparta, or maybe I love pizza. So whatever these sentences are, you can just go ahead and store it in varchar. And then we have a data type called as date time. Now there would be a lot of cases, especially when you're dealing with data, that you would have to store data with respect to date or time. Now all of this would be historical data, and it would be very important to know what exactly is the date with respect to all of this. So again, if we take the same college database, then we'd want to know on which date which exam had occurred. So something like this. So let's say if it's an engineering college, then we'd want to know on which day the computer science exam was conducted. Similarly, on which day the chemical engineering exam was conducted. So date time is very, very important. So we have all of these over here. We've got the date data type, and with this, you can basically store the date, which would have your year, month, and then day. And then you have the time over here. So with the help of time, you can store hours, minutes, and seconds. Then you have date, time, which helps you to store date and time at the same place. Now, similarly, you have year. You can store the year at which some sort of event would have occurred. Now, after this, we have Unicode or character strings such as nchar, nvarchar, and ntext. And after that, we also have miscellaneous data types. Now, there would be a lot of cases where we'd want to store some sort of XML data or JSON data. Then SQL also provides us an opportunity to store XML data and as well as JSON data. So those are all the different data types which we could work with in SQL. Now, let's understand what exactly are constraints in SQL and look at the different types of constraints. Now, when it comes to SQL, there'd be a lot of scenarios where we'd want to restrict some type of data which we are storing into the table, or restrict some type of data which we are extracting from the table. So this is where we need constraints. So constraints, as the name states, would put in some sort of constraint on the table when you're either storing the data or retrieving the data or maybe even modifying the data. The first constraint which we have over here is the not null constraint. Now, let's say if we have 5 columns in a table, and the first column in a table is the employee ID. Now, you want to make sure that no row in this employee ID column is left as a null or is left as an empty value. So this is where we'll put a not null constraint. The not null constraint ensures that the user provides some sort of input with respect to this particular column, and if the user does not provide an input, then SQL would arise an error. So as it is stated over here, not null constraint ensures that a column does not have a null value. After that, we have the default constraint. Now, many a times it would happen that we would want to store a default value for a particular column. So here, let's say, as it is stated over here, provides a default value for a column when none is specified. Let's say we have the age column in the student database, and we are dealing with maybe the 12th standard students. Now, 12 standard students, their age would be 17 or 18 in general. So what we do it, by default, we'll set all of the students' age to be 18 because it is easier that way. And there will be very few cases where the age of the student is not 18. So wherever the age of the student is not 18, then we can go ahead and modify it later on. So wherever if we want to set a default value with respect to a particular column, we can use a default constraint and set a default value over there. After that, we've got this unique constraint over here, which ensures that all the values in a column are different. Now, let's say if it is again the employee ID or maybe the student ID, then it is absolutely necessary that every employee should have a unique employee ID, or every student should have a unique student ID. And to these columns, you would put in this unique constraint, which would ensure that whatever data is fed into the employee ID column or the student ID column, you are making sure that that data inserted is totally unique. And after that, we've got this primary constraint over here. So this primary key or foreign key constraint ensures that each row or record in a database is uniquely identified. Now, what does this mean? So simply put, you can consider the primary key constraint to be a combination of your not null constraint and the unique key constraint. So when you add the primary key constraint to a particular column, you are making sure that whatever value is inserted, it is not null. That means that you definitely have to insert a value, and the value which you are inserting, it has to be unique. And this helps the table to uniquely identify each row or record in that particular database. And after the primary key, we have the check constraint, which ensures that all of the values in a column satisfy certain conditions. Now, there could be a lot of cases where you'd want to specify one particular check, which would ensure that there is proper retrieval of data or proper storage of data. That is why you can use the check constraint. And then we finally have the index constraint, which helps us to create and retrieve data from the database very quickly. So we've got different indexes such as clustered indexes and non-clustered indexes, and with the help of these different indexes, we can make sure that the data retrieval is very, very easy and it's very fast. So those were the different constraints in SQL. Now let's go ahead and look at the different subsets of SQL. So these are the different subsets in SQL. We've got DDL, which stands for data definition language. Then we've got DML, which stands for data manipulation language. After that, we've got DCL, which stands for data control language. Going ahead, we've got TCL, which stands for transaction control language. So we'll work with all of these. And first, we'll start with the data definition language. That is stated over here. Data definition language is a primary mode of SQL queries where we are able to create objects for the database. So let's understand this database. So let's understand this data definition language in a more comprehensive way. So this data definition language comprises of all of these commands. So we've got the create command in DDL, which would help us to create objects in a database. So with the help of this, you can either create a database or create a table with SQL. And then you've got the alter command over here. So alter command is used to alter the structure of a database or database objects. Now, this would mean that wherever, let's say, you would want to change a particular row value or maybe change a particular column value, that is when you can use this alter command. Then you got the drop command, and drop command helps you to delete all the objects from a database. So let's say you have that same student table in your college database, and for some reason you would want to go ahead and delete that student table. So what you will do is you will use the drop command and you will remove that student table from your college database. Now, similar to the drop command, we also have the truncate command, which would help us to remove all of the records from a table permanently. Now, you need to understand the difference between a drop command and a truncate command. So when it comes to the drop command, you are deleting all of the values present in the table and you are also removing the table itself. But when it comes to the truncate command over here, you are only removing all of the data which is present in the table, but keeping the table intact. The table or the structure of the table remains as it is, but the data which is present inside the table is deleted. After that, we've got this rename command over here, which would help us to rename a particular table or maybe rename a particular column in the database. So these are the different commands which come under DDL. Now let's go ahead and perform our first SQL query for which all of you guys have been waiting for. So our first task would be to create this employees table over here, and to create a table the syntax would be this. So we'll use the keyword create and then we'll follow it up with the table command. After that, we'll give in the name of the table over here. So here we'll type in create table and the name of the table is employees. And we'll have this parenthesis over here, and inside this we'll give in the name of the column, and after that we will give in the data type of the column. So first we want the employee ID column, and this is of integer type, and the size or the length of the employee ID is 10. And after that we also have this not null constraint, which would ensure that we don't have any nulls in this particular column. Going ahead, we have the next column, which is first name over here, and the data type of this is varchar, and this is variable length characters. So we have a variable length size of 20 characters. After that, we have the last name column over here. Again, the data type is varchar, and we are setting the size to be equal to 20, and we are ensuring that all of the values are not null. And finally, we have the salary column, which again is of integer type, and this also is not null. So over here, apart from first name, we are ensuring that the rest of the columns, they have some sort of value inserted into them. And then finally, we are ensuring that this employee ID column, all of the records in this employee ID column are uniquely identified in the table with the help of this primary key command. So using primary key, and inside primary key, we are passing in this employee ID column. So let's go ahead and create our first table in MySQL. So guys, this is how MySQL Workbench looks like. Now I will go ahead and write down the command over here. So it will be create table, and after this I'll have to give in the name of the table. Now I'll give in the name of the table as employees, and I'll give in space over here, and after this I'd have to give in the name of the first column. So name of the first column would be, let's say, employee ID, and this is of integer type, and the size is, let's say, 10. Now after this I would have to give in a constraint which is not null. So I'm ensuring that a value is inserted in the employee ID column. So I'd have to put in a comma after this, and after this I have the first name column. So I will have first name over here, and this is of varchar type, and I am setting a length of 20 for this. And after this, I'll give in the next column, and the name of the next column would be last name. And I'll also set the varchar over here. I'll have give the size over here. So the size of this would be 20 again. And finally, I have one more column, which is the salary of the employee. So I'll just type in salary over here, and I'll give in the data type. So the data type again would be 10. So now that this is done, I would finally have to set the primary key. So I'll type primary key over here, and inside this I will pass in the employee ID column. So employee ID, all of this is set. I'll put a semicolon over here. Now let me select all of this and let me click on execute. So we see that we have successfully created a table over here. We see this action over here, right? So now that we have created this table, let's see how can we see the table which we have created right now. So I'll delete this, and to have access at the table, we have this command known as select query. So we'll just have a brief glance at the select query. We'll learn about this in detail later. So I'll type in select star from, and then I'll give in the name of the table which I want to have a glance at. So the name of the table is employees. I'll click on execute. So you see that we have successfully created this new table called as employees, which has all of these columns over here. Employee ID, first name, last name, and salary. So guys, we have successfully created a first table named as employees. So that was the create table command. Now let's go ahead and work with the next DDL command, which is the alter command. As I've told you, the alter command helps us to alter the table. So over here, I want to add a new column into my table over here. So apart from employee ID, first name, last name, and salary, I want to add a new column called as contact. And to do that, this would be the command. So I'll have the keywords alter table, and then I'll give in the name of the table, which is employees over here. So alter table employees. After that, if I want to add a new column, I'll type in add column, and then I'll give in the name of the column, which is contact. And since I've given a new column over here, again, it needs to have a data type. So I'll put in int, and the size of this is 10. So let's go ahead and alter our table and add in this new column. So I'll use alter table, and after this, I'll have to give in the name of the table. So alter table employees, and I would have to add a new column. So I'll type in add column. Now after this, I'll have to give in the name of the column. So the name of the column would be contact, and this is of integer type, and the size or the length of the contact would be 10. Right, so we have successfully added this new column. Let me just hit execute over here. Right, so we have added this. Now let me just go ahead and have a glance at my table again. So I'll type in select star from, I will give in the name of the table, which would be employees. So select star from employees. So as you see, initially we did not have this contact column. Now after using the alter table command, I was able to successfully add this new column. Now let's go ahead and have a glance at our next DDL command. So this time we've got the rename command over here. Let's say if I want to change the name of some column, then I can go ahead and use the rename command. So earlier we had created the contact column. Now instead of the contact name over here, I want to change this to job code. So this is where I can use the rename command. So rename is again part of the alter table syntax. So first we'll add alter table, and then we'll give in the name of the table, which is employees. So instead of adding add column, we'll have rename column over here. So alter table employees, rename column, and I'll give in the name of the column which has to be renamed. So contact and to. So contact would be renamed to job code. So let me go ahead and perform this in MySQL. Let me close this over here. Again, I'll use the alter command. So I'll type in alter command, and after this, I'd have to give in the name of the table. So the name of the table would be employees. So alter, so this is actually alter table, not alter command. So alter table employees, and then I would have to give in rename column, because that is what I'd want to do. And I'd want to rename the column contact to job code. So this is done. Let me hit execute, and this is also done. Now let me delete this and let me have a glance at the table again. So I'll type in select star from employees. Let me hit execute now. So as you see, this contact column, or the name of this contact column, has been successfully changed to job code. Right. And then we have this truncate command in DDL. As I've already told you during the theoretical part, this truncate command helps us to remove all of the data which is present inside a table. So the command is very simple. All we have to do is use truncate table employees, and whatever data is present inside this, we can successfully remove. Now we don't have any data inside the table, but still I'll go ahead and show you what happens when we use this truncate table command. So this is our table over here. I'll go ahead and type in truncate table, and after this I'd have to give in the name of the table, which is employees. I'll hit on execute. So you see that we have executed this truncate table employees, and message 0 rows affected because we haven't really added any data inside the employees table. Now let me type in select star from employees and let's see what is the result. So when I do this, I get the same thing over here because what this has done is removed all of the data from this table, but we did not have any data. And it also has made sure that the structure of the table remains intact. So this is what happens when you use the truncate command. Now a similar command to truncate is the drop command, which would not only remove all of the data present inside the table, but would also remove the table structure, or in other words, it would delete the complete table itself. So the command is drop table employees. The only difference in the syntax is, so when it comes to truncate, you will type in truncate table employees, and when it comes to drop, you will add in drop table employees. Now let me go ahead and add in the command. So here I'll add drop table, I'll have employees, and let's see what is the result now. So you see that this has been executed. Now let me have the command over here, select star from employees, and let's see what do we get. So as you see over here, table world.employees does not exist, and we get this message because we have actually deleted this employees table. Let me run this again and show you. Again, we get the same error because we have dropped this table. Now that we're done with DDL, let's head on to the second type of query language, which is data manipulation language. So as the name states, the data manipulation language would provide you certain commands which would help you to manipulate the data which is present inside your tables. So we've got these three commands in DML, which are insert, update, and delete. So let's start off with the first one over here. So the insert command would help you to insert data into a table. So as simple as that. Let's say you would want to add new records and new rows into the table, then you would want to use the insert command. Now, after you've inserted data into your table, you would want to update certain entries. Now, let's say you would have inserted wrong data. Let's say you would have given the name incorrectly, or maybe if it's the student data set, maybe if you have inserted the marks of the student incorrectly, then you can go ahead and update these values. And apart from insert and update, we also have the delete command in DML query. So delete helps us to either delete one record or a specified record, or maybe all of the records present inside the table. So these are the three commands which are present in DML. Now let's start off with the first one, which is the insert command. So this is the syntax to use the insert command. We'll start off by typing insert into. So these are the keywords. We'll type insert into, and then we will give in the name of the table over here, which is employees. So insert into employees, and then over here we'll give in round braces and list out the names of the columns. So these are the columns which we have in our employees table. We've got employee ID, first name, last name, and salary. And after that, I would give the keyword values, and again I will have this parenthesis, and inside that I'll give in the values. So 101 would go into employee ID, Steven would go into first name, King would be stored in last name, and 10,000 would be stored as the salary. So this is the first record which we have stored in this table. Similarly, we'll use the same command over here. We'll type in insert into, and then give him the name of the table, which is employees. After that, over here, we'll list out the names of the columns, and then we'll add values, and we'll list out all of the values. So this is the second record over here, 102 Edwin Thomas, and this is the salary of Edwin Thomas. And then similarly, we'll insert the third record into this employees table. So let's go ahead and work with this example. So we are back to MySQL Workbench. Let me just show you the table again. So I'll type in select star from, and the name of the table is employees. Let me hit execute. So this is our table over here, and these are all of the columns which we have. Now I'd want to go ahead and insert my first record inside this. So I'll type in the command over here, insert into, and then I'll have round braces, and after this I'd have to give in the names of the columns. So the first column is employee ID, second column is first name, and then I have a column name which is last name, and finally I have a column called salary. So I'd be inserting values inside all of these. So first the employee ID is, let's say, 1, and then the first name of the employee is Sam, and then I'd have to give in the last name. Now let's say the last name of the employee is Winchester, and salary of Sam Winchester is, let's say, $20,000. So I'll put a semicolon over here. Now, what I'll do is I'll just cut it out from over here and I'll paste it over here. Let me just copy it properly. I'll cut it out and I'll paste it at the bottom. Now, as you see, we have an error over here because we have not given the name of the table. So let me write in the name of the table. Now, obviously, if you want to insert records, we'd have to insert records into one particular table, isn't it? So over here, the name of the table is employees. So I'm typing out insert into employees. These are the names of the columns and these are the values which should go to the corresponding columns, and I will print out the result. So as you see, we have successfully inserted this record into this table. So we've got one over here, Sam as the first name, Winchester as the last name, and salary as this. Similarly, let me go ahead and add 2 more records. Now what I'll do is I'll make changes in this command itself. Now I'll change the employee ID to 2 and I'll change the first name to Dean, last name would be Winchester. And let's say since Dean Winchester is the elder brother, I'll give him a greater salary of $30,000. Now let me execute this. So we have 2 records inside this. And then I have the record number 3 and I'll name this guy as Matt and his surname is, let's say, Matt Devon and his salary is $40,000. Let me hit execute again. So I've got 3 records. Let me go ahead and add another record over here. Now I've got Julia and her surname is, let's say, Julia Aniston. Let me just add Aniston over here and her salary is maybe $90,000. And I'll just add one more record over here. I'll have the ID to be equal to 5 and I'll change the name to be Annie. And after this, I'll add a surname Hathaway and her salary is maybe $60,000 over here and I'll hit execute. So I've got 5 records successfully stored inside this. So now that we're done with the insert command, let's go ahead and work with the next command, which is the update command. As I've already told you, the update command is used to update certain entries in our table. So over here, I am updating the last name. So initially, let me check what was the last name over here. So this was Edwin Thomas. So this guy's last name was Thomas. Yes, it's actually the first record over here. So this guy's last name is King. So his entire name is Stephen King. And I want to change the last name from King to Cohen. So what I'll do is I will use the keyword update. And after that, I'll give him the name of the table, which is employees. So update employees. And then I'll write set. And then I will give in the column name, which I'd have to change over here. So last name over here and record I'd have to change. After that, I'll give in the where keyword and then I will give in that value, which is the corresponding value over here. So what is basically happening over here is, so where the employee ID is equal to 101, I will go there and update the last name. So this is what this command is saying. If you have any doubts, I'll just repeat it again. So we have to update one particular record, and to update that, I am using this where condition. So where the employee ID is equal to 101, I would have to update the last name from King to Cohen. So again, let's go to our MySQL Workbench and work with this. So I've got all of this ready over here. Let me remove this. I would just have to give in the update command. So I'll type in update and after this, I'd have to give in the name of the table. So update employees, I'd have to use the set keyword. And then let's say I would want to change the last name of Dean Winchester. So update employees, set last name is equal to, so I want to change the name from Winchester to maybe, let's say, Lucifer. So update employee set last name is equal to Lucifer, where his employee ID is equal to 2. So I'll set where employee ID is equal to 2. So we are updating this record and we are printing out the result. Now let me hit execute. Right. So initially this guy's name was Dean Winchester and I have successfully updated this record by using this update command. Now similarly, let's say if I want to update the salary of Julia Aniston over here. Let's go ahead and do that. So I'll use the same command, update employees, and I'd have to update the salary. So I'll set the salary over here. Set salary is equal to, so I want to change it from $90,000 to maybe $75,000 over here, where employee ID is actually, so employee ID would be equal to 4. I'd have to remove this. And let me hit on execute and let's see what is the result, right? So initially Julia Aniston's salary was $90,000 and I have reduced it to $75,000. So that was the update command. Now we can actually go ahead and delete certain records or delete certain values from our table. So this is the keyword. So we'll type in delete from, and then we'll given the name of the table, which is employees. After that, we'll use the where clause. Using the where clause, we will set which column or which record has to be deleted. So here the condition is delete from employees, where employee ID is in 101 and 103. So what will happen is wherever the employee ID is either 101 or 103, those two records would be deleted. So we'll use the same thing over here. So initially we've got these 5 records. So I'll type in delete and then I'll use the keyword from. After this, I'd have to give in the name of the table, which is employees. So delete from employees, where maybe let's say I don't want to delete the record number 4 over here. So I'll type in where employee ID is equal to 4. Now let's hit execute and let's see what is the result, right? So as you see, we have successfully deleted the 4th record. Now similarly, if I want to record the second record over here, so I'll type in delete from, and I'd have to give in the name of the table, which is employees, where now instead of using the employee ID, I can also use some other column. So I'll set last name is equal to Lucifer. So basically that record would be deleted where the last name is Lucifer. I'll hit execute. Let us see what is the result over here. Let me actually delete this out. Let me run this now. Seems like that is not run. Now let me add it again. Now let me hit execute. The name is Lucifer. Seems like we have an error over here. Delete from employees where last name is Lucifer. Let me cut this out and let me run this. Okay, so seems like over here I've given 3 is, which was the error over here. Now let me run this properly. Again, we have, you're using safe update mode and you try to update a table. Okay, so we'll have to change this from safe update mode to normal one. Only then we'll be able to delete this. So let me cut this out over here. Let me run this now. So you see this error over here. You are using safe update mode and you try to update a table without a where that uses a key column. Now this happens because this is a safe mode. So to remove this safe mode, you would have to go to edit and you would have to change these preferences over here. Now in the preferences, you will have the SQL editor, and over here you see this save updates, rejects updates and deletes with no restrictions. So uncheck this and now click on OK. So this time when you go ahead and try to delete this, this will work properly. So now let me go ahead and actually run this again. So now that we've removed this, we'd have to actually re-log in. So what I'll do is I'll close this up and then I'll log in again. So I have logged in again over here. Now let me go ahead and try to delete this and let's see what is the result. Right, so this time we see that we have successfully deleted this. Delete from employees where last name is equal to Lucifer. So when we are working with MySQL, you'd have to keep in mind that if the save update mode is on, you'd have to uncheck it and only then you'd be able to delete records from your table. Now similarly, let's say if I want to delete another record over here. So let's say if I want to delete this 5th record, now I can go ahead and do that. So what I'll do is I'll type delete from employees where I'll set the first name. So I'll set the first name to be equal to Annie. Let me just add in Annie over here. Let me hit on run. Right, so I have deleted this as well. So that was DML. Now let's go ahead and understand what is data control language. So with the help of data control language, we can basically control the user access to the database. Now, what do I mean by that? Now, whenever we're dealing with data, it is very important that we control which user has access to what part of data, or we have to make sure that only a few number of users or only the important users have access to the important data and other people don't have access to the important data. So this is where we have two commands inside DCL called as grant and revoke. So as it is stated over here, grant gives access privileges to the database and revoke withdraws access privileges given within the grant command. So what this basically means is, let's say if we have 10 users working on one particular database, then I want to make sure that only, let's say, the user number 1 and user number 2 get access to the database to particular records. And let's say if in that database I have a table called employee, and to that employee table I want only the user number 1, 2 and 3 to have access. So what I'll do is I will use this grant command and I will grant the privilege of this table to only these three users. So this is how the command will work. So I'll type in grant and this is the privilege list. So whatever privileges, maybe it's the number of records in the table or maybe the entire table or what tables in the entire database that has to be given access to a particular user, right? So this is the entire privilege list. So I'll type in grant privilege list on, and over here I'd given whatever table that the user needs to get access to. So grant privilege on relation name to, and here I'll give in the username or the user ID. So this is how I can grant a privilege of a particular table to a particular user. Now this is granting the access. Similarly, we can revoke the access. So what does revoke mean over here? Revoke basically means taking back the access or restricting a particular user to access particular data. So to remove access from a particular user, what we'll do is we'll type in revoke. And let's say if I want one particular user to not have access to the first three columns of the student table, then over here I'll give in the privilege list. On, I'll give in the table name to whatever user that is. Let's say if it is user number 10, I'll give in user number 10. So this is how I can make sure that I can grant access to a specified users and I can revoke access to specified users. And then we finally have something known as TCL, which is known as the transaction control language. And these are the three commands which come under transaction control language. So we've got commit, rollback, and save point. Now, before we go ahead and understand what exactly is transaction control language, let's understand what exactly is a transaction. So in simple terms, whatever action you perform, that is known as a transaction. Now, let's take a simple example over here. Let's say you go to a bank and you'd want to perform certain operation. So let's say if you want to withdraw money from the bank. So over here, withdrawing money from the bank is a particular transaction. Similarly, if you want to deposit money into the bank, that again is a transaction. And if you want to see balance, how much balance do you have, that again is a transaction which you are performing. Now, in certain cases, it happens that multiple transactions are going on at the same point of time. So this is where you'd have to ensure that the important transactions are committed. And let's say if you have made certain mistake, there's an option to go back to the transaction which you've made. So this is where we have commit, rollback, and save point. Now let's say if you have completed one transaction which is very important to you, and you want to make sure that this is saved properly. So what you do is you will use the commit command and this will save all of your work till now. All of your transactions which have been done till now would be committed. And similarly, we have the rollback command over here. Let's say you have made an incorrect transaction and you want to roll back to the earlier state. So this is where you can use the rollback command. And there'll be a lot of cases where for now you don't want to save the data, but you consider this to be an important point where you can maybe go back and see your data, what you're working on, or maybe go back and save that particular data. So at those points, you can name that as a save point. So these are the different commands which come under transaction control language. Now let's go ahead and work with the where clause. So many a times it happens that we'd want to extract records from the table on the basis of a condition. So this is where we'll use the where clause. As it is stated over here, where clause is used to specify a condition while fetching the data from a single table or by joining with multiple tables. And this where clause can be used not just with the select statement, but it can also be used with the update, delete statement and multiple other statements. Now, let's say from this entire employees table, I'd want to extract only that record where the employee ID is equal to 101. So this is where I can go ahead and use the where clause. So what I'll do is I'll type in select star from employees. Now if I just type in this will give me the entire table. So instead of getting the entire table, I'd want only that record where employee ID is equal to 101. So after the statement, I'll use the where keyword and follow it up with the column name and then give the condition over here. So I'll state select star from employees where employee ID is equal to 101. And from this entire table, I'm able to extract this particular row. So let me go ahead and show you the employees table again over here. So I'll type in select star from employees. I'll execute this. So this is our table. This has got 8 rows in total. We've got employee ID, first name, last name, salary, and gender. Now out of all of this, I'd want only that record where the employee ID is equal to 3. So after this, I'll type in where, and then given the name of the column, which is employee ID, I'll give in the condition. So this will be employee ID is equal to 3. I'll execute this, and we have successfully got the result. Now similarly, if I want to extract only that column where the employee ID is, let's say, equal to 5, I'll set 5 over here and let's see what is the result. So this is the employee ID 5 and the name of the person is Nicole Kidman. Now similarly, if I want to extract only that record where let's say the name of the employee is Annie. So over here, instead of giving the employee ID, I'll use the column name first name. So the first name of the employee is Annie. So I have extracted only that record where the first name of the employee is Annie. Now this where clause can be used in conjunction with multiple operators. So we've got the AND operator, OR operator, and the NOT operator. Now whenever we want to give multiple conditions, that is, I want to extract records on the basis of multiple conditions, that is when I can go ahead and use the AND, OR, and NOT operators. Right? So over here, we've got this example over here. So you need to understand how the AND and the OR operator works. So the AND operator gives you a true result when both of the operands are true. That is, whatever is present on the left side of the AND symbol and whatever is present on the right side of the AND symbol, if both of them are true, that is when you'll get a true result. So here, let's check this condition properly. So on the left side of the AND symbol, we have 5 is less than 2, which is false. And on the right side of the AND symbol, we've got 5 is greater than 3, which is true. So false and true would give you a false value. So you will get a true result only when both the operands on the left and right side of the AND operator are true. Now let's go to the OR operator. So when you're working with the OR operator, you will get a true result when either of the operands is true or both of the operands are true. So over here, we see that 5 is less than 2, which is false. After that, we'll type in or 5 is less than 3. 5 is greater than 3. So since 5 is greater than 3 is actually true, that is why we'll get a true result. And then we have the NOT operator. So NOT operator is basically opposite of true. So over here, we are checking if 5 is less than 2. So 5 is less than 2 will give you a false result. And NOT of false will give you true. So if you have a true, if you put in NOT in front of true, you will get a false. Similarly, if you put in a NOT in front of false, you'll get a true. Now, let's go ahead and work with these sample queries. So let's start with the AND operator. Now, from the entire employees table, I'd want only that record or only those records where, let's say, the first name is equal to Steven and salary is equal to 150 over here, right? Now, let's go ahead and work with the AND operator in MySQL Workbench. Let me remove all of this and let me just show you the original table over here. So this will be select star from employees. Now, out of this entire employees table, I'd want to extract only those records where salary is equal to or greater than $500,000 and gender is equal to female. So over here, after select star from employees, I'll give in the condition where So the first condition would be salary needs to be equal to or greater than $500,000. So I'll type in greater than or equal to, and this would be $500,000. After this, I'd have to use the AND operator and I'd have to set the gender. Now the gender needs to be equal to female. So I'll just type female over here. So I've given both of those conditions. Now let me hit execute. So on the entire table, we see that only Nicole Kidman and Angelina Jolie are two employees whose salary is equal to or greater than $500,000, and both of them are female. Now, similarly, we have an example for the OR operator over here. So we want all of those employees where either the first name is equal to Steven or salary is equal to here $15,000. So let's work with a similar example from over here. So I'll remove all of this and I'll just print out select star from employees, and this is what we have over here. So from this entire table, let's say I'd want only those records where the employee ID is an even number or gender is equal to female, right? So I'm repeating it again. Either I want only those records where the employee ID is even or gender is equal to female. So let me give you the condition. So for this, select star from employees where, and the condition would be employee ID %2 is equal to 0. Now, what I'm doing over here is employee ID %2 is equal to 0. So whatever value is present, I am dividing it by 2. And if I get the remainder 0, then it would mean that the value is equal to 0. Now let's say if I divide 1 with 2, I obviously wouldn't get the result 0. When I divide 2 with 2, I get the quotient 0. When I divide 4 with 2, I get the quotient 0. So this over here would give me the remainder 0. So whenever I get the remainder is equal to 0, that is when I'll use the employee ID %2 is equal to 0. So select star from employees where employee ID %2 is equal to 0. This is my first condition. And then I'll use the OR operator and then given the second condition. So the second condition over here would be equal to gender is equal to female. So let me just type in gender is equal to female, and now let me execute this. Right, so I have extracted those records first where employee ID is divisible by 2. So I've got 2, 4, 6, and 8. Now, apart from this, I've also got over here this record employee ID 1 because the gender is equal to female. So apart from 3 and 7, apart from employee ID 3 and employee ID 7, I've got the rest of the records. And then I've got the NOT operator. So as it is stated, we've got the opposite result when we are using the NOT operator. So let's work with the NOT operator over here. So what I want to do is I'd want to extract all of the female employees from this entire table. So I'll type select star from employees where gender is not equal to male. So instead of typing where gender is equal to female, I'm just typing the opposite where gender is not equal to male. And since we've got only two genders over here, male and female, I'll get the opposite result. Similarly, if I want to extract all of the male employees by using the NOT operator, I'll type in the select star from employees where gender is not equal to female. Right, so gender is not equal to female, and this is what I'll have over here. So those were the basic operators, and apart from this, we've also got the less than equal to, greater than equal to, all of these operators over here. So let's see an example of all of these first. So let's start with the greater than operator. Now let me remove all of this. Let me hit execute. Now from this entire table, let's say I want all of the employees where salary is greater than $400,000. So I'll type select star from employees where salary is greater than, I'll type in $400,000 and let's see what is the result. So I have only 3 records. So Nicole Kidman, Angelina Jolie, and Joey Leblo are the only 3 employees whose salary is greater than $400,000. Now this is greater than. So similar to the greater than operator, I have the greater than equal to. So When it came to the greater than operator, this value was exclusive. But when we use greater than equal to, this value would be inclusive. So let me hit execute. And as you see, even this record where the salary is exactly $400,000 has been included. So Charlie Sheen, salary is exactly $400,000. Now similarly, from the entire table, I'd want to extract all of those records where the salary is less than $300,000. So here I'm setting salary less than $300,000 and I've got 3 employees over here. Annie Hathaway, Brad Pitt and Charlie Harper. So these are 3 employees whose salary is less than $300,000. Now similarly, if I want only those records where salary is equal to or less than $300,000, we just have to put in the equal to operator over there, right? And we also have this record over here, Matt LeBlanc. So Matt LeBlanc salary is exactly $300,000. So these were some examples of all of these different operators. Now we'll work with some special operators. So we've got between, like, as null, in, and distinct. So let's start with the between operator. So the between operator would give you a result within a particular range. So it has to be between a particular range as it is stated over here. Now let's say I want all of those employees where the salary is between 10,000 and 20,000 as shown over here, right? So between this and this. Now you have to understand that both of these are inclusive. So when you type in salary between 10,000 and 20,000, this would mean that 10,000 is inclusive and also 20,000 is inclusive. So let's perform a similar command over here. Let me remove this and let me show you the original table first. So from this entire table, I'd want to extract only those records where the salary is between $200,000 and $500,000. So I'll type select star from employees where salary between, I'll type $200,000 and $500,000 over here. Right, so now let me hit execute and we've got these 4 results. So Brad Pitt's salary is $200,000, which is the lower limit. Nicole Kidman's salary is $500,000, which is the upper limit. And we've got these 2 over here, Matt LeBlanc and Charlie Sheen, whose salary is $300,000 and $400,000. Now, we've got the like operator, which checks an attribute value matches a given string pattern. So this would mean that if I want to extract something where it matches a particular string pattern, for example, from the entire table, I'd want to extract only those records where the first name is like Steven, right? So over here, I'm checking the string pattern. So in the first name, if the string pattern is like Steven, then I'll go ahead and extract all of those records. So let's perform a similar example over here. So initially I'll show you the result again. Now, as you see in this, I've got 2 Charlies over here, right? So I want to extract both of those Charlies from this entire table, and for this purpose, I can use the like operator. So I'll type select star from employees where first name like, and I'll give in Charlie. I'll put in a semicolon over here. Let me hit execute, right? And I've extracted these 2 records. I've got Charlie Sheen and I've got Charlie Harper. Now, similarly, let's say from this entire table, let's look at the last name over here. So let me see if there's a repeat anywhere. So I've got Matt LeBlanc and I've got Joey LeBlanc over here. Now let's say I want to extract both of these LeBlancs. So I'll type in select star from employees where I'll give in the last name like, and the last name needs to be like LeBlanc. So I'll type in LEBLANC. I'll hit execute and I've successfully extracted these 2 records. Now I'll show the entire result. So let's say if I want to extract all of those records where the first name starts with an A, right? So we can also do that. So I'm repeating it again. From all of these records, if I want to extract only those rows where the first name starts with an A. So I'll type in select star from employees where first name like, and I'll type a % symbol. This would mean that the first name would start with a and it will follow up with certain number of characters. So when I type in % over here, this would mean either a is followed by a single character or multiple characters. And this is our result. So we see that we've got two employees whose first name starts with A. We've got Annie Hathaway and we've got Angelina Jolie. Now, similarly, from this entire table, let's say I want to extract all of those records where the last name starts with H. So select star from employees where last name like, and over here I'll type in H % symbol. And that's why I've extracted all of those records where the last name starts with H. So I've got Anne Hathaway and I've got Charlie Harper. So that was the like operator, and then we've got the is null operator, which helps us to extract all of those records where we have a null. But unfortunately, right now, the present table which we're working with, there are no null records. So this is not really of much use for us. And then we've got the in operator over here. So in operator helps us to check an attribute value, and if it matches with any value within a value list. So let's say from this entire employee table, I'd want to extract only those records where salary lies in 10,000, 12,000 or 20,000, right? So basically we have a list, and if I want to extract from that particular list, I can use this in operator. So select star from employees where, let me actually show the original table again. So I've got this. So select star from employees where, let's say I want the salary to be in $200,000 and let's say $500,000, and I've got $700,000 as well. So from this entire table, I'd want to extract only those records where salary lies in these three values. So I've extracted these three records. I've got Brad Pitt, Nicole Kidman, and Joey Leblanc, whose salary lies in $200,000, $500,000, and $700,000. And after that, we've got the distinct operator, which helps us to extract unique values from a particular table. So when I type in select distinct first name from employees, this would give me all of those records where the first name is distinct. So let me again show you the original table. And in the original table, as you would notice, we have Charlie 2 times. Now I want only the unique first names from this entire table. So I'll type in select star from employees. And I'll type distinct first name. And let me put in a semicolon over here. So this is actually the incorrect syntax. So we'd have to type select, and then after this I'd have to give in the distinct keyword over here. So I'll type in select distinct, and inside distinct I would give in the name of the column. So the name of the column would be first name. So select distinct first name from, I'd have to give in the name of the table, which would be employees. So select distinct of first name from employees, and we see that we've got this result. So even though Charlie was present twice, we've got the unique values, and we see that in this result, we've got Charlie only once. So after this, we'll go ahead and work with some SQL functions. So these are the basic functions which SQL provides us. We've got the average, count, max, min, and sum. Let's say if I want to find out the average value of some numeric column, then I can use this average function. So let's say if I want to find out the average salary of all the employees, then I'll type in select average of salary from employees. So let me perform this command. So I'll type in select, and then I'll give in the function average. So select average of salary from, and then I'll give in the name of the table, which would be employees. So I'll get the result over here. So we see that the average salary of all the employees is around $351,250. Now, similarly, if I want to find out the maximum and minimum values, Over here, instead of average, I'll just put in min, max. So select minimum salary from employees will give me the minimum salary, and select maximum of salary from employees would give me the maximum salary. So over here, all I'll do is I'll change this and I'll put in min over here. So select minimum of salary from employees. So we see that minimum salary is $10,000. Similarly, if I want the maximum salary, I'll type select maximum of salary from employees, and we see that the maximum salary is $700,000. And after this, we've got sum over here, which returns the sum of specified column values. Now, if I have numeric values and if I want to find out the sum of all of the records in that column, then I can use the sum aggregate function. So over here, instead of max, I'll just put in sum, select sum of salary from employees, and this is the sum of all of the salaries of all the employees. And then we've finally got the count aggregate function over here. So over here, let's say if I want to find out the total number of rows or the total number of records from the table, then I can use the count star example. So I'll just type in select count of star from employees, and that would give me the total number of records from this table. So I'll just delete this from over here and I'll type in select count of star from employees, and I'll hit execute, and we see that there are 8 records in total. Now let's go ahead and work with a group by clause. Now many a times it happens that whenever we are dealing with tabular data, there are some data, or there is some sort of data which is similar to each other. Now let's say we are working with the student table or the teacher table in the college database. Now from this entire student table, there would be some students who would belong to one particular department, and there would be some students who would belong to some other department. So let's say there are 4 departments in total. You have computer science, you have chemical engineering, you have mechanical engineering, and you have electronics engineering. Now out of all of these, we can place some students under computer science, some students under mechanical, some students under chemical, and similarly the rest of the students into electronics. Now this over here, what we're doing is we are placing students who are in one particular department into one group. So this is where, let's say if we want to extract the marks of all of the students who belong to one particular department, then we need the group by clause. Right? Again, similarly, let's say if we take the employee database or the employee table over here, then different employees would be working in different teams or different departments. Now, let's say there are teams such as marketing, content, tech, sales, and so on. So out of all of these, let's say if we want to find out the average salary with respect to each of these departments. Now, let's say I'd want to find out the average salary with respect to the tech department, with respect to the marketing department, with respect to the sales department, and so on. Again, what I'd have to do over here is group the data with respect to that department and find out the average salary of that particular department. So this is where we'd require the group by clause. Now, as it is stated over here, the group by clause, the group by keyword is followed after the where clause if the where clause is present in a select statement, and it is preceded by the order by clause, again if the order by clause is used. Now let's say from this entire table, I'd want to find out the sum of salary with respect to department where the salary of the employees or each of the employees is greater than 15,000, right? Now, if we take these 3 departments over here, so we've got department ID 10, 11, and 12. Now over here, if you take department number 11 and department number 12, you see that the salary is greater than 15,000. But when it comes to department ID 10, the salary is actually less than $15,000. So that is why what you'll do is you will ignore this department ID 10 and you will only find out the sum of salary of department number 11 and department number 12. So when you sum the salary of department number 11, you only have one record. So that is why you have 15,000 over here. Similarly, when it comes to department number 12, when you add 10,000 and 20,000, that becomes 30,000. So this is how, if you want to find out some information with respect to one particular group or one particular department, you can go ahead and use the group by clause. Now let's go to MySQL and work with the group by clause. So this is our employees table over here. Now what we'll do is we'll go ahead and add a new column into this table, and we'll name that column as department. So to add a new column, we'd have to use the alter command. So I'll type in alter table, and then I'll give in the name of the table, which is employees. And after this, I'll type in add column, and the name of the column would be DEPT. And after this, I'd have to give in the data type of this column. So let's say this is of variable length character, and the size is of 20. So we have successfully added this new column. Now let me have a glance at the modified table. So I'll type in select star from employees over here, and now this is our modified table. So we have successfully added this new column. Now I'd have to add the department in which each of this employee works. So for that, I'd have to update the table. So I'll use the update keyword, and then I'd have to give in the name of the table. So update employees, and then I'd have to use the set keyword, update employees set. And then I'd have to, let's say, update the value of department over here. So I'll set department is equal to, let's say Annie works in support. So I'll add support, and over here, update employee set department is equal to support, where employee ID is equal to 1. Now, after this, I'll just have a glance at the table. So I'll type in select star from employees. Now let me hit execute, and let's see what happens. Right, so we have successfully added the department for Annie. Similarly, I'd want to set the department for Brad. Let's say Brad works in content. So I'll add content over here, and the employee ID is 2. So this has been changed as well. Now I'd have to change the department for Matt, and Matt works in tech. So department is tech, and employee ID is 3 over here. This is also done, and then going ahead, I'd have to do it for the rest of the record. So after this, let's say I've got Charlie, and Charlie works in sales. I'll just add sales over here, and the employee ID is 4. Going ahead, I've got Nicole, and Nicole works in content, and the employee ID for Nicole is 5. This is also set. And then I've got Angelina, and Angelina works in tech again. So I'll add tech over here, and the employee ID for Angelina is 6. And going ahead, I've got 2 more records left. So I've got Charlie Harper left, and Charlie Harper, let's say, works in marketing. So I'll add marketing over here, and the employee ID for Charlie Harper is 7. And then I'm just left with 1 employee, who is Joey LeBlanc, and Joey LeBlanc works in the tech department. So I'll add tech, and the employee ID for Joey LeBlanc is 8. So we have successfully added all of the departments for all of the employees. And now I'll remove this, and it's time to use the group by clause. Now let's say from this new table which we've just created, I'd want to find out the average salary with respect to each of the departments. So I would have to type in select, and since I want the average salary, I'll use average over here, select average of salary. And since I want this average salary with respect to department, I'd also want to see the department over here, select average of salary, department from employees. After this, I'd have to use the where clause, select average of salary, department from employees, and I don't need the where clause. And after this, I'd have to use the group by clause over here. So I'll type in group by department. Now let me hit execute, and let's see what do we get. Right, so we have the average salary with respect to each of the departments. So we see that the average salary in support is 100,000, in content it is 350,000, in tech it is 533,000, in sales it is 400,000, and in marketing it just seems that the salary is the lowest, which is only $10,000. Now similarly, let's say if I want the average salary with respect to gender, then I can do the same thing. So I'll type in select average of salary, and instead of giving department over here, I'll type in gender from employees, and this time I will group the table with respect to gender over here instead of department, and let me hit execute. So we see that the average salary of female employees is $400,000, and the average salary of male employees is $322,000. Now let's say if I want to find out the maximum salary instead of average salary. Now let's see. So maximum salary with respect to gender. Now let's see if there's any change. So this time we see that the maximum salary with respect to gender. So we see that there is one male employee whose salary is $700,000 and there is one female employee whose salary is $600,000. Now similarly, let's say if I want to find out the maximum salary with respect to department, and over here I'll go ahead and use group by with respect to department. Let's see what difference we would get. So we see that the maximum salary which an employee gets is in tech department over here, right? So in the earlier command, we had seen that one male employee had a salary of $700,000 and it seems that that employee works in the tech department. And after that, again, it seems that the lowest salary is in the marketing department. So it seems like there is one employee and his salary is $10,000. And then in content, we've got someone who earns around $500,000. So this is how we can work with the group by clause. And after group by, we have the having clause. Now, the having clause is used to put up a condition with respect to aggregate functions. Now, normally when we want to use conditions or when we want to extract records on the basis of a conditions, we would use the where clause. But if we want to extract records on the basis of a condition, but that condition is with respect to an aggregate function, then you can't use the where clause. And this is where you would have to use the having clause. So let's understand this command with respect to the having clause over here. Now, let's say we have this entire table over here. Now, from this entire table, I'd want the average salary, where the average salary is greater than $10,000. And this average salary is with respect to department. And I want this only where the count of department ID is greater than or equal to 2. This means that there are at least 2 employees, 2 or more than 2 employees in that department. So in that case, we see that only department ID number 12, right? So where the department ID is 12, only this is the case where we have at least 2 employees in the department. So we have this employee ID, which is 103 and employee ID, which is 100. Now we have this department, and from this department, we'd have to find the average salary. So we have the total salary to be 30,000, and when you do 30,000 by 2, you get an average salary of $15,000. So this is how you can use the having clause and put up a condition with respect to the aggregate methods. Now again, let me show you my table over here. So I'll type in select star from, and then I'll give in the name of the table, which is employee over here. So select star from employees. Now similarly, let's say I'd want to find out the average salary with respect to only those departments where there are at least 2 or more than 2 employees. So what I'll do is I'll type in select average of salary, and I'd also want to have a glance at the department. So select average of salary department from employees, and I'd have to group this with respect to department. So I'll use group by department. After this, I'll use the having clause and I'll give the condition. So having, and as you see, I'm giving the condition where the condition is based on an aggregate function. So having count of department is greater than or equal to 2. So let's have a look at this table. So we see that there are only 2 departments. So the first department is content, where there are 2 employees, and then the next department is tech, where there are 3 employees. So let me run this, and as you see, the average salary with respect to content is $350,000 and average salary with respect to tech is $533,000. And we've got result with respect to only these 2 departments because there are at least 2 employees in only these departments. Now let's go ahead and work with the order by clause. So order by clause is used to arrange our table in either ascending order or descending order. And by default, whenever we use the order by clause, we sort it in ascending order. And if we have to sort it in reverse order, then we'd have to use DESE over here. So let's say we have this particular table over here, and if we want to arrange this table in ascending order, I'd have to type in select star from employees. After that, I'll use the order by keyword. So I'd want to order this table with respect to the salary column. And if I want to order this in descending order, I'll use the keyword DESC. Now let's do the similar thing over here. So let me first have a glance at the original table. So I'll type in select star from employees and let me hit run. So this is our table. Now let's say I want to arrange this table with respect to the descending order of salary. So I'll type in select star from employees and I'll type in order by. I'd have to give in the column by which I'd want to order. So I'd want to order this table with respect to the salary column. And I'd want to order this in descending order. So I'll just add DESC. Now let me hit execute. And as we see, we have ordered this table in descending order. So the first record which you see has the maximum salary and the last record which you see has the minimum salary. Now we'll work with some set operators in SQL. So the first set operator which we'll be working with is the SQL union. So this is used to combine the result set of two or more select statements, and the final result set would have the result without any duplicates. So what this basically means is, let's say if we have two select statements, and with the help of two select statements, let's say with the help of the first select statement, we'd get 3 records. And with the help of the second select statement, we'll get 4 records. Now what we'll do is, we'll find out the result set of the first 3 records and the second 4 records from these two select statements. And if there are any duplicate records, they'll be removed. And what happens with this is each select statement within the union must have the same number of columns. So let's say if with the first select statement you are using 3 columns, then it is necessary that the second select statement should also have 3 columns. It cannot be less than 3 or more than 3. It should be exactly 3 columns. And also you must make sure that whatever data types of the columns you are using in both the select statements, they must be same. So let's say if in the first select statement, the first column is of integer type and the second column is of varchar type, then you must make sure that it is the same in the second select statement as well. That is, in the second select statement, the first column needs to be of integer type and the second column needs to be of varchar type. So as it is stated over here, you can also use more than 2 queries and you can club them using more than one union statement. So if all of this theory is too much complicated for you, let's understand that with the help of this example. So over here we have 2 tables. So the name of the first table is product 1 and the name of the second table is product 2. And in these 2 tables, we have the same column. So in product 1, we have category ID and product name. Similarly, in product 2, we have category ID and product name. Now, what we are doing is with the first select statement over here, we are selecting the product name column from this product 1 table. Similarly, from this select statement, with the help of this select statement, we are selecting this product name column from the product 2 table. So this select statement would return us Nokia, Samsung, HP and Nikon. And similarly, this select statement would return all of these values from this table. Now, when you use the union operator in between these two, this will give us the result set of both of the select statements. So that would mean whatever common values are there, those will be removed. So from this, we'll get Nokia, Samsung, HP and Nikon. And from this, whatever extra are there. So LG, Dell, Apple and PlayStation. So these are the ones which are not present in product 1, right? So basically when we use the union operator, we'll get the result set of both of the select statements. So let's go to MySQL and implement the union operator. So my first task over here would be to create those 2 tables. So I'll type in create table and the name of the first table is product 1. And inside this, so the category it is let's say category ID. This is the name of the first column, and then I'll have to give in the name of the second column, which would be product name. And this is of integer type. And let's say the length is 10. Similarly, product name, this is of varchar type and this is of length 20. So let me go ahead and create the table. So we have successfully created this table. Now let me have a glance at what I've just created. So I'll type in select star from product 1. So we see that we have the structure of the table over here ready. Now it's time to insert the values. So I'll just type in insert into product 1, and over here I'd have to give in the names of the columns. So the name of the first column would be category, and I'd have to give in ID over here. So I'll just type in underscore ID, and then I'd have to give in the name of the second column, which would be product name. And after this, I just have to type in values and give in the values over here. So I'll give in 1, and then let's say the first product is Nokia. So let me just type in Nokia over here. Let me cut this and paste it below the insert statement. Right, so we have successfully inserted the first record. Now, similarly, let me go ahead and add other records as well. So I'll type in 2, and then over here, I'll add Samsung. And after this, I'll go ahead and insert a record, and that would be HP. So let me just add HP over here. And after HP, I would have at category ID 6, this would be Nikon. So let me just add Nikon over here. So this is my product 1 table. Now, similarly, I'd have to go ahead and create product 2 table. So I'll type in create table product 2, and inside this, the name of the column would be the same, which would be category ID, and this is of integer type. Size is 10, and then I'd have to give in the name of the second column, which would be product name, and this is of varchar type again, and since there's a variable length character, the length would be 20. Let me execute this over here. So we have created this table, and now let me have a glance at product 2. So select star from product 2, and this is our product 2 over here. Now it's time to insert values into product 2. So I'll type in, let me actually cut this over here, and I'll type in insert into product 2. So the names of the columns are same. Now I'll have to go ahead and insert the values. So category 1 in product 2 would be Samsung. So let me just type in Samsung over here. We've got this set, and then category 2 would be LG. Let me type in LG. Then we've got HP at category number 3. So let me also add HP over here. Then at row number 5 or category number 5, we've got Dell. This is also set. Then at category ID 6, I've got Apple. So let me remove this, and I'll also add Apple over here. I'll hit on execute, and then going ahead, I'll add the final record, which would be category ID 10, and this is a PlayStation. So let me just add PlayStation over here. I need to put a comma after this. Now we have created product 1 and product 2 tables. Now it's time to extract the records which are common in product 1 and product 2. So I'll type in select product name from, and then the name of the table is product 1. After this, I'll use the union operator, and I'll use select product name from, and then this would be, let me get the spelling properly over here. So this would become product 2. I'll hit on execute. And so this is the final result over here. So this is the result set of both of these select statements. Now, similar to the union operator, we've got the union all operator. So this is used to combine the results of two select statements, including duplicate rows. So this is the only difference between union and union all operators. So when it comes to the union operator, the duplicates are not included. And when it comes to the union all operator, the duplicates are included. And as it is stated over here, the same rules that apply to the union clause will also apply to the union all operator. And this is the syntax for union all operator. So you will first give in the select statement. You'll list out the columns which you would want to extract from table 1. After that, you will give in the keyword union all, and you will give in the second select statement and list out the same set of columns in the same order from table 2. So if you see over here, we've got product 1 and product 2. These are the same tables, and when you apply the union all operator on these two tables, this is what we get. So this is the result from first select statement. So we have Nokia, Samsung, HP and Nikon. And after that, from the second select statement, we have this Samsung, LG, HP, Dell, Apple, and PlayStation. So as you see over here, the duplicate values are also included. So Samsung over here comes 2 times. So as you see over here, Samsung comes over here 2 times. Now let me just change this from union to union all, and let me hit on run, and let's see the result. Let me increase the size of this over here. So as you see, we have Nokia, Samsung, HP, and Nikon, and we also have the duplicates from the second table. Now we'll understand the concept of joins in structured query language. So many times it happens that we want to combine different tables into one single table so that we may have a glance at all of the records at one single place. So if we take that example of the college database, and let's say if we have the student table and the teacher table inside that college database. Now there'd be some properties which we'd want to see from the student table and also from the teacher table at the same point. So let's say if we want to see which teachers teach to some particular students or which teachers teach to some particular department. Now, if that is the case, then we'd want to combine the teacher table and the student table into one single table so that we may have more information at the same time. So this is where we can use the joins in SQL. So another similar example would be, let's say if we have the company table or the company database, and inside the company database, we would have the employees table and the departments table. Now, there'd be some situations where we'd want to see the employees table, the information in the employees table and the information in the departments table at the same time. So again, the best option would be to combine these two tables into one single table and have all of the information in that table. Now, for that purpose, we have different joins in SQL. So we have inner join, left join, right join, full outer join, and a lot more. So let's understand all of them. So what does a join actually do? Let's understand that first. That is stated over here. With the help of joins, we can combine rows and columns from 2 or more tables based on a related column between them in a database. So what this basically means is, let's say if we have a table A and table B, then what we are doing is we are trying to combine the rows or columns from table A and table B on the basis of a common column which is present in both table A and table B. So this is one important information which you guys have to note over here, guys, right? So there has to be at least one common column between table A and table B. Only then you'd be able to apply these joins on these two tables. So first, let's go ahead and understand inner join. Now, for inner join, we would need two tables, absolutely, table A and table B. And what happens in inner join is this returns when there is a match in both tables. This would mean that, let's say if we are trying to combine table A and table B on the basis of a condition, then this would return all of those rows wherever the condition is satisfied or wherever there is a match, right? So let's say if there are 10 records in table A and 15 records in table B, and out of those 10 and 15 records, let's say 5 records match, and now on the basis of that condition, you will only get those 5 records which satisfy the condition between table A and table B. So this is known as inner join, which only return the matched records. And after inner join, we have something known as the left join. So in left join, we get all of the records from table A, irrespective of whether the condition is satisfied or not, right? So we get all of the records from table A or from the left table, and only the matched records from table B or from the right table. And when it comes to the right join, it's exactly opposite of the left join. So in right join, we get all of the records from the right table or from table B, and only the matched records from the left side of the table or the table A. Now going ahead, we have something known as the full outer join. So full outer join would give you all of the records from table A as well as all of the records from table B. And then we finally have the self join over here. So self join is used to join a table with itself. So now the question which arises over here is, how can you actually join a table with itself? So you just rename the table as something else. You have a temporary table. So as it is stated over here, self join is used to join a table to itself as if the table were two tables. temporarily renaming at least one table in the SQL statement. Now let's say if you have a table called as A, what you do is you try to join A with A itself, but then again you rename A as something else. And then we have the last join, which is known as the Cartesian join or the cross join. So this cross join returns the Cartesian product of the sets of records in these tables. So this would mean that if there are 3 records in table A and 4 records in table B, and if you apply the cross join on these two tables, then the final table would have 12 records in it. This would be because 3 into 4 would give you the Cartesian product, which is 12, and the final result would have 12 records in it. Now let's start off with the first one, which is inner join. As I've already told you, inner join would give you all of the common records or all of the match records in table A and table B. And this is the syntax to apply inner join on two tables. So first we'll start with the select keyword. After giving the select keyword, we will give in the set of columns which we'd want to extract. So let's say if we want to extract column 1 from table 1, we'll first give in the name of the table, we'll use the dot operator and then give in the column name. Similarly, if we want the column 2 from table 2, then we'll give in the name of the table, we'll give in the dot operator and then we'll give in the name of the column from this table. Similarly, we'll give all of the columns from all of the tables which you'd want. So let's say if I want column n from table 1, I'll give in table 1 dot col n. So once I've listed all of the columns which I want from table 1 and table 2, after that I'll give in the from keyword and give the name of table 1 or the left table. And I'll give in keywords inner, join, and I'll give the name of the second table or the right table. Now once all of this is done, I'll use the keyword on and then give the condition on the basis of which I'd want to join these two tables. So over here, the condition is table1.common field needs to be equal to table2.common field. That is, wherever the records in this column of table 1 is equal to wherever the records of this column in table 2 are equal, all of those records I'd want to extract. So let's go ahead and apply this concept of inner join in MySQL. So let me go back. So initially we had the employees table over here. So let me just show you guys that employees table. So select star from employees and this is our employees table. Now to apply all of the different joins which you have just seen, I would need one more table. So for that I need the department table. I'll go ahead and create the department table for that purpose. So I'll type in create department and inside this I need certain columns. So first, let's say I would need the department ID column. So over here, I'll type in department ID and this is of integer type and the length is 10. And then I would need the department column, which is the common column over here. So I have the department column in the employees table as well. So this would be my common column. I'll set varchar of 20. And then after this, I'd have maybe the department location column. And again, this would be of type varchar and I'll set 20 to this. So this is how I am able to create this table called as department. So seems like we have an error over here. So create and after this, I'd have to type in table. So this was the error. Now I'll type in select star from department. Let me hit execute and let's see what do we get. So we see that we have successfully created this table called as department. Now it's time to insert values into this table. So let me go ahead and insert some values. So for that, I'd have to use the insert command. So I'll type in insert into, have to give in the name of the table, which is department. And then I'd have to set the column names over here. So this would be department ID. After department ID, I just have department and then I have the department location. And I'll go ahead and set the values. So let's say the first department ID is 1 and the department is content and the content department, let's say, resides in Chicago. Now let me cut this and let me paste it over here. Let's see what is the result. So we have successfully created our first department. Now I'll go ahead and create my second department over here, which would be support. So department ID is 2 and name of the department is support. And let's say support department is in New Jersey. So let me just change this to New Jersey over here. This is also set. Now I'll go ahead and create the third department, which would be sales. So I'll add sales over here. And after this, let's say the sales department sits in Boston. I'll add Boston over here. I've got this to ready and I'll go ahead and add 2 more records. Now let's say the fourth department is the HR department and I'll add HR over here. And let's say also the HR department sits in Chicago. And then I'll add 1 more department, which would be operations. So I'll set the ID to be equal to 5 and I'll add operations over here. And operations is in New York. So let me just add New York over here. And my department table is finally ready. Now that I have both of these tables ready, I would want to apply the inner join on this. So I'd want, since I'm applying the inner join on these 2 tables, I'd want only those records where the department is common in the employees table and as well as the department table. So let me go ahead and write the command for that. First, I'd have to give in the select keyword and then I'd have to list out all of the columns which I'd want from the employee table. So first I'll use the alias. So I'll type in E dot. And after this, let's say I would want the first name from the employee table. I would also need the last name from the employees table. So I'll add E dot, let me add last name. And apart from this, let's say I'd want the department name and the department location columns from the department table. So I'll type in d.dept and I would also need d.dept location. So these are the 4 columns which I'd want from both of these tables. And after this, I'd have to give in the from keyword and give in the name of the first table, which is employees, and I'll set the alias E. So this E, what you see is basically I am extracting the first name and the last name columns from the employees table. So this is the alias which I've given to the employees table. And after this, since I'm applying inner join, let me just add inner join over here. And I'd have to give in the name of the right table, which is department. And I'd have to give in the alias for department, which is D over here, right? So I'm extracting the department name column and the department location column from this department table. And after that, I'll finally give in the keyword on and I'd have to set in the condition. So the condition would be E dot DEPT is equal to D dot DEPT. That is, the department name column needs to be same in both of those tables. Or in other words, wherever these records are common in the department table and the employees table, I would want only those records. So let me go ahead and execute this. And this is our result. Now let me just elongate this and this is what we have. So it seems that the common departments are support, content, sales. And again, we have content over here. So it seems like these are the only common departments over here. And with respect to this, I have extracted these people. So Anne, Brad, Charlie, and Nicole. So these are the people which basically occur in the same departments. Now, just to be sure, I'll also have select star from, and then let me give in the department table over here. Select star from department. Let me run this, right? So as you see, we have the content, support, these 2 departments over here. Now let me run this. And I've got content, support, and sales. Right, so these are the 3 departments. Content, support, and sales are the 3 departments which are common in both these tables. So we have applied this inner join. Now it's time to work with the left join. So as it is stated over here, when we apply left join, we get all the records from the left table and only the matched records from the right table. And wherever there is no match, we will put in null values in the right side. And the syntax is pretty much the same. First, we'll give in the select keyword, and after that, we will list out the set of columns which we'd want to extract from table 1 and table 2. After that, we'll give in the from keyword and give the name of table 1, and then we'll type left join and then give the label of table 2. After that, we'll type on and then give in the condition on the basis of which we'd have to join these two tables. So this is our example of left join over here. Let's say we have this employees table and this department table over here, and I'm applying this left join, and the condition is wherever the department ID is common between these two. So over here, let's say I've got 10, 11, 12, I've got 10, 11, 13, and 14. Now, since this is left join, I'd get all of the records from this left table. So that is why, as you see over here, I've got Harry, Edwin, Steven, and Eric. All of these are there. And from the right side of the table, let's say wherever this is not present. So 12, wherever 12 is not present, I get null value. So the ID is 103 and 100. So as you see over here, 103 and 100. So as these two employees or these two records are not present in the department table, I have a null value over here. And wherever the records are common, obviously I get the records from both the tables. So let's go ahead and apply a similar operation on the employees table and the department table in MySQL. Now, obviously the command would be select, and I'll type in E. I'd want the first name, and after the first name, I'd want the salary. So select E dot first name, and I'll type E dot salary, and from the department table, I'd want DEPT, which is the department name, and I'd want the department location. So I'll type D.DEPT underscore location. So this is actually LOC. Now that I've given the list of all of the columns which I'd want to extract, I just have to give in the from keyword, and I'd have to give in the name of the first table, which is employees, and the alias is E. Now that this is done, I'd have to give the left join, because that is what I'd want to apply on these two tables. I'll type left join, and I will give in the name of the second table, which is department, and I'll give in the alias, which is D. After that, I'd have to give in the on keyword, and I'd have to set in the condition. So the condition is wherever these columns are equal, or the records in the department column are equal. So this would be E.DEPT is equal to D.DEPT. I'll put a semicolon and let me hit run, and this is what we have. So 1, 2, 3, and 4. So these 4 records which you see, so these 4 records are where the condition is satisfied. That is where the department is common in the employees table as well as the department table. Now these records, the rest of the records which you see, these are part of the left table. But since this department, whatever department these guys belong to, that department is not present in the department table. That is why we have a null over here for the last 4 values. So I'll repeat it again. So for the first 4 values, the condition is satisfied. And for the last 4 values, the condition is not satisfied. And since this is the left join, that is why we have all of the records from the left table, and we have the null values from the right table over here. Now after that, we have the right join. So the right join is exactly opposite to the left join. So in right join, we would have all of the records returned from the right table, but only the match records in the left table. And this is the syntax. So again, we'll type select, we'll list down all of the columns from table 1 and table 2. From table 1, right join table 2 on, and then we'll give in the condition on the basis of which we'd have to join these 2 tables. And over here, we've got the employee table over here, department table over here. And I want to join these 2 tables on the basis of where the department ID is equal. And since this is the right join, I am getting all of the records from the right table over here, as you see. And wherever this is not satisfied, right, wherever the department ID is not equal, there I am getting the null values over here. So I have 10, 11, 13, and 14. So as you see, 13 and 14 is not present over here. So this is resources and shipping. So these 2 records, wherever are there. So for these 2, I have null values from the left side of the table. So I'll delete this and let me write the command for this as well. So I've got the employees table and as well as the department table ready. First, I'd have to type in select. and I'd have to list down the set of columns. So let's say now instead of the first name, I'd want the last name. So I'll type in e dot last name. And from the department table, I'd want the department and I'd want the department ID. So I'll type in d dot dept ID. These are all of the columns which I'd want. And let's say I'd also want the gender over here along with this. So I'll type in e dot gender. After that, I'll put in from and then the name of the first table, which would be employees, the alias. Once I give the alias, I'd have to type in right join because that is what I want. And then the name of the second table or the right table, which is department. Now that this is done, I'd have to give in the on keyword and set the condition, which is e dot dept should be equal to d dot dept. I'll put in a semicolon, let me hit run, and this is what we have over here. So this is right join, and as you see from the left side of the table, I've got last name and gender, and from the right side of the table, I've got department and department ID. And since this is right join, I've got all of the records from the right side of the table. And where the department condition is not satisfied, I have got null values. So HR department and operations department is not present in the employee table. And that is why I have null value over here. And then finally, I've got the full outer join, which combines the results of both left and right outer joins. So the join table will contain all the records from both the tables, and wherever the match is not there, we will be returned with nulls. And this is the syntax. So as we are combining the results of both left and right outer joins in full outer join, what we'll do is we will first use the syntax for left join, and we'll use the union operator and we'll union it with the results of the right join, right? So we had earlier learned the concept of union. So what we'll do is we'll just use this union operator between the left join and the right join, as this combines the results of both the left join and the right join. So again, we've got this table over here. This is the employees table and this is the department table over here. So first we will give in the entire syntax for the left join. After that, we'll put in the union operator and then we'll put in the entire syntax for the right join. Now, as you see, this is the resultant. So first, since we've put in the left join, we've got all of these 4 records from the left join. And since there is not satisfied over here, so we have null. And after the union operator, we've got the right join. So we've got these 2 records from the right join. And since these 2 departments are not there, we have the null value. So let's go ahead and put in the condition. So let's say for this, I'd want everything. So e dot last name is already set. So I'd want e dot first name. So let me put in e dot first name, e dot last name, e dot gender, and I'd also want salary for this. So I will just write e dot salary, and from the department table, I'd want the department name, the department location, and the department ID, all of these. So basically, I'm extracting all of the columns from the employees table as well as the department table. So first, I will give in left join over here. Now, once I give in left join and the condition over here, I'd have to use the union operator. And I will select the same command over here. I will paste it over here. And in the second half of the command, instead of using left join, I'll just keep it as right join. Now let me remove the semicolon and I'll put it at the end of the command. Now let me hit execute and let's see the result. So it seems like we have an error over here. So we don't have a department called DLog. So this is actually DEPT-LOC. Let me change it to DEPT-LOC and let me hit run. And this is our result. So this is how full outer join looks like. So as you see, first we have applied the full join. First we have applied the left join. That is why we have all the records which are common in these 2. So the content department and support and sales are common in these 2. And after that, we have got these records which are present in the employees table but are not present in the department table. So as you see over here, so we've got these members. So Matt, Angelina, Charlie, and Joey. So these are present in the employees table, but they're not present in the department table over here. And finally, we've got 2 new departments, HR and operations, which are not part of the employees table. So now that full outer join is done, we are just left with one join, which is the cross join. And as I've told you, the cross join would give you the Cartesian product of all of the rows in table A and table B. And this is the syntax for it. Select, I'll give in the list of the columns which I'd want from table A and table B. After that, I'll put in from table 1, and then I'll just type in cross join table 2. So let's say if I have table 1 and table 2 like this, and if I apply cross join on these two, since there are 4 records in table 1 and 3 records in table 2, so cross join is basically 4 cross 3, and this is what I have over here. So what this basically gives is for every record in table 1, I have these 3 results with respect to this. So first I have A1, then I have A2, then I have A3 over here, right? Similarly, I have B1, B2, B3, C1, C2, C3, and D1, D2, and D3. So this is how I'll get the result. So let's go ahead and perform this in MySQL. Let me remove all of this. Let me also reduce the size of this over here. Right, so select star, since I want all of the records from both the tables. So select star from the first table as employees, and after this, since I want to apply cross join, that is what I'll put in over here. And then I'd have to give in the name of the second table, which is department. So select star from employees, cross join department. I'll put a semicolon, and let's just hit enter, and this is our result. So this is, as you see over here, so these are the total number of records which we have.
So now that we've learned all the major concepts of SQL, it's time for a lab exercise. So we'll be going through a bunch of questions and we'll be performing all of these questions in MySQL Workbench. So we'll start off with our first question over here. So we'll have to start off by creating a database with the name bank. Now, till now, we haven't seen actually how to create a database. We've only seen how to create a table and insert data into that table. So the syntax to create a database is actually very simple. All you have to do is use the keyword create and then follow it up with the keyword database. After that, you will give in the name of the database which you would want to work with. So you'll type in create database, and since I want to work with the bank database, I'll give in bank. So I'm here at MySQL Workbench. So here what you see on the left side column, these are all of the list of databases which we have. So as of now, we've got World, Sys, and Sakila. So now we'll have to create a new database with the name bank. So I'll type in create, and after this, I'll give in the keyword database, and I'd have to follow it up with a name of the database. I'll give it as bank. Now let me refresh over here. So we see that we have successfully created this database called as bank. Now, if we have to create tables into this database, so till now we were actually working with the world database where we were inserting all of our tables into this database. But now I'd have to change my database from this to this. So I'll just delete this over here, and now I'll give in the name of the database which I want to work with. So I'll type in use, and then I'll give in the name of the database which is bank. So now we are into the database, we are into the bank database, and we can create all of our tables in this bank database. Now let's head to our second question. So in the bank database, we'd have to create a new table called as bank details. And this bank details table will comprise of following columns. We'll have product, quantity, price, purchase cost, and estimated sale price. And these are the data types of all of these. So product will have a string data type, quantity with numerical data type, purchase cost with decimal data type, and estimated sale price with a float data type. And this is the solution which you see over here. So starting off, we'd have to type in create table and then given the name of the table, which is bank details. Now after that, we'll give in the name of the first column, which is product. And if it is a string, we can either set it to be char or varchar. So char is a fixed length string and varchar is a variable length character. And we are setting the size to be 10. Then we want quantity, which is of data type int. And then, so you see the difference over here, numerical and number. So number, you can represent it with real, and numerical, you can represent it with int. So in int, you only have integer values, and real values obviously comprise of all of the real values over here. After that, we have the purchase cost, which is of decimal data type.
So to create decimal, we'll type in decimal, and after that, we'll give in inside the parenthesis, we are giving in value 6, 2. So the 6, 2 is the maximum length of the value which we are giving in it. And that would comprise of 2 decimal places at max, right? So in total, the maximum length could be 6. And in that, all of those 6 values, there could be only 2 decimal values or 2 values after the right side of the dot. And then we finally have this column called as estimated sale price, which is of float type over here. So let's go to MySQL and create a new table over there. So I'd have to create a table. I'll type in create table, and the name of the table is bank details. Now I'll put in parenthesis over here, and inside this I just have to give in all the names of the columns and the data types. So the first column would be product, and this is of char type, and the length is of 10. Going ahead, I'd have to create another column called as quantity, and this is of integer type. After this, I'd have to create price column, and this is of real. And then I have the purchase cost. So I'll type in purchase cost over here, and purchase cost is actually decimal, and this would be 6, 2. And I have my final column, which is estimated sales price. So I'll just type in estimated sales price over here. And let me actually keep it as estimated sale price and not sales price. And this is of float type, and I'll put in a semicolon, and let me just hit execute. So this is float, FLOAT. Right, so we have successfully created our table with the name bank details. Now let me just have a glance at the table which I've just created. So I'll type in select star from, and over here I'll give in bank details. Now let me hit execute, and let's see what is the result. So these are all of the columns which are present in this table. So now that we have created the table, we'd have to display all of the columns and their data types in the bank details table. Now, if we just want to see the names of the columns, we can use select star command. But if we want to also see the structure of the table, then we'd have to use the describe command over here. So we'll use the keyword describe, and then we'll give in the name of the table, which is bank details. So that is what I'll do over here. I'll start off by giving the keyword describe, and after this I'll give in the name of the table, which is bank details. Now let me have a glance at the structure of this, and this is what I have over here. So these are all of the names of the columns, and this is the data type. So now that I've done this, I'd have to go ahead and insert records in this table. So basically I'd have to insert 2 records. So the first record would comprise of all of these values. So as you see, we have the corresponding values of product, quantity, price, purchase cost, and estimated price. So this is record number 1. And similarly, we'd also have to insert the record number 2. So to insert values into a table, we'd have to use this keyword. We'll type in insert into, and then we'll give in the name of the table, which is bank details. And after giving the name of the table, we'd have to use the keyword values, and we will give in the corresponding values inside this. So now let me give in the command. So I'll type in insert into, and then I'd have to give in the name of the table, which is bank details. So I'll type in bank details over here, and after that I'd have to use the keyword values. And let me go ahead and just give in all of the values over here. So let's say first we've got product, and the first product is, let's say, pay card, and after that we've got quantity is, let's say, 3. Then I've got price, which is, let's say, $330, and then I've got purchase cost, which is, let's say, 8,008, and then I've got estimated sale price, which is, let's say, 9,009. So this is my first record. Now similarly, I'll go ahead and insert a second record into this. So I'll type in insert into. Let me write it properly over here. Insert into bank details, and after this I'll type in values, and inside this I'd have to give in the details. So the first or the second product over here is actually pay points. After this I've got the quantity, which is 4. And then the price is, let's say, $200, which is lesser than the first product. And then the
purchase cost is 8,000, and after this, I'd have to give in the sale price, which is 6,800. Now let me go ahead and execute this. So we have inserted these two records. Now it's time to have a glance at the modified table. So select star from the name of the table is bank details, and I'll hit execute. Right, so I have successfully inserted these two records inside this table. Now, after that is done, I'd have to make some changes to the table. So further going ahead, I'd have to add a new column to this table. So I'd have to add this column called as geolocation, where the data type is varchar with a size of 20. So the command would be alter table, and then I'd have to give in the name of the table, which is bank details. Then I'll use the keyword add, since I'd have to give in a new column, and I'll give in the name of the column, which is geolocation, followed by the data type of it. So let me go ahead and work with the alter command. So I'll type in alter table, and the name of the table is obviously bank details. And I'd have to alter this by adding a new column. So add of, I'll type in geolocation, and this is of varchar 20. So I have altered the table. Now it's time to have a glance at the modified table. So it'll be select star from bank details. Now if I hit execute, so as we see, initially we did not have this geolocation column, and by executing this command, we have successfully added this new column into this. Now further going ahead, we'll have to check the length of the string over here. So we want to find out what is the value of geolocation for product pay card. So wherever we have the product pay card, I would want to find out the value of geolocation. So what we'd have to do is we'd have to use the where clause. So we'll type in select geolocation from bank details where product is pay card. So basically the question is this: wherever I have the product of pay card, I would want to know the geolocation corresponding to this. So the command would be select geolocation from, and I'd have to give in the name of the tables, which is bank details. Select geolocation from bank details where product is equal to pay card. We actually have a null value because there is nothing stored in geolocation, because it is a new column and we haven't added any value inside that. Now further going ahead, we'd have to find out how many characters does the product pay card have in its bank details table. So in this, let's count the number of characters over here. So we've got 1, 2, 3, 4, 5, 6, and 7. So to get the exact number, we'd have to use the char length function. This is a string function which is inbuilt in SQL. So we'll type select char length, and inside this we will pass in the column name for which we'd want to find out the length. So we'll pass in product inside this, and we'll type from, given the name of the table, which is bank details, and then we'll give in the condition over here where product is equal to pay card. So let me show you the table first over here. So it'll be select star from bank details, and we have our table right in front of us. Now I'd want to find out the length of this. So I'll type in select of char length, and I'd want to find out the char length of product. Select char length of product from bank details. I'd have given the condition where I'd have to give product is equal to pay card. Right, now let me select this and let me hit on execute. So seems like we have a error over here. So this is actually product. So there's a spelling mistake over here. Now let me hit execute. So we see that the char length is 7. Now similarly, let's say if I want to change this, and if I put in
points over here, which is basically the second record. Now we see that the length is 9. Now if I remove this condition and just put in a semicolon, now let's see what is the result. So we get 7 and 9 because the character length of pay card is 7 and the character length of pay points is 9. And then going ahead, we have our new question over here. So we'll have to alter the product field from char to varchar. So initially when we had created this bank details table, the data type of this product column was character. So we'll have to change that from character to varchar, which is a fixed length character to a variable length character. So we'll again use the alter table command over here. So we'll type alter table given the name of the table, and instead of using add, we'll have the command over here modify, because we want to modify the table. Modify product, which is the name of the column, and given the data type. So again, I'll remove all of this over here. Let me use describe first so that it's easier for me to look at the table. So I'll type in describe and I'll give in bank details. So I basically have to modify this column over here. So this is char. I'd want to change this from char to varchar. So I'll use alter table and then the name of the table is bank details. And I'd have to use the keyword modify, and then I'd want to modify the product column. And from char, I want to make it to varchar, and the length would be same, which is 10. Let me cut this out. Let me run this now. Have we successfully executed this? Let me again run this and let's see what is the result. Right. So now we have successfully alter the table. Now let me go ahead and use describe again. So I'll type describe bank details, and now when I hit on execute, we see that initially this was char. We have successfully changed this to varchar with the help of the alter table command. Now after doing this, I'd want to reduce the size of the product field. So as you see, we had set the size to be equal to 10. Now I want to change the size from 10 to 6. Now after doing that, I actually want to see if this is actually possible. So again, the command would be same. I'll type in alter table given the name of the table, which is bank details over here. So I'll type in alter table bank details, and I'd have to use modify, and the name of the column is product, and varchar, and instead of giving 10, I'll put in a 6 over here. Now let me hit run. So we see that this is an error. We have an error over here, and it states data truncated for column product at row 1, because we already have inserted 2 records into this table, and the length of both of those characters was 7 and 9, which means we need to have the size over here at least to be 9. So let me change all of these values and show what happens. When I put it to be 7, again I get an error. When I put it to be 8 and run this, again, as you see, we have an error. Now, finally, when I put it to be 9, you see, we have successfully applied this to 2 rows over here. And now, just to ensure that we have made the changes, I'll type describe and then given the name of the table, which is bank details. So as you see, we have changed this size from 10 to 9. And after doing this, we'd have to create a new table called as bank holidays. And this new table again would comprise of 3 columns. So we've got holidays, start time and end time. So holiday field displays only the date. And then we've got start time, which displays hours and minutes. And then we've got end time, which displays hours, minutes, and time zone. So to create a column which comprises of only date, over here as you see inside the create table command, first we'll give in the name of the column and then we'll set in the data type. So over here to display only date, we'll use date over here. And when we want date and time, so when we want time in hours and minutes, we'll use date time. And then when we also want the time zone, we'll use the timestamp data type over here. So let's go ahead and create this table. So again, we'll be creating this table inside our bank database. So create table, and the name of the table would be bank details. And inside this, I'd have to just go ahead and create all of these columns. So the first column would be holiday, and its data type would be date. And after this, I'd have to give in a new column called as start time, and this would be date time. And going ahead, I'd have to create a new column called as end time, and for this it would be timestamp. So I have successfully created this table. Let me hit execute. So seems like, oh yes, so this is actually not bank details and this is bank holidays. So let me change this to be bank holidays over here, because even employees of a bank need holidays. They can't work every single day, right? So I have created this table. Now let me just show you the table which I've just created. So select star from bank. Let me type in holidays over here. And this is our table which we've created. So now that we have created the table, we'd have to insert records in it. So first, we'd have to insert today's details in all of the bank holidays. So to insert today's details, which is basically the first, we'd have to insert the date and then start time and end time. So all we'd have to do is put in current date, and current date inside this. So we'll start off by using insert into bank holidays, because we'll have to insert a record inside this. And after this, current date will give us the date, and over here current date and current date will give us the timestamp and the date over here. So let me do this. So I'll type in insert into bank holidays values, and I'd have to give in current date. Again, it will be current date, and then the third again would be current date. Now let me run this. Now let me have a glance at this table now. So I'll type in select star from bank holidays, and let's see what is the result. So as we see, we have added all of these details. So today's date is 28th April, and this is the start time and the end time which you see over here. And after this, we have a step 2 over here. So we'd have to postpone holiday to next day by updating the holiday field. That is, we had inserted the date to be 28th of April, and I want to change that date from 28th of April to 29th of April. And since we are actually updating a record in the table, we'd have to use the update command. So we'll type in update, given the name of the table, bank details, given the keyword set. And now to update a date field, we'd have to use this method called as date add. And this takes in 2 parameters. So the first parameter is the column which we'd want to update, and and the second parameter will add by how much we'd want to change this. So either if you want to change this with respect to days or hours or minutes or anything over here. And since we do want to increment this by 1 day, I'll add interval 1 day. So whatever date is stored inside this record, when I put in interval 1 day, it would be incremented with 1 day. So let me go ahead and perform this. So I'd have to type in update bank details set, and after this I'd have to update the holiday column. So I'll type in holiday is equal to date add, and I'd have to modify the holiday column. Let's say if I put in interval 1 day over here, I'll put in interval 1 day. And after this, let me see what happens. I'll put in select star from, and this is actually bank holidays and not bank details. Right. And over here, I want to have a glance at the modified table. So I'll type in bank holidays. I'll hit run.
And as you see, initially this was 28th of April. I have modified this to 29th of April. Now let's say similarly, if I want to add 10 more days, I'll just put in 10 over here. Now let's see what is the result. Let me run this. So it was 29th of April. And when we add 10 more days, it becomes 9th of May. So this is how you can add or modify details over here. Now similarly, if I want to subtract, so I'll put in -3 over here. Now let me run and see, right? So it was over here, 9th of May. And when I do -3, I have 5th of May over here. So this is how we can work with it. Now after this is done, I'd have to go ahead and update the end time over here. So we had the end time column. So we had to update the end time column with current European time. So again, we'll use the update command and we'll set end time is equal to UTC timestamp. So if we have to update it with European time, so we'll have to use UTC underscore timestamp. Now I'll delete all of this. Let me write in the command from the beginning. So update bank holidays set and time is equal to UTC timestamp. All of this is set, and then I'd have to have a glance at the modified table. So select star from bank holidays. Now that this is done, I'll click on run, right? So initially we had all zeros over here. Now that we've updated this, we have 648, 44. And once this is done, we've again go back to the bank details table over here, and inside the bank details table, let's say I have this product column. Now I want to display this product column with a new name. So I don't want to show this as a product column, but I want to show this as a new product column. So what I'll do is I'll just use a select command. So select product as, and I'll give it the name by which I want to have a glance at it. So select product as new product from bank details. So let me run this command. Select product as new product from bank details. And this is what we have. So actually the name of the column is product, but I'm displaying this as new product. And then after this, let's say if I want to show only the first record from the table. So we can go ahead and use the limit operator over here. So display only one record from bank details. So to do that, we'll type in select star from bank details and we'll set limit 1. Now select star from bank details because we want all of the columns, but not all of the records. I'll set the limit to be equal to 1, which would give me only the first record or the top record over here. And then finally, we have one last question. So I want to display the first 5 characters of geolocation of bank details table. So for that purpose, we'd have to use the substring functions. So we'll type in select substring, and this takes in 3 parameters. So the first parameter is the name of the column, and then we'd have to add the starting index and the ending index. So these are all the index values for the characters which we'd want to extract for that particular record. Now, to actually find out the substring of that particular record, we'd have to add some values over here. But as you see, there are no values. So to add values, we'll use the update command. So we'll type update and we'll set geolocation, update geolocation set. So this is not actually update geolocation. This has to be name of the table first. So I'll type in update bank details set geolocation is equal to, let's say it is New York, where I'll maybe set where product is equal to pay card. Now let me see if this change has been done. Right, so we have successfully updated this. Now similarly, I'd want to update the geolocation to, let's say, New Jersey, where product is equal to pay points. Let me change this to pay points now. And let me run this. So even this command has been executed. Now, let me see the modified table. So select star from bank details. And this is my modified table over here. Now to get only the first 5 characters, what I'll do is I'll use select substring over here. And in this, I'll just give in 3 parameters. So the first parameter would be the name of the column. So the name of the column is geolocation. And after this, I'll give in the first index and the last index. So I'll give in 1, 5. Select this from, and I want to select this from actually bank details, where since I want this for the first record, so I'll type product is equal to pay card. Let me change this to pay card over here. Now let me hit run, right? And these are the first 5 characters. I've got new underscore y. Now similarly, let me change this to pay points over here, and let's see what do we get. Now we get new j. Now we'll head on to the second part of the lab session. So this time we've got some more queries. So we basically are dealing with 2 data sets. So we have the cricket1.csv and the cricket2.csv. So this cricket1 is the table for all of the players who've played in test match 1, and cricket2 table is for all of the players who played in test match 2. Now let's start off by having a glance at these 2 tables first. So I have my CSV files open over here, and this is the cricket1 CSV file. I've got 4 columns: player ID, player name, runs, and popularity, right? So these are the different players who played in test match 1. Now similarly, I've got cricket2 table over here, and in this I have player ID, player name, runs, and charisma. So the difference between cricket1 and cricket2 CSV files are, in cricket1 over here we've got the popularity column, and in cricket2 we've got the charisma column. Now let me head to the notepad again over here, and let's start off with our commands. So our first command would be to find out all of the players who are present in test match 1 and test match 2. So this is not an intersect, this is basically union. So this is a union of all of the players. So basically, what is the team? What are all of the players who were present in test match 1 as well as test match 2? So for this, we'll have to use the union operator. So we'll give in the command select star from cricket1 union select star from cricket2. So over here, instead of using the star operator, you can actually give the name. So we'll just put in player name, and that would give in the list of all of the players who have played in either the first test match or the second test match. So let me go to MySQL Workbench over here. Now before we go ahead and apply all of these commands, our task would be to import these 2 tables into MySQL Workbench. So I'll be importing these 2 tables into the world database over here. So I would have to right click on the world database, and over here I have this option of table data import wizard. And over here I would have select the browse option, and inside this I will give in the name of the file which I'd want to import. So I have the cricket1.csv file. I'll import this, and once I select this, I'd have to click on next. And as you see, if we don't have the table, if this is not an existing table, then MySQL Workbench will automatically create a table called as cricket1 over here. And as you see, we would have all of these columns in cricket1, and we also have the field type. So player ID is of text, player name text, runs and popularity are of integer type. I'll click on next, and when I finally click on next, this will import the data and also prepare the file. So the data has been successfully imported. Now I'll just click on finish. Now inside the tables, if I refresh this, I would have the cricket1 table ready. Similarly, let me go ahead and import the cricket2 table. So I have the table data import wizard. Now I'll click on browse, and this time I'll be importing the cricket2.csv file. So I have selected this. All I have to do is click on next,
And again, we would have this table ready over here. So player ID, player name are of text type, runs and charisma are of integer type. Next, let it import. And once the import is done, again, click on next, click on finish. Now let me refresh it over here. Now we also have the cricket2 table ready. Now, just to be sure, let me also show you these two tables inside MySQL Workbench. So first I'll type in select star from cricket1. Right, so this is our cricket1 table. Similarly, when I put in select star from cricket2, that'll give me my second table. So our first query was to find out all of the list of players who were either present in test match 1 or test match 2. So for that purpose, I will type in select and I would want the names of the players. So I'll type in player name from, and the first table would be cricket1. So I'll type in cricket_1, and after this I'll have to give in the union operator. Now similarly, since I want either the players who have played in test match 1 or test match 2, after this I'll give in again player name. So this would be player name from, and name of the table is cricket2. So this would give us the entire list of players who have either played in test match 1 or test match 2. And then we have our second query over here. So we'll have to write a SQL query to find out players from test match 1 having popularity higher than the average popularity. And this would be the syntax for that. So we would have to find out players whose popularity is higher than average popularity. So for that purpose, first of all, I'll select the player name because I want to know which player or whoever player has higher popularity. So player name, and then I would also need the popularity from cricket1 where popularity is greater than, and over here now this greater than has to be for a subquery, and inside the subquery I'm giving select average of popularity from cricket1. So till now we have not worked with any subqueries, so this might be a bit difficult for you to process. So let's understand this from the right side. So we'll start off by getting the average popularity from cricket1 table. So when I type in select average of popularity from cricket1, this would give me the average value of popularity for all of the cricketers. Now I would want player name and popularity for all of those players whose popularity is greater than this value. So first we'll find out this value, and then we'll find out all of those players whose popularity is greater than this value. So let me go to MySQL Workbench and implement this. Let me remove all of this. So I'd have to start off by finding out the average popularity. So for that purpose, I'll type in select average of, and inside this, I'd have to type in popularity from cricket1. So we see that we have an error over here. So the name of the table is wrong. Right, so we see that the average popularity of a cricketer is 9.8333. Now I'd want all of the players whose average popularity is greater than this. So I'll put this inside braces over here. And let me give in my main command over here. So which will be select. What do I want? I would want the player name, and I would also need the popularity. So let me also type in popularity over here. So select player name and popularity from cricket1 where the popularity has to be greater than 9.8333. Now let me hit execute. And this is our result. So as we see, all of these players, their popularity is greater than 9.833. And it seems that Dhoni has the highest popularity of 15 over here. After that, we'll have to find out the player ID and player name that are common in test match 1 and test match 2. So guys, understand the difference between this and this over here. So over here, we wanted to find out the entire team, that is the list of players who either played in test match 1 or test match 2. Here, we'd want to find out all of those players who have played in test match 1 and as well as test match 2. So this would mean that this is the intersection over here, right? So these are players who are part of both of the test matches. So now since we want player ID and player name, we'll start off by typing out select player ID and player name from cricket1, which is the first table, where cricket1.player ID in, again we'll give in a subquery over here, select player ID from cricket2. Now over here this means that we are selecting only those player IDs from table 1 where the player ID is also present in cricket 2, right? So when you use the in operator over here, this means that this player ID is also present in the player ID of table 2. Now, if this seems complicated, let's again go to SQL Workbench and let's implement this command over here. So I would want the player ID and the player name. So I'll type in select. So my first column would be the player ID. Let me just give in the player ID over here. And after player ID, I would also need the player name. Select player ID, player name. This would be from the table cricket1, where the cricket1.player1 ID, this would mean that basically whichever player ID is also present in the second table. So I will type in cricket1.player ID and then I'll type in, and inside this I'd have to give in the subquery. So let me write this properly over here. This is select and the subquery would be select of player ID from, and then I'd have to give in the name of the second table, which is cricket2. Now let me hit execute. So these are all of the players. So we've got 1, 2, 3, 4, 5, 6, 7 players who are part of the first test match as well as the second test match over here. And then going ahead, we'd have to retrieve the player ID, runs and player name from cricket1 and cricket2 and display the player ID of players where the runs are more than the average runs. This would mean that I would want all of those players whose score is greater than the average score with respect to both the test match 1 as well as the test match 2. So this is the command for that. Since I want player ID, runs and player name, I'll select all of these from cricket1 where cricket1.runs is greater than average of runs from cricket2. Now you must be thinking, why have I given only table 2 over here and not table 1? This is because if we just select those players whose score is greater than the average ID of whichever test match is higher. So over here, it seems that the average score of all of the players in test match 2 is higher. So that is why I'm comparing with test match 2. So this will give me all of those players whose scores are greater than the average scores with both the test matches. Now let me show you by finding out the average scores in both the test matches. So I'll type in select average of runs from, I would have to find out from the first table. So the average score from test match 1 is 39.33. Similarly, if I want to find out the average score from test match 2, it is 49.45. So that is why we are finding out all of those players whose score is greater than the average score in test match 2. Now it's time to write the command for that. So I would need the player ID. So I'll type in select of player ID. I would need also the player name. So I'll type in select player name, and I'd also need runs. Select player ID, player name and runs from, and I would have to type out after this from cricket1 where cricket1.runs is greater than select of average of runs from, I'd have to give in cricket2. Now if you guys still don't understand the concept over here, I'll repeat this. So instead of finding out all of those players whose score is greater than test match 1 and test match 2, what I'll do is I'll just find out all of those players
whose score is greater than the higher average of both of those matches. And as we have already seen over here, the average score in test match 1 was 39 and the average score in test match 2 was 49. So that is why we are just taking out all of those players whose score was greater than the average score from the test match. Now let me hit run, and it seems that we've got only 3 players, Virat, Yadav and Raidu, whose scores were greater than the average scores in both of the test matches. Going ahead, we'd have to write a query to extract the player ID, runs and player name from Cricket 1 where the runs are greater than 50. So this is a very simple query. All I have to do is use the select keyword and I'm extracting player ID, runs and player name from this table where runs are greater than 50. So let me type in select. I would want player ID. I would want the player name as well. And I would want the runs from Cricket 1. And I would want all of these details where this is actually greater than 50. So where runs are greater than 50. So only Yadav and Raidu have their scores greater than 50 over here. And after this, I'd have to write a query to extract all the columns from Cricket 1 where player name starts with Y and ends with V. So for this, we have the like operator. So we'll type in select star from Cricket 1 where player name like Y%V. This would mean that we will extract all of those records where the name of the player starts with Y, has some set of characters are followed by Y, and then it ends with V. Now, when you're given this percentage symbol between two characters, this would mean that this would either mean either a single character or multiple characters. So let's go to here and let's perform this command over here. So all I'd want is select, and then I would want all of those players. So select star from, let me type in Cricket 1 where player name like Y%V. Right, so Yadav is the only player whose name starts with a Y and ends with V. Similarly, if I wanted to find out all of the players whose name starts with a Y, then inside these single quotes over here, I'll just give in a Y and then I'll follow it up with a percentage symbol. So as you see, again, we only have Yadav over here. Now, similarly, let's say from table 2, if I wanted all of those players whose name starts with a Y, so I'll type in Cricket 2 and we've got Yuvraj, Yadav and Yusuf, whose name starts with a Y. And then going ahead, we've got the next question over here. So we'd have to write a query to extract all of the columns from Cricket 1 where player name does not end with T. So instead of like, we'll just use not like over here, and after not like, we'll put in percentage T. This would mean that this ends with a T. So percentage T, this would mean you could either have one character or multiple characters, and after that, it just ends with a T over here. So before we find out all of those players whose name does not end with a T, let's just find out all of those players whose name ends with a T. So select star from Cricket 1 where name like, I'll give in %, I'll give in T over here. So seems like we have an error over here. So this is actually player name. Now let me hit execute. So Virat and Rohit are the players whose name ends with a T. Now let me put in not like over here and let's see the result. So as you see in this result, we will not have Virat and Rohit because their name ends with a T. So going ahead, we'll work with the new dataset CSV file called as newcricket.csv, and this is our file over here. So this is basically a combination of the Cricket 1 file and the Cricket 2 file. Now in this, as you see, so these are the 4 columns from Cricket 1 and these are the 4 columns from Cricket 2. And wherever the values weren't present, we've just added null over here. So let me go ahead and also load this file in MySQL Workbench.
So here I will perform the same command. I'll right click this. I'd have to click on this. Now I'll click on browse, and the name of the file is newcricket.csv. Open. Next. And since this table is not present, we'd have to create a new table over here, and these are all of the columns which would be created inside this. So again, next. Wait for a while and just wait for this to be done. So as you see, we have successfully created this table. Let me refresh this over here. Let me bring it down. As you see, we have this new cricket table over here. Now, let me show you what is present in this table. So I'll type in select star from new table. This is actually new cricket, not new table. So I'll type in new cricket. And this is our result over here. Now from this table, I'd have to extract the player ID and player name of all the players where charisma value is null. So I'll just type in select player ID, player name from new cricket where charisma is null. So it's a very simple command over here. Let me again go to MySQL Workbench and let me perform these commands. So I'll type in select player ID, player name from new cricket where I'll type in charisma is null and I'll hit enter. Let's see the result. So we see that these are the two columns, player ID and player name, where the charisma value is actually null. And then going ahead, we'll have to separate out all the player ID into single numeric IDs. So we had seen in player IDs, we had something known as PL1, PL2, PL3, PL4, and so on. So we'd have to take all of those and just make them. So if it is PL1, I'd have to make it 1. If it is PL2, I'd have to make it 2. If it is PL3, I'd have to make it 3, and so on. So for this, we'll use the substring query and we'll type in select player ID and substr. And in this takes in two parameters. First is the name of the column, and then over here, this we can either give in the starting index and index or just one. So this would mean that from this entire string, I would want just that character which is present at index number 3. So as you see, this is our entire string. From this entire string, if I take only this value which is present at index number 3, I will get the numbers. So I'll type in select player ID and substring of this would be player ID and 3 from new cricket. Let's see what do we get. So as you see, from this entire table, I have taken these two. So these were the original values of player IDs, and I have extracted only the final character which is present at index number 3. And then we have our final query over here. So we'd have to write a query to extract player ID, player name, and charisma, where charisma is greater than 25. So select player ID, player name, and charisma. And again, after that, you will just give in the condition where charisma is greater than 25. So let me just bring it down over here. Let me remove this. Select. First, I'd have to select player ID. Then I'd have to select the player name. And then I would need the charisma, where I would need this from a table. So I'll type in from, and the name of the table over here is new cricket. I'll give in the where clause, where the charisma is greater than 50. So it's only Virat and Dhoni whose charisma is greater than 50. Now we'll work with a new data set. So this is our churn1.csv. So as usual, we'd have to go ahead and load this data set first, but this is a really huge file. So I've already done that for you guys. Now let me show you what is there over here. So we've got all of these columns. So this table basically tells us whether the customer would churn or not. So this is a telecom data set, and we've got all of these details: the customer ID, gender, whether the person has a partner, whether the person has any dependents on him,
the tenure for which the customer has been using the network, and we've got the technical help, online movies, and so on. And similarly, we've got the payment method over here, the monthly charges, the total amount, churn, and so on. So these are the different factors which are present in this table. Now, our first task would be to write a query to count the frequency of the values in the agreement column from the table churn1. Now, let me show you the agreement column over here. Let's just find out where the agreement column is actually from this. So we've got a lot of columns over here. Now, this is the agreement column. So these are the different levels over here. So we've got 1 year, month to month, 2 year, and so on. So we'd want to find out the number of times 1 year occurs, number of times month to month occurs, and the number of times 2 years occurs. Or in other words, we'd want to find out the number of subscribers whose agreement is 1 year, similarly number of subscribers whose agreement is month to month, and number of subscribers whose agreement is 2 years. So let's go to MySQL Workbench and work with this. So I would have to type out select, and then I'll type in agreement because that is what we want, and I'd want the count of agreement. So I'll type in count of agreement, and I would want this count with respect to the group. So from, I'll give in the name of the table, which is churn1, and I'd have to group it with respect to agreement again. Now let me execute this and let me show you the result. So this is what we get. So you see that there are 195 entries of 1 year, 342 entries of month to month, and 262 entries of 2 years. So what I've basically done is I've grouped my data with respect to the agreement column, and in the agreement column I've got 3 levels. Now for these 3 levels I'd want to find out the count, and that is what I've done over here. Then I'd have to go ahead and change the name of the table from churn1 to churn details. So to rename a table, I'd have to use the rename table command. So I'll type in rename table and then given the name of the table, which is churn1. After that, I'll type 2 and then given the new table name. So I'm changing the table name from churn1 to churn details. Let me delete this. I'd have to type rename table and then name of the table, which is churn1. And this would be changed to churn details. So we have successfully implemented this. Now let's see what would happen if I try to read data from churn1. So I'll type in select star from churn1. And as you see, we get an error because churn1 doesn't exist. Now instead of this, if I put in churn details, right? Now this table exists because we have changed the name of the table from churn1 to churn details. And then we'd have to go ahead and add a query to create a new column named as new amount, which is basically the sum of total amount and monthly charges. So over here, we've got the total amount and monthly charges. So wherever these are there, so I'd have to add these two values and make it into a new column called as new amount. So for that purpose, first of all, we'd have to start off by using the alter table command. So we'll type in alter table and we'll add a new column and we'll name that column as new amount. So let's go ahead and do that. So I'd have to start off by altering the table. I'll type in alter table and I'd have to alter the table whose name is churn details. And what alteration do I actually have to do? I'd have to add a new column. So I'll type in add column and the name of the new column would be new amount. And this would be of type float. Now let me run this. Right now, let me see what changes have been done to this table. Select star from churn details. Now let me go to the end of this table. So as you see, we have added a new column to this and we also have to add values now. So the values are basically this plus this. So when I add these two, I would get something which is close to 253 over here. Right now, let's see how to do that. So for that purpose, we'll have to update the table. So we'll type in update
churn details set new amount is equal to total amount plus monthly service charges. So I'll just use the update command. I'll type in update and then I'd have to give in the name of the table, which is churn details. So let me type in churn details over here. And after that, I'd have to use the set keyword and give in the name of the column which I'd have to update. So I'd want to update the new amount column, and this is basically the total amount plus the monthly service charges. So this plus this would give me the values into new amount. Now this would be monthly service charges. Let me hit execute. Now let me have a glance at the table. So select star from, this would be churn details actually. So let me just type in churn details, and over here, let me go to the end of this table again. And as you see, we have added these two and we have found the values for all of the records over here. So 233 plus 20 would give you 254. Similarly, 3579 plus 53 would give you a value something like this. So we have updated that as well. Now we'd have to go ahead and rename the column new amount to just amount. And if we have to make some changes with respect to a column, we'll have to use the alter table command. So we'll type in alter table, given the name of the table, which is churn details over here, and we'll use change. So basically I am changing the name of this column from name amount to amount, and the data type is obviously float. So there is no change in that. Now I'll use the alter table command. So I'll type in alter table, and I'd have to give in the name of the table, which is churn details. So alter table churn details, and since I have to change the name of the column, I'll type in change. So old name of the column was new amount, and I'd want to change it to just amount, and the data type is float. Now again, let me go ahead and have a glance at the modified data set. So it will be select star from churn details. And when I run this, I see that this column, the name of which was earlier new amount, it has been changed to just amount. And then going ahead, I'd have to also drop this column. So to drop a column from a table, I'd have to just use this alter table churn details drop column amount. So let me go ahead and drop this column as well. So again, I'd have to use the alter command. So alter table churn details, and I'd have to use the drop command. So what do I have to drop? I'd have to drop the column called as amount, and then just put in a semicolon and then hit execute. Now let me see if this column has been removed or not. So select star from churn details. Let me go to the end of this, and as you see, the column which we had created has been dropped as well. Now after dropping the column, we'll have to write a query to extract customer ID, internet connection, and gender from the table churn details, where the value of the column internet connection has I in it. Now let me go to the internet connection column. Let me see what exactly do we have to do over here. So this is the internet connection. So as you see, the second character has to be I. That means that we have fiber optic value over here. This basically means we'll have to extract all of the records where the internet connection is equal to fiber optic. So this is what this query is asking us to do. So where the value of the column internet connection has I at the second position over here. So as you see, we have I at the second position. We'll type in select customer ID, internet connection, and gender from churn details, where internet connection like underscore I %. This means that we would have some character at the first position. At the second position, we'll have I followed by any number of characters. So select, let me start off by giving all of the names of the columns which I'd want to extract. I'd want the customer ID, and then I'd want the internet connection as well. Then I'd want gender. So these three I'd want from the churn details table and the condition is where the internet connection like. So here the first character could be anything, the second character needs to be I, followed by either one or more characters. Now we have an error over here. We don't have a customer ID, so this is not an underscore over here. So now let me just hit enter. Right. So as you see, we have extracted these three, and in the records, we only have fiber optic. Now there are a lot of internet connections. From all of those internet connections, we have extracted only those records where the internet connection is equal to fiber optic. So similar to that command, we'd have to execute another one where we'd have to extract all of the records where tenure is 6x, where x is any number. This means that the tenure has to be in the 60s. It could be either starting from 60 going on till 69. So 60, 61, 62, 63 till 69. It could be any of these values. So we'll type select star from the table name churn details where tenure like 6 underscore. So select and then star from name of the table would be churn details. Let me write in the name of the table properly, where tenure like 6 underscore. So this has to be in single quotes. Actually, I'll type in 6 underscore over here. Now let me hit execute and let's see the result. So in this tenure column, if you see that all of the values, they are in their 60s, right? So 67, 63, 60, 63, and so on.
Having built a solid foundation in SQL, we are now ready to dive into MySQL, one of the most widely used relational database management systems. In this section, you will learn how to apply your SQL skills specifically with MySQL. We will guide you through the installation process, introduce you to basic commands, and explore practical use cases. By the end, you will be equipped to create and manage databases efficiently using MySQL's robust features.
Let's have a look at MySQL, because in this tutorial, we are going to use MySQL software. Now, let's have a look at how can you install MySQL. So, installing MySQL, you need to go to their official website, that is www.mysql.com. And from the downloads, you can download your MySQL. But before downloading the MySQL, be sure you are not going for Enterprise Edition, because if you want to go for Enterprise Edition, you need to pay for that. But there is an option where you can use MySQL for free for like the student if you want to do their own databases and if they want to practice their databases. So that time there is a free version is also available for MySQL, right? And you also take care of your system configuration. So in MySQL, there are lots of version is available according to your system configuration, right? So you have to choose your MySQL carefully for that. Now we have already seen that how can you install MySQL. Now we will move towards how can you start coding or how can you start writing your own query using MySQL. So there are some data types concepts we have in MySQL. But what are those data types concepts, right? And what is the data type stands for? A data type is an attribute that specifies the type of data that the object can hold. The data types can be integer data, a character data, monetary data, date and time data, or binary strings, and so on. So basically, in our case, maybe we are going to use character strings, numeric values, date and time, and binary. Now we will have a look at what are the string data types we have in MySQL. So we have character data type that stores in number of characters in bytes, where in is in the range of 1 to 8,000. So basically this is the range or the length of those data types. Now comes the nchar. So what is that nchar stands for? So it stores n Unicode characters to n bytes, where n is in the range of 1 to 4,000. Now we will have a look at what is varchar, right? So it stores up to 231 to 1 characters. But wait, what is that varchar stands for? And why this is named as varchar, right? As the name suggests, varchar means character data that is varying, and it's also known as variable character. It is an intermediate length string data type. So basically, it can hold number, letters, and special characters. So, and SQL varchar usually holds 1 byte per character and 2 more bytes for the length information, right? Now we also have varchar max. So what is that varchar max? So it stores up to 231 to 1 characters, actual string length plus 2 bytes, right? Now we have in varchar. So now we have in varchar. So it stores approximately n characters and to an actual string length plus 2 bytes where n is in the range of 1 to 4000. Now we have in varchar max that stores up to 231 minus 1 divided by 2, then minus 2 characters. Basically 2n actual string length plus 2 bytes. So these are the data types we have particularly for string types in MySQL. Now we will have a look at what are type of commands we have in MySQL. So you already got what are the data type we have, but where can you use these data types, right? So in that case, you need to have a proper command. So SQL is basically based on all types of command. So basically we have 5 types of commands. We have DDL, DQL, DML, DCL and TCL commands. I know you are thinking, what are these DDL, DQN and DML commands, right? Wait, I will give you a brief and I will show you how can you implement them in MySQL as well. So first, let's start with DDL commands. So basically, DDL stands for Data Definition Language. It helps to define the database schema. Also, it deals with description of the database. Also have power to deal with creating and modifying the structure of database objects. So let's have a look at how DDL works and what are the command we have under DDL. So we have create command. So why do we use that create command? This command is used to create a database, or it also have some objects. Maybe you want to create a table, index, function, views, store, procedures and triggers, right? And there comes the drop command. But why do I need to use drop command, right? So drop is mainly if you don't want some of the part of your database, like mainly used to delete objects from the database, right? Maybe you want to delete a table, maybe you want to delete a function, view, store, something like that. Now comes the alter command. So why and where we use alter? Alter, from the name itself, you can understand you can alter something. So maybe it's used to alter the structure of the database. So let me give you an example, like maybe you create a table and after that you want to add one more attributes, which stands for columns. So in that case, using alter statement, you can actually change your structure of the table. So this is how alter works. Then comes the truncate. So what is truncate? So truncate command is used to remove all the records from a table. So which includes all memory allocated for the records are removed, right? So basically truncate is used to remove all the records from a table. Now comes the comment. So this command is used to add comments to the data dictionary. And lastly, we have rename. So what is that rename stand for, right? So this is used to rename an objects existing in the database. Now we will have a look at how can you use them using MySQL. Now we will go to MySQL software and I will show you how can you do these commands. So we have already written the commands. Now I will show you what are the commands and how can you do that. So before start with that, MySQL has 3 parts, right? One is a console. Over here you can write your data or your language, structured query language. Here you will get your, like if you write one structured query language, that is SQL commands, and if you want to see your query is actually working or not, you can see over here. So it will, if you get a green tick over here, so basically, okay, your commands are running. your commands are executed properly, and you will get a message for that. And if your command has some problem, you will get an error code as well, right? But before that, let me show you how can you create your first SQL script. So basically, this is known as script. Here you can see an option called file, right? You can go from here as well, or you can see over here there is a plus sign in SQL. You just need to click on there, right? And from there, your script is ready, and or you can say your script where like the document is ready where you can write your script. If you want to save your script, how can you do that? So here you will get an option called save the script, right? You need to click over here, and the location you gave to save your script, you will get that over here, and you need to give the name of your demo accordingly. But the extension of the demo will be .sql. So maybe you can give demo2, and then you just need to save it. And one more thing, if you don't save your data and the command you have written, so that will be lost, right? So whenever you are going to start working with MySQL, you have to be sure that your data is already saved, right? And MySQL is not case sensitive. So whenever you are going to use MySQL, you don't need to take care of the alphabets. I mean, the alphabets means the hierarchical alphabets, or maybe that's a capital letter or a small letter. You don't need to take care of that. So all you need to take care of the name. So that is why the MySQL is not case sensitive, right? Now we will have a look at how can you create your database. So first, if you want to create your database, you need to write a You need to write a query for that. So here you need to write create, the first command, the DDL command, right? So you need to write create, and then I'm going to write database. And then you need to give the name of your database. So for my case, maybe I'm going to give MySQL, then demo, right? So this will be my database name. Here, if you want to execute that, you need to select the whole command. Otherwise, it will not be executed. So in this case, you need to select the whole command, and then you need to press this sign, right? So you can see there is a pop-up came that execute the selected. Okay, it's gone. Okay, execute the selected portion of the script or everything if there is no selection. So if you don't put any selection, it will execute the whole query. Okay, here one more catch over here, you need to use a semicolon. So whenever you complete your query, you need to put a semicolon. So these are the syntax you need to remind whenever you are going for using SQL, or if you are going to write SQL query. Let me just select the part, and then I'm going to write a execute, right? You can see I got a message that one row is affected, and I got a green sign as well. That means my query got executed. Now, if I want to do the same thing, right? If I want to go for making the same database with the same database name, let's see my SQL software is going to take that or not. Let me execute that. Yes, I got an error message. You can see can't create database, right? It's as it is already exists. So you have to take care of that as well. Whenever you have made one database, you cannot use the same database again and again. So your all database name in MySQL Workbench is always be unique, right? Let me just delete it. Now, what I need to do, I need to say, okay, I have created my database. Now, what I need to do, I need to give an information or a instruction to my MySQL that, okay, I have created a database. Now I want to use them. To do that, we need to use a command called use, right? And under use, you need to give what database you need to add, right? Use, and then I need to copy this part. Right? So this command basically give an instruction to your MySQL Workbench. Okay, I have created my database, or already I have this database. Now I'm going to use this database, right? So I said use this. Now let me execute that. Yes, you can see 0 rows affected, but this is actually worked. So now whatever the table or whatever the data you are going to add in your database, it will comes under MySQL demo, right? Now let's have a look at what are the other commands we have. Let me go to the previous slide. Okay, so already we have covered create. Now maybe I am going to use a drop command. Let's see if we can drop our databases, whatever database we have made. So we have made our database MySQL demo. Let's see if we can drop them. So dropping them means you are going to delete that database. So let me just write, So I need to write drop database and then MySQL demo. So basically you are giving an instruction to your MySQL Workbench. Okay, I have created this database. Now I want to drop them. What I want to drop? I want to drop a database. So drop database and then you need to provide the database name. That is MySQL demo. Let me execute that. Yes. Okay. Yes, you can see drop database demo is already there and 0 rows affected. But wait, how can I see that this database doesn't exist? So in that case, you can use one more command, it's called show, right? Show databases. Then you need to just put the semicolon, right? What it will return? It will return all the databases you have in your MySQL Workbench. So let me execute that. Okay, you can see I have lots of databases and here there is no database called MySQL demo, right? I have MySQL database, but I don't have any database called MySQL demo. So this is how we can use our DDL command using whenever we are going to make a database. Now, let me just re-execute those queries. For that, we can again create our database. Yes, use MySQL demo. And then I am not going to use this, right? And then if I going to execute the show databases, let's see if it's going to show my SQL demo or not. Yes, you can see I already can get this, that my SQL demo. So this database is already there in my MySQL Workbench, right? So you can be sure, okay, my SQL demo is already there. Now what I need to do, I am going to make a table. But why do we need to make a table, right? So we all know in SQL or in MySQL, what we need to do, we need to make our table, that is basically our database in a tabular form. So right, we need to go for making our first table. So how can I make them, right? So already I have written over there. Let me just copy that. And then I will just show you how I'm going to use that part. You can see I have written create. So basically I am going to use the create command. Here you can see I have written database. So basically I was making a database. Now what I am making? I am making a table. So I have written this is a table. Then I need to provide the name of the table. So what is the name of the table? That is student table, right? Now what I need to give? Okay, my table name is already there. Now I need to get our attributes or the columns, right? So in that case, you need to provide the column name, but be sure about the structure, right? You can see that there is a symbol over here. That means you are writing one query, right? You are not writing multiple query. So in that case, your first bracket or the curl bracket or the round bracket, you can say it starts from here. Then you need to write the attributes name. The first attributes for me, it's student ID. Then what type ID I want? I want an integer type ID. So my ID is integer. Now I have already explained what is varchar, and I have also given the range of varchar. So you can see student name, my second attribute name is student name. And then I have provided my student name can be a varchar. What is the length of that student name will be? Maximum is 100. Then I have used a comma. Again, I am going to use course name, right? So this is one more attribute for my table. But be sure one thing over here, I am not using any key. I will add them as well. This is the basic part where I was showing you how can you create your first table using MySQL DDL commands. With time, we will go for using keys and how this relation works, right? So course name is basically here. So course name is also your one attribute. That is also varchar, but the length of that varchar is 40, right? Lastly, be sure about the syntax. We need to close our round bracket and then we need to give a semicolon. So this is how you have to be careful whenever you are going to make a table. But one more thing, did you just notice that I have using a comma for each and every attribute, but in the last attribute I didn't use any comma, right? If you put a comma over here, you will get a cross, right? You can see there is a cross. That means your query is not right. You need to rectify your query. Maybe we will get some pop-up, but no, over here we are not getting. But this is something, it's showing your query is not right. Please look into your query. There are some mistakes, syntactical mistakes, or there are some like conceptual mistakes, right? So whenever your query is not right, you will get a cross sign like this. Now what you need to do, you just need to copy this and you just need to use an execute button. Yes, so you can say my table is already ready. But wait, how can I check that what are the tables I have in my database? So we can use again the show commands. So show, what I need to show? The database need to show tables, right? Let me just execute that. How many tables I have in my database? Okay, I have only one table, that is student table, right? So this is how you can see the table structure. Already I have shown you how can you see what are the tables you have in your database. But if I want to see the table schema or the table structure, how can I do that? To doing that, we need to use one more command that is called a describe. This is pretty clear, right? So this is how I really love MySQL because of its simplicity. Obviously, it's simple, like it's a normal English, right? I say show tables. Your command is ready. Now I say, please describe my table that is called student table. So first you need to write the command describe and the table name you want to see the schema, right? Let me execute that. So here again, I'm going to execute. Yeah, you can see I got the field, type, null, key, default and extra. But wait, what are these actually stands for? Field is basically what are the attributes you have. Type is basically what are the data types for each of the attribute. Now there comes null. Is your attributes can be null? Did you give that authority to your field that your field can be, your attributes can be null? Yes, for my case, I didn't mention anything. So that means your field can be null. And key, did I mention any key? No, I did not mention any primary key or foreign key. So yeah, this is how it's showing your table schema. So we have student ID, the first attribute, that is data type is integer. Then we have a student name attributes called varchar, which lengths have 100. Then lastly, we have a course name, which is also the type of varchar and the length of that varchar is 40, right? So this is how you can see your describing student table. Now what I need to do, I need to use a alter command, right? So if we go back to the presentation, let's have a look at what are the commands we left so far, okay? So here we came to the presentation again. So we left with truncate, comment and rename. So let's have one more, that is alter. So let's have a look at how can you actually use alter and truncate. So we came to the MySQL again and let's try to add one more attribute for your student table. Let's try to do that, right? So we are going to use alter command, right? Then what you need to do, you need to provide the table name, right? So for my case, student table. Then add what you need to add, columns, right? And then I am going to write email. And what will be the type of that email? Varchar and then 100, right? Okay. but I am getting some error. Okay, I was getting some error, but why I was getting the error? Okay, let me go back to the previous phase. So I didn't mention what you need to alter. So here you can see I need to alter table, right? So you need to specify that. Alter what? Table, and then you need to provide the table name, that is student table. Now please add what I need to add. Add the column. What's the column name? That is email. And what's the length of that? What's the type of that column, right? Or the attributes? That's varchar 100, right? So my data type is varchar and the length of that data type is 100, right? So let me just execute that. Yes, you can see my alter table command is already worked. So let me just again check my description of that student table, right? Yes, you can see here my alter email field is already added and the type of the email field is varchar 100, right? So this is how our alter works. Now we will have a look at the truncate command. I have already written over here. Let me just copy this. Okay, so truncate command is also same as the before we have used whatever the command. So basically we are going to use truncate command. Then we need to use what you need to truncate. I want to truncate my table. So basically I want to delete my table, right? And then I need to provide my table name. Okay, so this is student table, right? Let me just execute that. Yes, you can see my truncate table is already done. So if I am going to use the show table commands, let's see what's going to give me. But still it's giving me the tables I have in the database. Let me see the describe. Yes. Okay. So we have seen that if we use truncate table, still we will get the table structure in the database. But wait, why do we use truncate table? I will tell you why we use truncate table and how it's gonna work. Before that, we need to learn and we need to understand some of the other DML, DQL language as well. After learning those commands, you can understand how truncate is working and how it's actually deleting the data from the database. So now we will have a look at the second part. What is DML commands? That is data manipulation language. So let's go back to the presentation and let's have a look at what is DML command. So here we can see DML basically stands for data manipulation language. This DML commands handles all the data manipulation part. Let me give you what is actually data manipulation stands for. Suppose you have a table and now you want to insert some data to your table. How can you do that? Using DML command. Or if you want to get some of the particular data from your database, how can you do that? Using DML command. So this is how DML commands help us, or DML language help us to manipulate our data, right? And it also includes most important parts of SQL. So let's have a look at what are the DML commands we have in MySQL. So we have insert command, we have update and delete command. So when we use the insert command, right? So insert, from the name you can understand that when we need to insert data in the table, that time we need to use insert command. And when do we need to use update command, right? So we use update command if we want to change the table structure or if we want to change some of the data in the existing table. That time we need to use update command. And lastly comes delete. So when we use delete command, so we use delete command when we want to delete a particular data from the database. So we will see first how can you use insert command, and then we will see how can you use DQL command. So basically after using DQL command, we can use update and delete command as well. And we will do all the commands practically in MySQL Workbench. So let's go and see how can you use insert command to insert data in your database. So you can see I have already written my command or the language that how can I use insert table. So we know we have a table called student table. and we know what are the attributes we have for that particular table, right? So we have student ID attribute, we have student name, course name, and email. Now, if you want to insert them, you need to write insert and then you need to put into, right? So this is the basic syntax of how can you insert data into your table. Then you need to provide what? You need to provide the table name. My table name is student table. Now in the bracket, I am going to say, okay, what are the attributes I have and what are the attributes values I'm going to give. So I have attributes called student ID, student name, course name, and email. So these 4 attributes I'm going to give data for them. Now, whenever you're going to give the data for all of them, you need to write values, right? So in the values after the bracket, you need to provide for the student ID I have provided, it is 1. Then for the student name, I have provided the name of the student is Prakash. Then course name is C1002. And lastly, we will have the attribute called email, that is prakash@gmail.com. So this is how we can use our insert command, right? And like the same way, you can write the you can insert thousands of data into your table. Okay. Now, maybe I'm going to write more data for your convenience, that how can we actually add more data, like millions of data in MySQL, right? Okay. Now I'm going to change all the values for them, right? 4, then maybe Shilpi, and then C1106, and then Shilpi@gmail.com or Shil123@gmail.com, right? And here again, we are going to change the data. So we don't want redundant data. So in that case, try to give all the unique data. But wait, we already have learned about primary key. In the next step, I will show you how actually we can use primary key. For that, it reduces the redundancy of the data. And every time it makes sure that your rows value or your rows data is unique, right? Firstly, have a look at what are the commands we have and how can we use that commands. Then we will go for making a table with the key concept we have learned, right? Now, I am going to write Rima, and the course ID should be unique, right? Yes. So this is how we are going to add some of the new entries. These are actually known as entries as well, right? So data we have inserted, that is known as entries when you go for industry level. So that time they call these data as entries, right? So there, and maybe this is 8 and this, right? So in this case, we are going to use only the insert command. After learning some of the different SQL commands, we will go for using update and delete command as well, right? Okay. Now, let me just run this. Yes, you can see you got a message that one row is affected. When you got this message that one row is affected, that means your query get executed. And this is already stored in your data. But wait, I have inserted the data. How can you see that, like in what manner my data gets executed or my data gets stored, right? So that time the DQL commands come into the picture. So let's have a look at what is DQL and what does it stands for, right? So let's go back to the presentation and have a look at what is DQL command. Now we will have a look at the types of command in MySQL, the DQL one. So basically, DQL stands for Data Query Language. And this DQL used to make a queries on data within schema objects. The main focus on DQL command is to get some schema relation based on the query passed into it. And we have one command under DQL that is called select. This select command is the best or is the key for all the query you can say, right? So whenever you want to fetch data from your database, you need to use select commands. So let's go to the MySQL Workbench and let's have a look at how can we use select command. Now we are going to use select command. So I need to write select, right? Then what I'm going to write? Maybe if you want to get one particular column or attribute from your data set, you need to specify that. Maybe for my case, I want student ID. All the student ID I want to see, right? Okay. from, then you need to write a from command. So this is basically where you want to fetch the data. From which table? I want to fetch the data from student table, right? Okay, let me execute that. Yes, you can see I have got all the data for student ID. Now I want to see the course ID as well. So in that case, or maybe the email. So in that case, I need to write email and then I need to execute the same command. So you can see we have got the result for student ID and email both. Let me just minimize that. Yes. So you can see we have got this. Now, if you are going to say, okay, I want to see the course name as well, right? So samely, you need to write course name, the attribute name. Be sure whenever you are going to write the attribute name, they are perfectly correct. Otherwise, it will not fetch the data. Okay. So let me execute that. Yes, you can see I have got the result, right? Student ID, email and course name. Now wait, I want to see all the data, not the particular attributes data. How can I do that? Do I need to write all the data, all the attributes, each of them, like every time I need to write all the attributes name? This is hectic, right? But no, you don't need to do that. What you need to do, you need to write just a star, right? This star is basically fetch all the columns from the data set or the data from the table, right? So I need to write select start from student table. Let me execute that. Yes, you can see I got all the attribute I have. Sorry. Okay. So all the attributes I have in my table, right? So you can see I got student name, course name, student ID and email, right? Okay. So basically if you drag this, you can change the column name according to you, your users, right? So basically I got student name, student ID, course name and email. So this is how we use our select command, right? Now we will have a look at the next command we have in MySQL. So let's go back to the presentation and let's have a look at what we have in the next. Now we will have a look at the next command called DCL. This DCL command is basically try to control your data, and this stands for data control language. Basically, it deals with the rights and permission of the database. This works for controlling part of the data. And if you want to control your data, you need to use DCL commands. So let's have a look at what are the commands we have under DCL. So basically we have grant and revoke. Two types of commands we have. So basically what grant stands for, right? So this grant command provides users access privilege to database. So if you want to give some access to that some particular user, you can give them using grant command. When comes the revoke? Revoke is basically if you don't want to give your database access privilege to some particular person, that time you can withdraw that privilege using revoke command, right? So this is what stands for DCL. Now let's go back to MySQL and let's have a look at how can we use delete command that comes under DML, right? So we will have a look at how can you use how can you use DML commands. So here we are going to use delete. But how can you use delete? And what's the difference between delete and truncate as well, right? Okay. So here I'm going to show you the truncate command that I have said. I will show you in the later part. Okay. So, and the delete we are going to see what and how delete is also working. So first let's have a look at delete. So how can you write delete? So first you need to write delete command, then you need to write from, but where? From where you need to delete, right? You need to write the table name. So for my case, table name is student table. Let me just execute that. Okay. Fine. So basically when I was trying to delete my table, that time I was getting a safe update mode error. So what you need to do in that time, right? So if your SQL Workbench or MySQL Workbench is a safe update mode, that time you cannot delete anything like without any clause, right? Without any condition. So in that case, what I was doing, so that time you need to write a command. What command you need to write? You need to write set SQL safe updates equals to 0. So basically when you are going to use this command and execute this, you can see 0 rows affected, but your command get executed, right? Now let's have a look at what we have in our table, right? So using select star from student table, we are going to check that. So you can see we have this, that student ID, student name, course name, and email, right? Now, what I need to do, I need to just execute my delete command. Again, how can you write the delete command? We need to write delete, that command, and from where you need to delete. I need to delete from student table, right? So I am going to execute that. Yes, you can see that 6 rows affected. Why it's showing 6 rows affected? Because you have 6 rows in your table. So it's got deleted. So let's have a look at actually it's deleted or not, right? Okay, let me use the same query, that select star from student table. I already told you guys that this select command is basically your like pathway or your everything when you want to retrieve your data, right? So anyway, if you want to retrieve your data, you want to see your data, if you want to manipulate your data, you need to use the select command, right? Now let me just execute that. Yes, you can see I have my table structure, right? But I don't have the data under my table. So this is how delete commands work. Now let me again insert all my data and try to execute truncate command, right? Okay, I am again going to execute all the insert command that I have inserted before. Okay, so let me just execute that. Yes, you can see 1 row is affected. Now what we need to do, we need to again use select star from student table to understand actually data got inserted or not. So as we got the green tick, that means our data got inserted. That's for the second checking. So you can see we got total 7 records in our data. Now we are going to use the truncate table. How can you use truncate table, right? So using truncate table, you need to write truncate, the command, then table, from where table you need to, which table you need to truncate, right? So the table name, for my case, student table. Now let me execute that. Now I already have shown you guys that in the truncate table schema is there. But what is got deleted, right? So basically, again, we are going to use select star command. That's select star from student table. Okay. Okay, I need to go down. Okay, I just changed my, okay, fine. Now, what I need to do, I need to write select star from student table, right? Let me just execute that. Yes, you can see I have this table schema, not the data under table. So this is how delete and truncates work. But wait, what's the difference between delete and truncate? If we can do the same thing using delete, why do even need to go for truncate? So let me give you an example. What's the difference between delete and truncate? Now I will give you few examples that what are the difference between delete and truncate. So the basic difference between delete and truncate is when you use delete, it is used to delete specific data, right? Here I didn't give any conditions. Whenever we are going to give some conditions, maybe a particular row you want to delete, right? So that time you need to go for using delete command. But when comes the truncate, it's to delete the entire database of the table. So if you want to maybe delete one particular row from your table, that time you cannot use truncate. You need to use delete command. Now let's have a look at when we have where clause. So I will give you an example where we are going to use where clause and what actually that where clause stands for. So when we use where clause, with the where clause we can use delete. But for the truncate time, whenever you are going to use truncate command, that time you cannot use a where clause. So basically where clause help us to give condition to do some particular work. But as we know in the truncate is not going to listen any condition. It's going to delete all the records from your data, right? Now comes the locking part. So when it comes to a delete, it locks the table row before deleting the row, right? But in the case of truncate, it locks the entire table. Okay. Now comes the rollback. So what is rollback? So rollback is basically if you want to roll back your data. But using delete, you can roll back the changes, whatever you have made. But using truncate, you cannot roll back your changes, right? Now the performance for delete is really slow, but for the case of truncate, it is faster than delete. So these are the basic difference between truncate and the delete command. Now let's go back to the presentation again and let's have a look at what other type of commands we have in our MySQL. Now we will have a look at the other command type we have in MySQL. That is TCL command. But what does TCL stands for, right? TCL is basically transaction control language. It helps you to control the transaction. We have commit. So why do we use commit command? Commit is basically used to commit a transaction. Then comes the rollback. Roll back a transaction for any error occurs. If you have any error, that time you can use rollback transaction command. Now comes a save point. So basically save point uses save point within a transaction. If you want to create a save point within a transaction, you need to use the save point command. Then lastly, the command we have for TCL, that is say transaction, is basically used to specify the characteristics for the transaction as well. Now we are going to use a filter. So in this filter, using this filter, you can start doing the, maybe you don't need the all records you have in your data set. Okay. So what you need to do, you just need to just pick the specified data from your database. How can you do that? That time where clause comes into the picture. So basically where clause is used to filter the record from the data. We use where clause with select command. Right? Now we are going to talk about SQL case statement. So yes, this is one of the most used way. I mean, when you try to work with any big companies, that time you have to work with case statements. But what is this case statement? For the beginner, maybe you don't need to use the case statement, but when you go for writing some big query and you need to give some if-else statement like some conditions, that time maybe you need to have a proper case. Okay. So let's have a look at what is case. First, the case statement reads through all the conditions and return a value when the first condition is made, like an if, then else, then if else, right? So yes, if you are going to give this if else and if then else statement, you have to use case, right? So and your case reads through all the conditions, right? So first it will read all the condition you have given and then returns a value when the first condition is met. So if it's gonna meet any condition, then only it's gonna give you the results. As always, we can see in the SQL. Now, when a condition is true, automatically it will stop reading and return the results, right? So suppose you give if and then you said, hey, if your age is this, then it's gonna give you this results, right? So that time it will say, okay, this condition is met and okay, I need to give the answer for this. And it will stop the execution. It will give the result first. Then again, if no conditions are true, then it will return the value in the else clause. So first it will go for if. As we know, this if and else statement works in our normal programming language. So it's like that. So if no conditions are true, then it will return the value in the else clause, right? It will go to the else clause. If there is no else part and no conditions are true, it returns null. Okay, so if you give only if and you did not give any else part, that time what is gonna do? It's gonna say, hey, I don't have any else. I don't have any other conditions. It's true. Whatever you give, I am gonna return null. So this is how your case statements works, right? So let's go to the MySQL and let's work with few case statements and try to understand how this case statements works, right? As we are learning the beginning part and we are learning the very basics, like how this gonna work, how you can implement them. Later in the section, we are going to do few projects to understand, okay, I have this database and how can I work with this concepts, right? So that time we are going to merge all the concepts together and then we are going to, just attack the project and we will try to solve all the statements, right? So it's going to help you to understand SQL better. It's going to help you to, solve different types of query and how can you deal with the, some serious, some difficult query, right? So let's go to MySQL Workbench and let's have a look at how we can start with case statement. So we came to MySQL Workbench and now we are going to talk about how we can start off with this table itself. So as you can see, we have this table called select star from. Already we have two tables. We are working with two tables, and one is data of customers and account table. Now here we are going to do few things. What we are going to do? So if you can look at it, first you need to use select. But why? But if you need to fetch any data in MySQL, you have to start with select, right? So you have written select. Then what are the attributes you want to go for? So you have customer ID, if name, that is your first name, age, right? So you want these three field to be like, based on your case or your conditions, right? So you have written select customer ID, first name and age. From there you have written case. This is the syntax starts where you need to write case. And you have said, hey, when age is greater than 30, then you have to write age is greater than 30, right? When you say age, when age is equals to 30, then the age is 30. Is the age is not group of 30, right? So this is a very basic, there's a very basic case statement we have written. We will do some more and you will understand more well, right? So if you can look at when, then, lastly you have else, right? Then you have to write end as how. I mean, it's gonna give you a total column, right? So that time this age is greater than 30, the age is 30. How you can do that? To doing that, you need to write end as age, right? Your column name will be age. And you have to write this way, okay? And lastly, you need to write from where you are giving this data, this conditions. You are giving this condition from data of customer, right? So this is how your case statement works. If I can execute the whole statement, first you will understand that how it's going to work, and then we will do few more case statement and you will understand that how this case concepts working, right? Yes, can you look at this? For each and every one, we got the customer ID, first name, age. Now you got age. Maybe I can write age information, right? So we are going to get to the same column, right? I don't want that. I want to be age information. Yes. Can I look at this? First one, the customer ID C001. First name Ramesh, age is 45. So which one is gonna work with? Age is greater than 30. As you can see. Now we have Avinash. That is the age is 32. That is also comes in the first one. The age is greater than 30. Then we have Rahul. But the Rahul age is 24. Right? Which is not equals to 30, which is not greater than 30. So it's gonna say the age is not group of 30. Right? Now we got Parul, and this is C0004. The age is 46. The age is greater than 30. Right? Obviously 40 is greater than 30. Now we have Navin, which is not the group of 30. We have Chitresh, we have Amit, Nisha. So for all the data you have in your data of customers, it's putting all the conditions you have given so far, and it's making a new cell, a new attribute, right? A new column according to the based on your conditions you have given to info. So this is how our case works, right? So we are going to use one more, and maybe we are going to use with 3, 4, and then we will have a look at how these how these case studies are working. I hope you understand how these cases are working. So these cases you can use after order by as well, after select as well. So there is a flexibility using this case. Right? So if you are going to use case, you can use this case concept after select, after order by, after group by, everything. Right? Okay. Now we will have a look at how you can, order by your CT. Okay. So you can see select. I am going to say select first name, age from data of customer, then order by. What order by? Why we use order by again? We use order by to sort our data in ascending order, descending order. So I said case when CT is null, then no CT. Okay. Else CT. Okay. So as we have all the CT, it's gonna say, hey, you have CT for all the customers. There is no way of using main clause, right? The CT is null, right? So if you can look at it, the Shankar is from Chennai, Ramesh is from Delhi, Avinash is from Delhi, Rahul is from Delhi, right? So this is how your cases are going to work. So if I get going to write select, let's have a look at what we can use else in the case, right? So data of customers, maybe we are going to write, and I'm just trying to figure it out what we can add over here, right? Okay, so maybe we can say that whatever the customers you have from Delhi, so your customers from Delhi, if you are having Mumbai and Kolkata and Chennai, maybe we can do one thing. Mobile number is also there for everyone. Maybe we can segregate the customers using occupations, right? Yes, right. So maybe we are going to say student, we are going to say service or housewife, right? So you can segregate the student on like that. So anyway, you can use group by, but if you want to use a case over there to do that, you can do that, right? Let me just do that. Okay. I am going to copy this. I just don't need to write the whole thing, right? What do you need to write? Select customer ID, or if you can work with star, right? I don't know it's gonna work or not. Okay, select star. No, it's not gonna use that star part. Okay, so I need to write, I want this to be customer ID, if name, age, and occupation, right? I want to see the occupations as well. Occupation, and then when I said occupation is equals to, right? Let me just write. Occupation is equals to service. Then you are going to say the person works in a organization. Works in an organization. Right. When your occupation is equals to, let me just copy this, as equals to student, right? Then the person is a student. Else, the other occupation. So basically you want to see, okay, and as occupation information. Okay, let me just execute this. Yes, we got it, right? You can see for service we get the person works in organization. For student we get the person is a student. For housewife we got the other occupation, right? So yeah, this is how this whole case concept works, right? Yes, so let's go and let's have a look at what else we have in our next in presentations, and I hope it's actually helping you to understand how this case is working, how the subquery, and what's the difference between, the main question when we go for some interview. I mean, in the last intersection, maybe we will talk about some interview questions as well. So if you go for any interview, what I face, like you need to understand the basic queries. I mean, at any way, if you are clear with your basic queries, you can go for some complicated queries. I mean, it's all about you need to put your heads down and you need to understand that how this is going to work, right? But if your base is not clear, how can you just try to think about which query you are going to use, right? Yes, so in that case, you have to have a good idea about the basics part. So if maybe if you think like, why do I need to create table every time if we go for any operators or, for SQL joins, for other things. But yes, if you are actually practicing this creating table, understanding databases, and creating databases using the basic commands to understand the the whole complicated command that actually help you to understand the basics very well. And when you are knowing the basics very well, and hey, I know the basics, I know how this is gonna work, you can just give me any complicated query. I know how can I actually break those query, and how can I start with the very basics one, right? So this is why we really need to understand each and every concept very carefully. Right, so now let's go back to the presentation and let's have a look at what is view and why do we need to use view, right? So let's go to the presentation. Now we are going to talk about view. But what is view? View stands for virtual table, which is based on the result set of an SQL statement, right? But why do we need view again? Just let's have a look at why do we need view. So normally in view, it contains row and columns, which is like a real table. It's like a real table if you're going to create a view. The fields in a view are from one and more real tables in the database. So maybe you want to say, hey, I want to make a table from different attributes from different table. But it will not be a real one, but it looks like a real table. Yes, that time we go for using view technique. Right, so let's go and let's have a look at how this view are working. Okay, we again came to the SQL Workbench. Okay, so if you look at creating view, you need to write create view. The first, command that create view, and then you have to give a view name. So aged customer, right? So I just want to say before 40, like after 45, the customers are not in a young group. Right, so you make, okay, this is the aged customers. The view name will be aged customers, and select what after that you need to write as, okay, as a alias, right? Then you need to write select first name, age, and city. You want first name, age, and city from data of customers, okay? So where age is greater than 45. Okay, so I said, hey, I just want to create a view which is the age is more than 45, and I want to see all the customers. Right, it will be like a real table, right? Let me just do that. Yes, now as we say, this view is already created. Now we need to talk about aged customers, right? Select star from aged customers. It's already like a table. If you can look at Parul, Amit, Abhishek, Shankar, they are actually more than 45 and they are going to be in the view. So Parul is age is 46, Amit is 76, Abhishek is 67, and Shankar is 90. So this is how your views are going to work. Let's have a look at the data of customers, and maybe we can make some more view. Okay, we can start with the city. For city, the Delhi one, we want to see all the Delhi customers, right? So here, if we can write the same one, and just let me just try this out. Create view Delhi customers, right? I want to see all the Delhi customers as select if name a city when city is equals to Delhi, right? Let me just create this view. It's already created. Now I need to write select star from Delhi customers. Again, it's not case sensitive. Okay. Can you see all the Delhi customers you got? Ramesh, Avinash, Rahul, Parul. They all are from Delhi. Yes. So this is how your view works. But if you write this show table, see, maybe you can say, hey, I just want to see the tables is already created or not. Let me just execute this. Can you see? This view is already there. These are tables, but this is views, right? This is the views, okay? So whatever you have created, it looks like real table, but it is views. This is not like real table, okay? Yes, so this is all about, we have learned about views, we have learned about cases. This is very advanced topic in SQL when we start talking about this, what are the case and what is going to use if, else, then. So these are the cases, subqueries. So basic three things you have to have very good understanding on, very grip on. First is, what is SQL joins, and second one is what are the subqueries, right? Correlated subqueries and other type of subqueries, and then comes the cases. Right, this is the main key points to manipulate your data. Okay, so yeah, now we are going to talk about what is ER diagram, because why do we need ER diagram and all. We will again talk about all those things. But before start with any project, you need to have a good understanding of ER diagram. Right, now in this part, we are going to talk about the project 2, that is Azure Database Management System.
After getting hands-on with MySQL and understanding its core functionalities, including the SQL case statement and views, it's time to dive into subqueries. Before that, tell me which one you prefer, SQL or MySQL. Drop your thoughts in the comments below. Subqueries are powerful tools within SQL that allow you to perform more complex and nested queries. In this section, we will explore how to use subqueries to retrieve data more efficiently and solve intricate database problems, enhancing your querying capabilities in MySQL.
Now we are going to handle a problem. But what problem it is? So if you have 2 or more queries, how can you handle them, right? Do I need to write 2 separate queries, or what will be my way of doing that? Right? Suppose you said, okay, I have a customer table or I have a demo customer table. So I want all the customer whose age is more than 45, and I want in the customer table that those will be updated, right? So how can you do that? So doing that, we need to use a concept called subquery. Now we are going to look at what is subquery. Subquery is a SQL command again, which is nothing but a select query that contains another query inside. Oh my god, but how it works, right? It's not that complicated. Go with one by one. What is subquery? What are the types of subquery we have? What are the parts we have in subquery, right? Let's go and let's have a look at how many parts we have in subquery. So basically, we have 2 parts. One is inner query, one is outer query. So we have 2 parts in subquery, right? We will do the demo on that as well. Now, first, we are going to look at how the subquery executes. Yes. So first, whenever you are going to give an inner query, it gets executed. Then, it will take the result from the inner query, because in SQL, you cannot hold your data, right? So suppose you want to take a, output from one particular table and you need to use that to the other particular table. So in that case, you need to go for using join or else in the subquery, right? So again, first it will execute the inner query, then it will hold the data of the inner query, then the output of inner query added to the outer query, right? So whatever the result you get from inner query, it will be added to the outer query. And then outer query will get executed to get the final result, right? So at the end of the your execution of outer query, you will get the final result, right? So this is the process of how subquery executes. Now we are going to talk about what are the types of subquery we have. We have 2 types of subquery. One is nested subquery and the second one is correlated subquery, right? So what is nested subquery? So nested subquery first executes the inner select query, right? It will obviously the way we saw. So it first executes the inner select query and then within the returning values executes the outer query. So if you look at it, don't think about all these complicated terms. Think of first you execute a query, you got an output. From there, that output you are going to use for the next query. So that your next query will be your outer query. Now comes the correlated subquery. So a correlated subquery reads every row in a table, right? It's gonna read every row you have in your table and comparing values in each row against related data. Okay, so first it will read all the rows in the table, then it will compare each row. right? Each row with each other against the related data when your data is related. So this is the two types of subquery we have, right? Now, what we are going to do? We are going to do in MySQL Workbench, and let's see how can we do the subquery. Yes, because there are lots of things we can do with subquery as well. Right, now for the subquery, I am going to take these things again. So what we can do for subquery, let's start with the simplest one, right? Okay, so, right. What we can do? Yes, right. We can insert customer. Maybe we can make a demo of customer or demo of customer table, and with the filter data we can make a table as well, right? So maybe here, let me just copy this, right? So why I am making the separate file? Because I don't want this to be very, like already we have done the join in the previous one. So here I just want to make it in a clear picture. So here what we are going to do. Okay. So I have a table called demo of customer, right? Demo customer. Here I am going to make a table again with the same structure, right? Okay. Now, but we are not going to add all the data from that particular demo customer. Here, my table name will be customer. Okay. Let me just create this out. Okay. Yes. You can see it's already done. So again, if you want to check your table is created or not, show tables command. So these are the basic commands again you have to understand. Yes, you can see customer and demo customer. Now I want to insert data, right? The same command we are going to use, insert into, right? Then where you need to insert? I need to insert my customer table. Then your inner query starts. You need to write select, right? This is your outer query, insert into customer. Then your inner query starts, right? So your inner query, you are saying select star. So basically you want to select all the thing from data of customer. Here you can write demo customer, right? Where age is greater than is equals to 45. You want all the data. Maybe you are making this for the senior citizens, or like, the age range is like greater than 40, right? So in that case, you say insert into customer. So basically insert all the data to my customer table, select star, right? So select all of them from demo customer. So your table name was demo customer. So select all the data from demo customer where we use where clause where age is greater than is equals to 45. Let me just execute that. Yes, you can see 5 rows affected. Duplicate 0, warning 0. Now I want to see what is inserted in my table customer. So again, I am going to write select star from customer. Let me just execute this command. Yes, you can see that I have 5 data in customer table from demo customer 1, 4, 7, 9, 10. These are the customer ID. So if name is Ramesh, Parul, Amit, Abhishek, Shankar, right? Whose the age is basically 45, 46, 76, 67 and 19. Right? So all the age we have that is greater than or equals to 45. Right? So this is how you can use insert command with the subquery. Right? Now we are going to use the update command. Okay? So maybe I want to update the age. Okay? So in that case, what you need to write update. So basically, whatever the command we have learned so far, I am just trying to use those commands in subquery. Right? So if you look at the query, you can see there are 2 particular parts you have in your subquery. So some of the cases, maybe you will have 3 queries at a time. So these are known as subquery. right? So I have written update. So I want to update something. Update in where? Update in customer. Update customer, set age is equals to maybe 45 or age plus 2. I just want to make them plus 2 too. Where age in we use in for what? Okay, let me just show you why do we use in. I think we have done this, but still, just for the recap from demo customer, where age in, okay, 45. Okay, right. But we got the error. But where we got the error? Because we can use this in, right? This in over here. In is basically when your age is equals to 45, or it's like there is a range you have. Okay? Greater than 45 or less than 45, right? Greater than is equals to 45. Let me just execute that. No, it's not. Does not exist. Okay. I need to change of demo customer. Again, you have to be sure that what are the table you have, right? Otherwise, you will get the error. Yes, you can see this is done. So let me just tell. Okay. Now select star from customers. You don't need to do. Okay. Yes, can you see? My data is updated. That is, my age becomes first one was 45, it is 47. Then it was 46, it's 48. Then 90, Shankar was 90, now it's 92. Right? So this is how our update commands work with subquery. Right? So we have learned about insert into, we have learned about update. Now we are going to delete some data. Okay, so how we can do that? So for that, I said delete from customer where age in. So if you look at this, why do we are using this in? So in is basically the range of data set you have. So if you want this to check it out, okay. Let me just do that. Control B. Okay, let me just put the semicolon as well. Okay, I again don't have data of customer. I need to write demo customer. Okay. Yes, you can see we have this. So we have a range of data, right? We don't have one particular data. So I say delete. Then now delete from my table customer where age in, your age is in. Select age from data of customer is greater than is equals to maybe 60. Right? I want to delete all of them. Yes. Okay. Again, the same problem. Demo customer. Right? Let me just execute this. Yes, 0 rows affected. But why 0 rows affected? Let me just go over here. Right. We have customer. Okay. So here, if you can look at here, you can see select a star from demo customer. Right? Let's have a look at what are the age we have over here. Yes, we have 45, 32. Yes, right. Now, what I want to do, I want to see from here. All right, let me just do that. I want to see what are the ages we have when the age is greater than or equals to 67. I think 2, 3 data will have. Yeah, 3 data we have, right? Now, what we need to do, I say delete from customer. Yes, let me just try this out. Okay. Okay. No, but why? Again, why I am doing this? Suppose you want to delete from a particular table and you are giving the condition to that particular table, right? It will not work out. So what you are need to do, right? Select age from demo customer where age is greater than is equals to select age is greater than is equals to 60, right? Let me just do that. Yes, it's going to execute it, but we don't have any data which is actually greater than is equals to 60. That is age from demo customers. I give that condition that, okay, if you have any age, right? Like this, if you have age that is, let me just print the name as well, right? You will understand, identify the data itself. Yes, if you can look at that, we have Amit, Abhishek and Shankar. Okay, suppose if we are going to look at select star from customer, the same thing, right? It will be the same thing. Okay, this will be customer. Okay, let me just do this. Amit, Abhishek, Shankar, right? So basically what we are saying, okay, first let's check that if there is any data we have that is greater than is equals to 60 or not. If we have any data, then please delete them from customer, right? So this is basically where delete from customer, where age in, your age will be, like the range of age will be demo, like it will take the data from demo customers where age is greater than is equals to 60, right? So basically using this subquery, you can insert the data, you can delete data, you can update data as well, right? Yes, now we are going to use one more technique. What is that technique? So if I come to here, so you can see, let me just use this part, demo database. This is also only you are using, right? Okay, so here what I said, select star from customer, all the data I want from customer, where customer ID, my customer ID. So if you write this, select star from demo customer, right? Let me just execute that. Yes. Okay, so just write over here, use demo database, right? So maybe I am using the separate file. So okay, I see, right? I have written down demo customer. Let me execute that. Yes, we have this. Now what I said, select all the data from customer where customer ID in, select distinct customer ID from customer where age is greater than 25. Okay, so how it's gonna work? Okay, just let me just execute one query first to make you understand how it's gonna work. So okay, write it over here. Select distinct. What is distinct stands for? If we just don't write distinct, right, we are going to write select customer ID from customer where age is greater than 25. Okay, let me just execute that. Yes, we have this customer IDs, right? Comma if name, if I'm going to write. Okay. Yes, you can see I have customer ID, if name, and these are the customers we have greater than equals to greater than 25 age, right? Now I said select star from customer, okay, where customer ID in. This will be your condition. Let me just execute that. Yes, you can see I got all the data. And if we just remove distinct, so distinct is basically getting a distinct value. So there is no duplicacy. You can see we got it. Age is 47, 48, 78, 69, 92. So this is how your subquery works with select command. From both the cases, we are going to use select command, right? And in is basically it will go with the range of data set. So if you write is equals to, it will work with only one data, right? Okay. Now what we are going to do, we are actually learn about all this, this how this delete works, how this update works, how this select works, and insert into as well, right? So these are the quite of nested query as well as correlated query. So we do have lots of other options, like later in the tutorial, we are going to make some project and we are going to feed data in a complex table as well. That time you will understand more easily how these concepts are working.
Having mastered subqueries and their ability to handle complex data retrieval, we are ready to move on to Oracle SQL. Oracle SQL is a powerful and widely used database management system known for its robustness and scalability. Next, you will learn how to apply your SQL skills within the Oracle environment, explore its unique features, and understand why it's the preferred choice for many enterprise-level applications. By the end, you will be well versed in leveraging Oracle SQL for advanced database management.
So now that you are beginning with our particular Oracle SQL tutorial, the first topic is introduction. So let's see what is there in this introduction. Now, let's say that we have a particular student in a college, right? And we want some information from that particular student. So what we will have? We'll have his name, maybe his roll number or registration number, and then we'll have some address, right? And then maybe the contact number, right? Or let's say mobile number. So these are some of the information which we want from this particular boy, right? Now, if you can see, these all informations are nothing but what? So these are called as data, correct? Now, why I'm telling you what is data? Because there's a lot of difference between data and database, correct? So now, first of all, we need to understand that what is the difference between data and database. Data is something which is very particular about one person or one particular individual. Now, if you talk about a college with a group of students, and I want those group of students all details, that means I want his detail also, her detail also, her detail also, and his details also, right? Now, obviously, all of these people, all of these students, name, roll number, address, mobile number, I want it, and it will be a huge data, right? That means I have to create some table, and inside that I have to write all these informations, right? To make it look very structured, correct? And that is what is nothing but database. So that whole table is nothing but now database. So if you talk about data, data is one particular information, but database is a group of information, correct? So this is what is the difference between both of these things. Now, if you're very sure about what is data and database, now you must be very sure that why it is called as Oracle database and not only Oracle data, right? Okay, let's move to the next part. Suppose if I ask you that how you will manage this particular data or how you'll manage the database, how will you do it? So let's say that I want to record my information somewhere. So what I'll do, I'll take a sheet of paper and I'll write my information there, right? Correct? But does that sheet of paper will be maintained 20 years after or 30 years later? Will it be the same? I don't think so, right? Because it's just a sheet of paper, correct? Now, how we can manage those data? How we can do that? Now, obviously, in your mind, one answer will be coming, which is computer, which we actually save our data. Right now, also, if you're using a laptop, you have many of your data or information, your music file, video files, images, everything is stored in your laptop, right? Okay, so how to manage? Managing refers to storing permanently and retrieving efficiently. Okay, now managing doesn't mean that you're just storing it, but it also means that you are retrieving it efficiently. Let's say that I have a bunch of students and I want all students' record details to be in a sheet of paper, right? Now, one particular student detail in a sheet of paper is perfectly fine. But when you have 50 or 100 students' details in a sheet of paper, it becomes a little bit messier. Why is it? Suppose that I have a 2 sheet of paper, and in those 2 sheet of paper, I have all the data of my batch of students, all my 50 to 100 students' details, right? Now I want to find the detail of one particular individual whose name is Rohan. Now I need to search from starting till the last, where is Rohan detail? And it'll take a lot of time. That is what is retrieving. So retrieving the data is not efficient here, right? And that is what we need to also look upon. So a sheet of paper will not work here. Now, the question arises is, so then how to store data, a small volume of facts permanently, and how to get the stored facts efficiently? Or the another question is how to store database, which is large volume of facts and figures permanently, and how to retrieve those efficiently, right? So these are the two questions which we need a solution now. So let's go back to some early 90s or a decade ago, and let's see what happened there. Now we used to use a ledger. So if you know what is a ledger, if you go to a hotel restaurant right now, also in many parts of India, people are using ledgers if you go to a hotel to stay, right? Now ledger is something like a very big and thick diary in which they store all the informations, correct? Now most of the modern hotels and all, they are using tab and pads and obviously the laptops, but many of the places are still using the ledgers. In ledgers, they actually record all of your data and then they use it for next purposes, right? Or to store data efficiently. But now, let's say that I have a ledger and I'm storing these particular data of some students in my ledger, okay? Now, in the below ledger, one page has data, right? One single page has the data. But if you talk about the book, the whole book is nothing but the database, right? If you can see, all pages and many books put together forms database, which is large volume of facts and figures. Now, is this a correct idea, or is this a great idea to save our data or to save the database? Let's see. Problems associated in managing data or database are as following. Now let's understand what are the following challenges. So we have security challenges. Obviously, why security challenges? Because to save these ledgers, we have to have a godown, or we have to have some place where security is there, right? And we cannot just assign one security guard to actually look upon all the ledgers, right? Not a very great thought, correct? Now, backup issues. Now, suppose that you have a 10 years ledger, okay? 10 years ledger means a lot of books and a lot of ledgers, right? Now, how you can back it up? That means, obviously, you won't be keeping all those ledgers for 10 years or 20 years in your godown, right? It's just a sheet of paper, or it's just a diary, right? It can get rotten, or anything can happen based on weather conditions, right? It will not be safe inside, right? So how will you back it up? You can't just make a new diary or make a new ledger and copy all the information in the earlier ledger to this new ledger. You won't be able to do that because it needs a lot of effort. It needs a lot of resource. It needs a lot of employees to do that, right? So nobody will copy all the content of the old ledger to a new ledger, correct? Imagine you are just writing and copying down all the things from new ledger to a old ledger. It doesn't sound good, right? Next is space issues. Obviously, all the 10 years ledger, 20 years ledger, you won't be able to keep it somewhere. It's not a great idea, correct? Human resource issue. Again, you need a lot of people to work around this ledger to keep it safe, to keep the data secured, right? It should not happen like anybody will enter your godown and anybody can change the ledger data. They'll cut your name and they'll write your name. Something like that. It should not happen, correct? So it's not safe. It's not secure. Now, costly. It's very costly because you have to buy the ledgers. You have to keep it safe. You have to have human resources. You have to have most of the people around those ledgers to keep it safe and secured. Inefficient in retrieving facts. If you want to search some of the details, what do you have to do? You have to tell the particular people that, hey, I came to this hotel long back ago and I want to search those details. Now, can you please show me? The hotel manager will go to their godown. They will bring that particular ledger down, and then they will search. If this is not the ledger, they'll go to the next one. If next one is the ledger, they will again scroll to all of the 100 pages and they have to search your name. And it can happen that we have the similar names like Ritvik many times in the ledger. So you have to find out which particular Ritvik you are, correct? So like that, it will take a lot of effort, a lot of time will be wasted in searching or retrieving the facts or data, correct? So these were all of the issues. Now, computer came into existence looking into these all problems in 1940, right? But computers were very costly, very heavy, and very expensive, right? So people did not think of using computers, but in late 1950s, computers prices came low as compared to 1940, and people thought of using computer to manage facts and figures. But there were no means to do it. Now, what is the meaning of no means to do it? Let's understand pointer by pointer. Now, in 1960s, high-level programming language developers suggested to make use of programming language to manage, store facts and figures. Now I think we are close enough to the era that we are talking about, right? But we were having a lot of problems in this particular era also. Let's understand what are the problems. So in programming languages, we use a concept called data type, variables, arrays, right? And one can make use of it to store the facts and figures, right? Now, don't you think that people in that era were having so many problems around using computer or working with computer? People are very happy because computer do not have disadvantages like ledgers, and now they have a way to store facts and figures in computer. And they started to store facts and figures in computer using programming languages. But as the size of facts and figures increased, programming language failed to manage it. So programming languages are also bound to have some limited capacity, and that is why these were also now not very much efficient. Programming languages are successful only in managing data, but not database. Okay, so using programming language, you can save some of the data, but not a huge database. Now, this is where the concept of software comes in, which is database management software. So this is one software which is used to manage and store data permanently and retrieve the large amount of data efficiently. And this is what people were looking for. Now, this particular has many examples right now. We have Oracle database, MySQL database, DB2, Informix, and there are a lot more. So this is one of the particular software which we now use, right? But now understand what is the difference between this and the ledger and the computer programming languages. Let's understand that, because this is what will lead you to Oracle DBMS, and that's how you will actually use that particular software. So suppose we have a ledger and we are saving these informations, right? So these ID, name, age, gender, marks, send, these all are called as fields. So we have all the fields, and then we have all the values, which are also called as data, right? So these are the two main things which we saw in the ledger. We have only two main things which we need to save our data, right? Keeping this fact in mind, people came up to an idea that how we can actually save this field and value into a hard disk of the computer, right? Because all your data will be saved in the hard disk of the computer, right? So a hard disk is nothing but where all the data are saved. Now, how we can actually take this field and value and put it inside the hard disk? We can't do it like manually, correct? We can't do it like that. So if I have a hard disk, we can't put this information directly into our hard disk. We need something. We were using programming languages, but programming languages are not accessible to actually capture all the database or all the different data. It is only has limited capacity, and it is only being able to access or store limited amount of data. That's it. So we started to use now, which is DBMS. Okay, so we use database management system software to say that, hey database, can you please do the following things? Now database is having a similar kind of structure which you always maintain, okay, which they always maintain. And if you want to tell the DBMS that, hey, we want to save some data, we have to tell him the procedure how to do it. So let's say the very first procedure is create the table. We need to tell DBMS that, hey, you need to first create the table. Which table? Let's say some name, student table. The field of the ledger should be the columns of the table. Whatever field we have given in the ledger, that is nothing but the columns of the table. That should be the columns of the table. Give a name to the table. We have already given student. Insert the data inside the table. Whatever values or data is inside the ledger, that should go inside the table. Now what you have? You have a table, the column, field names, table name, in which you have inserted the data. This is what you have to follow to keep the data or to store the data present in the ledger onto the hard disk of the computer. Now DBMS will do this and will keep the data saved in your hard disk. This is what happens when you use DBMS. What is the difference between Oracle and then SQL? What is this SQL? We have understood that Oracle is a DBMS software or a database. But what is this SQL then? Let's understand. So when we talk to any person, let's say that she's saying, "Hi Gokul, how are you?" So the person says, "Hi Sita, I'm good. What about you?" What language we are using? We are using English language to communicate with our particular person or an individual, correct? Now, if I want to talk to all the DBMS softwares, all the databases that we have, right? Like we have MS SQL, we have MySQL, we have Oracle, we have Hadoop, we have PostgreSQL. Now, to talk to all these particular databases, we can't use English language, correct? We need to have some language to talk to these databases, to give the commands to these databases, to actually tell the database what you have to do, right? So we have to use here what is called as SQL, okay? So it is a language used to communicate with database management system. We'll be using Oracle database to store our data, okay? But SQL will be the language. SQL will be the actual language which will be writing to tell the DBMS what he has to do. Fine. Now this was all about the introduction. This was all about the historical and the latest trends, what is happening in storing and retrieving data or database, okay? Now let's understand how does it appear when you are actually storing your data from a ledger to a DBMS, right? Or to your any Oracle or any other DBMS softwares. So if you have a ledger looking like this particular data using SQL will look something like this, okay? So this is how the table looks like, and this is how the fields are the columns. Understand that the fields ID, name, age, gender, marks, and SEM, these are the columns, and the values are nothing but our rows, which you can see here, correct? Now let's understand what and how to create a table. What is the syntax of it, and how we can actually do something to create a table, which we have seen earlier in our previous topic, right? So let's see what is this SQL command, how to use this SQL command, and what do we call it as. Now, how to insert data into the DBMS by creating the table. So if I have this particular data in our ledger, how we can actually store it in our DBMS using SQL. So this is one of the query which we have to write. Now what I'm saying, what is this word I'm using here? Query, right? Now this query word is very, very important if you're learning database, because query is something which you write to solve a problem, okay? Or query is something which is a problem by itself, right? Query means a problem. So we have a problem. What is the problem? We want this data to be stored in the table. So we write a query. This is the query. We write this query, and once we execute this query, this particular table will be created. Okay. So any particular statement, a set of a statement which you write in SQL is nothing but called as query. Okay. So what we are writing here, we are writing create table student with, we have all the fields in it. Okay. Not only the fields, but we also have the data types, plus we also have the maximum number of letters or digits, how much you want, those things. Let's understand one by one. So create table is a command, right? Create table is a command, which is, you can say, keywords. Okay. So we have to use create table to create a table in a DBMS. Student is the table name, which you can always change. This is user defined. So if you want to write any other, or you want to give any other table name, you can give it. Now we have the ID, we have the name, we have the age, we have the gender, marks, and SEM. Obviously, ID, age, marks, and SEM, you know that these are numbers. If you see here, 52, 26, 98, 8, these all are numbers, right? So we have here number, right? Now ID, we know that it can be only till 10 digits. It should not exceed 10 digits, right? If it is exceeding 10 digit, my table or my DBMS is not going to accept it. So you have given a particular limited capacity to it, which is 10. Similarly, to name and gender, we have varchar2, which is another data type. Don't worry, we will see what is data types and how does it look like, how do we write it in our other topics. But right now, I'm just telling you that these are the data types. Varchar2, why is it named as varchar2? Not only varchar, that also I'm going to tell you in the topic of data type. 30 and 6. Now these are again limited capacity. If you want to write 6 letters only in this particular gender, if you see male and female, that can be the only particular gender, right? So that is why I've written here 6. 30, the name should not be longer than 30 letters, correct? So this is how you write a particular query. Once you execute this, you will get this kind of thing. Now one thing is missing here, and if you notice, that is nothing but our data, the values. And obviously, because we have not written a query to insert the values, correct? And that is why only the table is created, correct? Now let's move to the next part. So if I have a lot of data in our ledger, how do we do that? So this is another example of employee table, and just have a look, how does it look like, right? So this is how we have the fields, which is employee ID, name, age, address, salary, department, and experience. So these are all my fields, and I've just created a table. Now let's understand how to actually insert the data inside this particular table, because now we have the table, but now we need to insert the data also inside it. So let's understand that. So we have a query which is insert into student values. Now understand what is this. See, insert into is nothing but a command. Likewise, we are having create table. Similarly, we have insert into. Student is a table name. Now, if you remember, student was the table name which we created. We are using the same table name here. If you write student 1 you have not still created. So it will give an error. So you have to use that particular table which is already created. Then only it can insert values. Then we have the values. And inside the values, we have the all values which you want to give. Now understand that the order of all these values should be the same how you are putting it in the creation of the table. So in the creation of the table, if you remember, we were using ID, name, age, gender, marks, and SEM. And in the same manner, I'm going to put it here also. So we have ID, name, age, gender, marks, and SEM, right? This is how you put it. Now, some of the questions will come into your mind. The first question is why the numbers doesn't have a single quote, but the names or the gender or the string or character sequence have a single quote. Now, that is an interesting fact. In any programming language or in any database language, even if you see, we always write the characters or the strings in a double quote, a single quote, and the numbers is written just like that. Okay. The next question which will come into your mind is, if we have to write the data and if you want to insert the data in the same order, then what if I miss out on some of the data? Suppose if I'm not writing 52, I'm starting from Aman, then what happens? Now what will happen is the SQL will check that what is this Aman. Now he knows that ID can't be Aman, right? Because ID is a number. So he'll put a 0 here by default or null by default, right? Because he can understand that you have not given an ID value. You have started from the name value, correct? But don't do that. If you don't have the data, then obviously you will not be able to write anything in the data. But if you have the data, don't just skip that. Otherwise it will take a null or a 0 value, correct? So this is how I've inserted the data, and now you can see that this is how my table is getting appeared, right? So we have the first row and we have the second row. Understand that for each row you have to write this particular query. Now I'll be thinking that, okay, so if I have 52 rows, that means I have to write all the 52 rows statement like this. And this is very long, this is time taking, right? Then how to do that in a shorter way? That is why we have the Oracle DBMS. So once you will do the Oracle setup and installation, once you will download it, then you will be able to see that how you can easily create a table without writing the query and how you can insert the data inside the table without writing the query. So without writing the queries also, you can just directly go to Oracle. There's a whole system there where you can just put the values. Once you click on save, it will automatically get saved, right? So we don't have to actually write the queries. But for your knowledge, you should know what are the queries, how to write it, and how will it appear, correct? So for more of the students record, you can see that this is how it will look like, right? So this is one of the great example, very easy example, but now it's time that we move to practical things and we see how Oracle is working, right? So now let's understand how we can actually do the download of Oracle software and how we can install it, right? So before going to the Oracle installation or to the Google Chrome and understand how we can start it, let's understand what is this software and how many types of softwares are like this. So if you talk about Oracle, we have the Enterprise Edition, okay, we have the Standard Edition, and we have one edition for only practicing, for only learning, right? So if I move to our Google and we just write here Oracle download, right? The very first thing that you can see, it is Oracle Database Software Downloads. So if I open it, you will be able to see that we have the Enterprise Edition, which is 19.5. And then if you scroll down, you will find the Oracle Database Express editions, which are 18C and 11G. Now 11G is the Express edition for Windows 64, for Linux, for Windows, and these are only for learners to practice, right? So you'll be using 11G itself. So what you have to do is, once you click on right click, let's say that I am clicking on that. As you can see, this particular database page is not taking me to the download part of 11G, right? That means now Oracle has removed 11G from this particular official website, okay? And they are trying to tell us that you have to go for 18C Express Edition, okay? So if I open this, you can see now this particular two links, which is one for Linux and one for Windows. Now 11G also some time ago, this was also giving me a page something like this, right? How 18C is giving me. In the same way this page used to come, but now it is not. That means they have removed it and now you can use 18C. So now once you download 18C Express Edition, this is having a lot of features which you can use with Oracle SQL Developer tool, okay? Now what is that? So one is Oracle Database and one is Oracle SQL Developer. Now Oracle SQL Developer is a software where you actually write the query and you will get the output, right? In Oracle Database also you can do that, but Oracle is more like a database, as I said. Oracle SQL Developer is a developer tool where you actually write the SQL language and get the queries or whatever problem solution you want, you find it there, okay? Now this particular Express Edition for Windows, you can download it. It is for 2 GB, I think. It's written here, it's of 2 GB. It will take a long time and you can do that. I've already done it. As you can see, Oracle XC 18.4 Windows 64. And it is the same way how your Oracle 11G is gonna work. But the question is, from where you will get 11G, because now you are learning and you don't want to use 18C, right? Once you are very fine with 11G Express Edition, then only I want you guys to work on 18C because it's a little bit of complex. So let's see how we can download 11G, right? What you do is, in Google, just type Oracle Database 11G or Express Edition, whatever you want to write, right? When you do that, you will get a lot of websites from oracle.com itself, a lot of links from oracle.com itself, but there are some links which you can see here from O7 Planning, and there are more of random links which you can see, right? And these people, what they have done is they have the .exe file and they have given it, publicly free. So you can click on any of those and you can get it. Similarly, I have done it. You can see here that I have got this particular zip file, correct? Similarly, you have to just download it. Some people are also putting it in the drive and giving it. If you're not finding it, we'll put it in this video description so that you will find this particular software in the drive also. Okay. Now what you have to do? So we have the 11G Express Edition Windows 64-bit. What you have to do is we will extract this file here itself. So we are extracting the file and we are getting this particular disk 1, right? Open this, click on setup, and now we are installing. So one message will pop up that do you want to allow this app? You can click on yes, and let's do the extracting and installation of Oracle Database 11G Express Edition. So it is preparing to install and it says welcome to the install shield wizard. Let's click on next. Let's accept the terms in license agreement. Click on next and let's click on next. See, we can browse, but I don't want to change the location. I want it to be in the default place. So click on next. Now here you have to set up your password. Now understand that there are two default database accounts, right? One is sys and one is system. If you see enter and confirm password for the database, this password will be used for both the sys and system database account. So I'll be writing a very default kind of password which you should or anybody will not forget, right? So normally for all the Oracle, we use a password which is root123. I am just going to put root, right? So that it becomes very easy for me to access anywhere whenever I want to access the Oracle database of mine. I'm clicking on next, clicking on install, and just wait for some time and it will get installed, right? Now this password you should never forget, because this password will make sure that you're working with Oracle in any of the laptop and in any situation, right? So do not forget that particular password. So as you can see, now we have finished our installation and let's click on finish. So let's go to our desktop. So now we are in our desktop, and as you can see, there's a shortcut which is get started with Oracle database. If I click on it, you will see that I'm getting an error, right? Now the error is Windows cannot find HTTP 127.0.0.1 : there's some HTTP port which is missing here, right? So we have to correct it. Now how to correct it? We'll go to our C drive. So let's go back to this PC, C drive, and in this C drive, let's go to our program files, and we have to find the Oracle software, whatever we have downloaded. Let's move to our program files here. So as you can see, we have got the Oracle exe. Let's open app, let's open Oracle, let's open product, let's open 11.2.0, let's open the server. Now in the server, we can see the get started page, right? Let's click on properties. And if you look here, we have the HTTP port here. And here what we need to have is, so you need to just delete the percentage HTTP port percentage, not the whole thing. Now let's click on apply, let's click on OK, and let's see whether it is opening or not. So let's double click on it again, and it is opening. So let's see how does it appear. So we have got the home web page of our Oracle, and this is how it looks like. If you can't see, I'm just zooming in so that it appears well for you. And you can see here that we have some things, Oracle Database XE11.2, and this is how it looks like. So let's go to our Application Express, and here it is telling me the username and password, right? So do you remember we have the default username? We have one which is sys, and another one password which we gave as root. Let's log in, and here we are, right? Let's not save the password for now. Now here you can see that we are in our sys, which is our sys or system, right? So we are on our sys database, and here they are telling me that whether I want to create a new database, or I want to use the existing one. So I don't have any existing one right now, so I'm going to create a new one. And to this particular database username, I'm going to give Ritvik, right? Or, okay, let's say Ritvik. And here also I'm going to give Ritvik. Password, I'm going to keep the same for all of the things so that I never forget what is my password for this or that. So for my particular schema, we have the root password. And for this database also, we have the password which is root only. And I'm just going to create a workspace. Now, once you create the workspace, you will get a particular message which is successfully created workspace Ritvik. To begin, click here to login. So I'm going to click here. Now you can see workspace Ritvik, username Ritvik. I'm going to put the password root and click on login. Now this is what is your main thing which you need to work upon, and this is where you will actually start working on your queries, writing the commands and getting the output. So let's see what are these things. So we have to go to SQL Workshop, and once you click on SQL commands, you'll be able to see two windows, which one is this one and the other one is this particular result, right? Now you must have understood what is this. So basically this is nothing but the main place where you will write the query and you will get the result of it, right? So let's say that I'm writing a particular query, select that from dual. Okay, I've written this small command, right? Let's run this. You can see here it is giving me an output which is the system date. Okay, now what is dual, what is from, what is select, you don't worry about that. I've just taken an example and I've given an idea that what is this. So it is giving me the system date right now. What is the date in the system, in my system? So it's 25/8, and that is what it is showing me, correct? So this is how you will write the query and you will get the output. This is where you will do that. Now let's go back to our home and let me tell you something more about this particular page. Let's move to application builder. Let's see what are the things here. So we don't have much of the things here. Okay, you don't have to care about this application builder. Let's go to SQL Workshop. Here most of the things you have to know. Let's click on object browser. Now this is one of the places where all of your tables will be appearing. So if you see, we have all the tables here. We have the imp table, which is by default. It's already created. You can see this is how the table is looking. We have the column name and we have the data type. Remember about the ledger and the table. This is what it is. We have the field names. These all are the field names and the column names. And these are all the data types with all the values. Now label means whether that particular column can be null or not. So employee number cannot be null, but all the other things can be null. So this is what is my table. If I click on data, I'll be able to get the data. That means the records also. So if you can see, these are all the records of my table, correct? If you want to edit, you can edit from here. You want to edit the row, you can edit it. So see, you don't have to write the query. You can do it directly. That is what I was saying you. Now, department, DEPT, this is also one of the table which is already given, right? So we have the data. Now let's move to demo users, demo stats, something like that we have. Now let's see how this EMP table appears in my SQL query. So what we have to do is we have to just go to our command line and you have to just write here select star from EMP. Now if I do that, if I run it, as you can see, you're getting the whole data in front of you. That means the whole database. The database which are having one individual data and everything is displayed here. Now you can see more than 10 rows available, increase row selected to view more rows. That means there are more rows here. So what you have to do, you have to do it, let's say around 200. Let's run and you will see all your data. So we have 14 rows which is returned, right? So this is how you can play with the data. You can get all these data accordingly, and this is what it is, right? Now let's move to SQL Workshop again, and if you can see here, create object is something which is written here, and we have the table, right? Now remember I told you that you don't have to write the query of create table or insert into, right? This is what it is. So suppose if I want to create a table, let's say I want to create a table named as student, right? And the column name I want to give here is, let's say, roll number. I want to give here is name. I want to give here is age. I want to give here is gender. I want to give here is city. So these are the 5 columns which I want to give. Now select timestamp. So roll number obviously will be number. This will be varchar 2. age will be again a number, gender will be again a varchar 2, and city will be again a varchar 2, right? Now you can see in all the numbers we have a precision and we have a scale, right? And then in varchar 2 we have the only scale, correct? Let's do one thing. Let's click on next, right? If you can see what is happening, the scale for the column name is required, gender is required, city is required. That means all the particular columns which we have varchar 2, it needs a scale value. It is must that you should give a scale value. So name, I want to give it 30, and gender I want to give, let's say 8, and city I want to give, let's say 10, right? So these are the things. Let's click on next, and once you click on next, you'll be able to get into the next different section, which is primary key. Now what is primary key, what is foreign key, what are constants, those all things we are going to look upon in the next topic, which is relational database management system. But right now, let's say that I don't have any primary key because we don't know what is primary key, right? And foreign key also will not select anything, so we'll just click on next. Constraints also we don't know anything, what is it? So let's create table. Now this is asking me a confirmation that whether this all things are correct which you have written, and it is also giving me a query already written. This is the query which is already written, and this is what I actually showed you in my slide. And we don't have to actually write this particular thing anywhere, right? We just create it and the table will get created. Now what we can do is we can copy this particular query. You can also click on create, you can do that. But right now what I'm doing is I'm copying this particular query, going to my SQL workshop, going to my SQL command, pasting this particular query here, and clicking on run. What is it showing? It shows table created. That means now my table is created. How can I check whether my table is created or not? One thing what you can do is you can just write here, select star from student. Let's see what happens. Now if I select this particular query and run, it says no data found. It doesn't say that table is not there. It just says that no data found. That means data is not there in this table. Table is created. Let's confirm whether the table is created or not. So if I scroll down, you will see student table, right? And we have the table columns and all, but in the data, there is no data here, right? So if I click on insert row, I will get the detail and I can insert it right now here itself. So we don't have to write the query of insert into and all blah blah. So roll number, let's say I'm writing 1. Name, let's say I'm writing Ritvik. Right? Age, let's say I'm writing 26. Gender, let's say I'm writing male. And city, let's say I'm writing Bangalore. Right? Let's create this. Now you can see one of the row is created. Similarly, you can insert another row, and let's say that I'm writing some of the statements. Right? And let's create. So 2 rows I have inserted and you can see it in the data. Let's verify whether it is coming in my SQL command or not. So what you have to write again, select star from student. From now, I think you have understood that what is this select star from student? What I am writing here. Select star from student is making sure that it is selecting all the data from your table and showing it to you. So if I click on run, I am getting my 2 datas, which is Ritvik and for Sachin, right? So this is how you actually play with your Oracle, and I hope this looks very easy for you. Now what we'll do is we'll understand the basic concept, the miscellaneous topics and all those things which I've told you in our agenda, and we'll start working using this particular software. Okay, so now we are done with our Oracle setup, download and installation, and we have seen how to create the table in an Oracle database and how do we actually start creating the table, inserting the values and playing with the data, right? Now, before moving into the miscellaneous topics or the basic concepts around Oracle, we have to first understand the topic, which is a relational model. So let's understand what is this particular topic and what is it about. So let's consider that we have two tables and something like this. So we have this one table which is roll number and student name. So let's say that table name here is student table. Okay, and this particular table is marks table. Right, so we have these two tables. These two tables are separate tables. So let's see the fields. So we have one roll number field and one student name field in student table. So every roll number is assigned with one particular student name. And in the marks table, we have roll number, which is again a particular field for marks table, and one particular field which is marks obtained for marks table. So assigned roll number, people have these marks obtained. Now, if a question arises that, we have a query, we have the query that, let's say we have a problem that we want the details of all the students who have scored more than 40, right? Or who has scored more than 45, something like that. And we want his roll number, we want his name, and we also want his marks. Okay, so you want all his details. Now, considering these two tables, we can get roll number, student name, and marks, right? Why? Because we have one particular column which is common in both the tables. So roll number is one of the column which is common in both the tables. And because of this roll number, we are being able to say that we are going to fetch roll number, student name, and marks obtained. Imagine that this roll number column is not there in this table. Will you be able to tell that how much Rohit has scored, or how much Mohan or Sanjay or Kiran has scored? No, right? We won't be able to tell, because marks obtained then will not be assigned with any roll number. Correct? So this is what is my problem here, and the solution of this is basically very easy. What we have to do is we should have one particular column which is matching with both the table, and we have this particular column roll number which is matching with both the tables, and we can use this. Now, the table which will appear will look something like this. So we have the roll number, we have the student name assigned with that roll number, and we have the marks assigned with that particular roll number itself. So we have this particular table which is a combined table, the resultant table, correct? And this is what is called as a relational model. What is a relational model? The relation between the two tables, which is the common column. So when you have the common column, you are actually establishing a relation between the two tables. Let's take another example. So we have two tables again here. We have the country and capital. So let's say that this is the capital table and this is country and currency. So let's see that this is the currency table. Now, as you can see, country is one of the common column field which is in both the tables, right? So if I'm asking that in Greece country, which capital and which currency is getting used, then it's Athens and drachma, correct? Similarly, if I ask for India, then for India country, we don't have any capital written here in this table, and we don't have any currency also written here. So for India, there will be null value for capital and currency, right? But if I ask for Italy, USA, China, Japan, Australia, and France, we have all the capital and currency in both the tables, and we will be able to get it. This is what is a relational model. This is what is a relational table. Now here are some of the key terms which is related. Let's understand what are these terms. So the first term is nothing but relation. Now what is this relation? Relation is nothing but the table. So now when I'm saying that this is a capital table, we don't say it's a table, we say it's a relation. Capital is one relation, currency is another relation. Tuple. Tuple is nothing but the row. So if I talk about this particular row, Greece, Athens, right? This is one row, which is called as tuple. So now we will not say that it's a row, it's a tuple, right? Next is nothing but attribute. Attribute is nothing but the column. So if I talk about this country and capital, which is my column or field, we call it as attribute. Okay, so country, capital, currency, these all are my nothing but fields or attribute. Now the next one is cardinality. Cardinality is nothing but the number of tuples in a relation. The amount of tuples or the amount of rows in a relation or a table is called as cardinality. So the number of rows in this is 1, 2, 3, 4, 5, 6, 7. So here we have 7 tuples, which is nothing but the number of cardinality. The degree is nothing but the number of attributes, that means number of columns or number of fields. So degree for this relation is 2 because we only have 2 columns or 2 fields, which is country and capital. Okay, domain of an attribute is nothing but the values of an attribute. So if you look about this attribute country, Greece, Italy, USA, China, Japan, Australia and France are nothing but the domain of an attribute. Okay, so these are the list of or set of values. Right? The next 2 terms are very important, which is primary key and foreign key. Now understand this in a very easy manner because this is one of the things which are very important to understand. This has been asked in a lot of interview questions and many of freshers are getting confused between these two. Primary key, what is primary key? Primary key are those keys which are actually uniquely defining your table. Okay, so let's say that I have this table which is capital table, right? Now in capital table, which particular column is uniquely defining? Country. Okay, country is all unique. Capital is also unique, but country is one of the particular column which is relational, which is showing relation with the currency table. Because in currency table also we have country. So country is our primary key in this table. Okay. Now, suppose if I have here one more column, which is, let's say, country code. Okay. So we have some random codes. We have 0, 0, 0, 1, 0, 2, 0, 3, 0, 4, 0, 5, 0, 6. Something like this we have, right? Now country code is now much more uniquely identified thing when you talk about this table, because country code can be a primary key also, correct? Let's say that in a school you have a roll number, right? Why do we have a roll number? Because maybe one of the student can have a similar name. Let's say my name is Ritvik. There is another student whose name is Ritvik, but he's Ritvik Kumar. I am Ritvik Raj, right? So to distinguish between these two people or person, which is Ritvik Raj and Ritvik Kumar, we have different roll numbers given, and those roll numbers are all unique, right? And that is what is our primary key in that case. So in all the tables, you have to find the primary key. Now, if I talk about this particular table, which is roll number is something which is unique, right? So this is my primary key. In this also, we have the primary key, which is roll number, correct? Okay. Now we have understood what is primary key. That means in one table, we will have one primary key. In this currency table, we have one primary key, which is country, right? We have one primary key. Always in one table, you should and must have one primary key. Okay. If you talk about a student table, which we have seen in our Oracle database, we have seen roll number, name, age, gender, and then code, right? Or the pin code or the city. So here we have the roll number as the primary key. Now let's talk about what is foreign key. Now understand, if you have two tables, I'm saying two tables, okay? In primary key, every table, each and every table should have one primary key. When you talk about foreign key, we talk about two tables. Let's say relation 1 and relation 2. Now here we have some columns and here we have some columns. Okay. Now let's say that here we have the ID, here we have name, and here we have subject ID. And in this particular relational table, we have the ID, we have the subject name, and we have the subject faculty. Okay. Now understand what is happening here. So here what will happen, ID is my primary key for this table. So for this table also there should be one primary key, and that is subject name, because all the subjects will be different. Okay. So this is my primary key for this table. Why I'm not putting this ID as my primary key? Why I'm not doing that? Because I know that these two tables are related and when two tables are related, and if already one particular column is a primary key of the other table, this can't be a primary key of another table. This will be a foreign key of another table. Okay, why it will be a foreign key? See, if you are living in India, you are localite. But if you're going to Singapore, or you're going to USA, or you're going to Dubai, you'll become foreign, right? Same thing happens here. When it is in R1 table, ID is nothing but a primary key, which is the local ID, local primary key. But when it goes to the another table, it becomes foreign. A very easy concept, right? So this is what is all about the primary key and foreign key. Now let's move to our miscellaneous topics, and let's do it practically, all of these things, and let's start using these terms again and again so that you will get an habit of using it. So now we are in our miscellaneous topics section. Let's see what all miscellaneous topics do we have in Oracle SQL, and what are the different topics that we are going to see. So first we'll start with projection, and then we'll move to selection, and then slowly we'll move to some of the very interesting topics in Oracle. Now remember that these are very short topics but very useful, and don't think that these are very small topics, so let's ignore that. No, these are very important topics, so let's understand one by one. Projection. Now projection is something when you want to project something, right? Let's say that you have a college and you have a group of students, right? Now if I want to save data of all the students, which will appear something like this, right? We have USN, name, gender, age, and marks, correct? Now projection is nothing but choosing which column or expression the query shall return. Now suppose that when we want to only present name, age, that's all from one table. Let's say that we have a student table and we want only name and age to be projected. That is what is displaying the result, right? So projection is a process of displaying the result using project queries. So project queries are all those queries which is used to display particular column to the user based on the requirement from the user. So if I want only name and age, that is what I'm giving the command to the Oracle. We are saying that I want only name and age. Now suppose if you're writing that I want the details of all the students whose age is greater than 20. So now you have a condition. Now you want all those details whose age is greater than 20. You are actually wanting those things which you want to project in your resultant table, right? So that is what is projection. Now, if you look in this particular example, write a query to display age and marks of all the students. So I want to display only age and marks of the students. So I'll write select age and marks from student, because I only want to display age and marks. This is what is projection. So write a query to display name and USN of the student whose age is greater than 21. Now I want to display the name and USN of a student whose age is greater than 21. So I have a condition. So there we will use this kind of query. Select name, USN, because these are the only two things I want to show. I don't want to show age, but the age of that particular student should be greater than 21. That is what I want. And this is what it is showing. The next is selection. What is selection? Now, selection means which rows to be returned. That means which all detail or data I want it to be displayed. The selection is the process of displaying the result using select queries. Now let's say, write a query to display all the information of a student named Kavita. Remember the table? We have name, age, gender, marks and all. Now I want to write a query to display all the information of a student named Kavita. So select star from student where name equal to Kavita, because I want all the details. So I've written star. So select star. This is what the selection. How many rows do you want to select? All the rows I want to select. So select star. Correct? Another example of this is write a query to display name, gender, USN of a student named Ravi. So the student named Ravi, what all things you want? You want his name, gender and USN. That's all. So select name, gender and USN from student. Do not get confused between projection and selection. Projection is the data which you want to display. Selection comes where you want to display that particular row data, one particular row data. That is what is selection. Okay. Don't get much into inside this, because any which ways you will do the queries, you will write the queries in Oracle database, you will slowly understand what is happening, why you're using select and why you're using insert, why you're using other commands. Now, coming to the next topic, which is case sensitivity. Now, obviously, in every programming language, we have case sensitivity, and in SQL or Oracle also we have case sensitivity. But to make sure that you know where all case sensitivity is required, that is why I have this PPT. SQL keywords are case sensitive. Select case insensitive. SQL keywords are case insensitive. That means select, from, whereas, order by, having, group by. These all are keywords and it can be written in capital or small letters. Usually it is written in capital so that it clearly defines that these are keywords. But you can also write it in lowercase itself. Now understand these 4 points. These are very important and keep this in mind till this video ends. Keywords in SQL is not case sensitive. These are case insensitive. You can write it in small letter or capital letter and it will work. Table names in SQL are not case sensitive. Again, table names can also be written in lowercase or uppercase. It doesn't care. Column names in SQL are not case sensitive. Column names are also not case sensitive. That means those also can be written in capital or small letter. It doesn't matter. But the data in SQL is case sensitive. Now this is very important. Data is case sensitive. Why? The reason is, suppose if you are saving one particular data as Ravi, which is small RAVI. Now if you are asking for a particular data which is capital RAV small I, obviously these two are having much and many more differences, if you can see, right? Name is same, but the writing pattern is different. Now this Ravi can be different person and this Ravi can be a different person, right? So when it comes to data, data should match. The data, letters, capital, small, lowercase, uppercase, these all things should match. If it is not matching, then you will not get a result. So make sure that you know in any database languages, the data is case sensitive. Other than that, everything is case insensitive. Let's move and let's see one of the examples. If I'm writing select name age from a student where name equal to Ravi, if you can see, select is a keyword. It's case insensitive. I've written it in a very different manner here. Name age, these are fields. From is a keyword. Student is a table name. Where is a keyword. Name is a field. These all things are case insensitive, but when it comes to Ravi, which is a value, which is a data, is case sensitive. So if I write here small RAVI, this output will not come. Because it's capital RAVI, that is why it is showing me capital RAVI. Okay, so these are nothing but my keywords, and this is my table name, and this is my data, and this is my column name, right? So this is what is all about my case sensitivity. Let's see one more example, which is select name age from a student where name equal to Ravi. Now this is wrong. If you can see, this is wrong data. So no data found, right? Now coming to the next topic, which is data types. So what all data types do we have in our database language? A data type specifies a particular type of data. We have already seen one or two data, which is number and varchar2. We have some more, which is integer, floating point, boolean. We will see one by one what are those. Now, if you look here, we have in character data type char, varchar2 and varchar, and then long. In number, we have the float, and in date, we have date data type. That's it. So these are some of the built-in data types which we have in SQL. Let's understand one by one what are the different features which they provide. So in char, it's a fixed length character size. Okay, that means how much ever value you will give to this char, only that much letters or characters can be kept. And the maximum size is 2000 bytes per row. Default size is 1 byte per row. Varchar and varchar2, these are variable length character data. That means it can be increased. Character is a fixed length which cannot be increased. Now, what is the difference between var and varchar? Now, if you look here, the amount of bytes is what is the difference. So it can store up to 2000 bytes per row, but varchar2 can store up to 4000 bytes per row. Okay. Some more differences are written here, but I'm not going to take that because this is not that much important. Varchar and varchar 2, if you know the difference of the memory size, that's enough. So people generally use varchar 2 because that is what is having the most bytes per row. So that is what they use. In number, we have two things. If you remember, in Oracle database also I've shown you two things. So you can see varchar we have a scale, but in number we have precision in scale, and that is what it is showing here. So we have in number precision and scale. Precision goes to 1 to 38 and scale goes from -84 to 127. We have similarly float and then date, and for date we have the normal format, which is DD, MMM and YY, and this is what is the date format. If you want to use it, you have to use this parameter NLS date format to use the date property. But generally we don't use these all things. We use it when we want to give date particularly, but even with number, dates can be written, and generally we use number, varchar 2 and char. That's it. Okay, let's move to the operators. And in operators, we have a lot of operators which we use in Oracle, but the most common ones are plus, minus, multiplication and division. Now, why these are common ones? Let's understand. An operator is a reserved word or a character used primarily in an SQL statement where clause to perform operations such as comparison and arithmetic operations. Arithmetic operations I have just told you. These operators are used to specify conditions in a SQL statement and to serve as conjunctions for multiple conditions in a statement. What is this? What have I read so much long? Now understand, if I go to my database and if I say that let's go to my SQL workshop, let's go to my object browser, let's go to my EMP, we have a salary section here, right? If I look into the data, we have a salary here, right? Now suppose that to this table, I want to write a code to which I want to say that I want the names of the employee with their salary increased by 1,000 rupees. I want the salary to be increased by 1,000 rupees. How we will do that? So let's say that I'm going to SQL commands and I'm writing a query, right? Let's say I'm writing select name from EMP, right? This is what I have written. So, okay, I think it's e-name, it's not name, right? So I am getting all my e-name. Can you see? I'm getting all the e-names, correct? Now, what I'm going to do is select e-name from EMP. Here, what I want to do is, I want to use the operator and I want to say that the salary, what I want, it should get increased by 2,000 rupees and then show me the table. So now, the king which was having 5,000 as a salary, now is increased to 7,000. Similarly, for Blake, it is now increased from 2,850 to 4,850, right? Similarly, for all of them, the salary is increased with 2,000 rupees. Another question. Let's say that somebody is asking you that I want employee names with their annual salary. That means in a year how much they are making. So what you will do? You will actually do multiplication with 12 because you have 12 months. The salary into 12 will give you how much? The annual salary. So this is nothing but your 60,000 rupees for King. For Blake, we have 34,000. And then for Clark, we have 29,000, right? So this is what is their annual income. Half annual income, 6. Let's multiply it with 6 and you'll get half yearly income, right? This is where we use the arithmetic operator, which is plus, minus, divide. Whatever you want to do, you can do it from there, right? The precedence is given here, plus, minus, multiplication and division. So board mass rule you already know. This is what we use. Now let's come to the next one, which is column alias. Now what is this column alias? Remember that we all have one nickname, correct? So if a guy named as Shivam Agarwal, his home name or house name will be something called as Monu, right? Or anything else. Now in SQL also, when we create a table, sometimes we give a column a very big name, right? Or a table a very big name. And when we actually write a query every time regarding that table, we always have to use that table name or column name. which is very long and it's very tedious. So what we do, we actually make another nickname for that particular table or for that particular column name. Okay. So let's say that I have USN name, gender, age and marks. Okay. Now I think that USN should be changed to registration number. I think that age should be changed to years old. And I think that marks should be changed to score. So this is what I have done here. And this is what is called as alias. Okay. Alias means that a temporary name to a particular column field or to a table name, right? Now how to do this? So we do this using two methods. We actually use as a keyword or we directly write it like this, right? So generally you must have seen that employee E1, employee E2. Why do we do that? Because I don't want to write employee every time. I want to make it a shortcut. I want to write E1, E2, something like that. So the alias name will never be reflected in the actual table. These are just the temporary names, not the actual names which is present in the hard disk of the computer. Okay. So how do we write it? Select USN as registration number, name, gender, age as years old, marks as score. And this is how you will get the result, right? Let's move to the next one, which is distinct keyword. So I want the data which is distinct. Let's say that I have this table and I want the data of distinct age. That means not the repeated ones. So 21 is repeated twice, 22 is repeated twice. I don't want it to display twice. I want the distinct data. So I want 121, 120 and 122. This is what you will get. Okay. This is what is distinct. So how do we use this keyword? There may be a situation when you need to retrieve unique records and not multiple duplicate records. So you want unique data. This time we will use distinct keyword. It is used to avoid displaying repeated values. So select distinct age from student. All the unique age will be shown from the student table. Next one is concatenation operator. And concatenation, if you remember, in any programming language, if you know, concatenation is nothing but joining of two things, right? So the operator, double pipe operator, is used for concatenation operator and is used to combine multiple data or multiple columns. So if I have this table and I want to use name, pipe operator, age, that means these two columns will be combined together. So, but I want to use it as a alias name, which is name and age. So this is where I'm using the alias. Okay. I don't want you to display as name, pipe, age. I want to display it as name and age. This is the column name. Okay. Now this is what is the answer. Ram 21, Ravi 20, Kavita 22, Arjun 22 and Anjuna 21. This is how you get the concatenation done, right? Now, one more example of this, if you can see here, this all are nothing but the concatenation. Now see what I'm doing here. Name concatenated with aged. Aged is not a column field. It's a string. So let's say the name is Ritvik. Then it will write aged. Then it will write my age. So this is what will get printed. Ritvik age 26. Amazing, right? Okay, so this is what is concatenation operator. Now comes the very interesting topic, which is dual table. So dual table is a default table which is defaultly given by Oracle, and this particular table is by default present. You can use this anytime to do any task. Now, the dual table is a special one row, one column table. So if I want to show you how the dual table looks like, have a look. Let's say that I'm writing select star from dual. See, I have not created any dual kind of table, but still it shows me one row, one column. The column name is dummy and the row data is X, right? And this is what is dual. Okay. Now what does this dual do? Let's understand. So dual is nothing but kind of a practice table where you can do whatever you want, right? So let's say that I want to print system date. So we use sys date, which I've shown you already, right? Now, if I want to see the description of this dual table, so what I can do is I can just write description dual. That's it. Now you can see what is in the description. Table name is dual. column is dummy, data type is varchar2, length is 1, nullable, yes, it can be null. And this is what is the dual table description. How can I look into any table's description? DESC is the keyword for it. Correct? So want to see how dual table looks like? So we use description. Okay. You can also check the system date from the dual table using the following statement, and you can also check the arithmetic calculations on the dual table using the following statement. Let's say I have some formula and I want to execute that, or an equation, I want to execute that. So this is what is the dual table will give you. So it will give you the answer, whatever answer will come. And this is what is my dual table. So this was all the miscellaneous topics around SQL and Oracle database. Now we will jump to the new topic and let's understand what all things are there in that topic. So now we are in our next topic, which is operators as keywords. And in this particular topic, we are going to understand what the different operators which we can use, and also the operators which acts as a keyword in Oracle database. So first of all, we are going to understand the relational operator, which we already know, like the less than, greater than, equal to. Those are nothing but our relational operator, something like this, right? We also have not equal to with 3 symbols. So don't get confused in Oracle. Not equal to is actually denoted by 3 symbols, which is exclamation mark equal to, and then if you're using less than, greater than together, and then the exponent and equal to together. These all 3 symbols are nothing but not equal to, so don't get confused. And these particular relational operators are usually used when you are comparing 2 values in a condition, correct? I'll show you some examples also. So let's say that we have this table which we are using from the starting, USN name, gender, age and marks, which is a student table, and we have to write a query to display USN name and age of all the students whose age is equal to 22. So condition, but based on comparison, right? That we use relational operator. Write a query to display USN name and age of all students whose age is greater than 20. Again, comparison, relational operator. The next question, write a query to display USN name and age of all the students whose age is lesser than 22. These are some questions. You guys can do it. This is very easy. You have to just use the operator and that's it. You will get the result. So try to create, as I've already told, try to create this particular table and try to solve these questions. Next question can be, write a query to display USN name and age of all students whose age is greater than or equal to 20. This also you can do. Lesser than or equal to 22. This also you can do. And whose age is not equal to 20. This also we can do. So in this particular last question, which is age is not equal to 20, you can use any of the 3 symbols. Try to do it on your own. Try to see whether you're getting the answer as imagined or not. Yes. So this is what is your precedence operators. So first we give precedence to equal to, then greater than, less than, greater than equal to, less than equal to, and it goes on. Correct? Operators as keywords. Now this is very important and this is why this topic was discovered. So the very first topic which here comes in is between and operator. Okay. Now what is this between and operator? Now let's say that I have the relational operator and I want the age greater than 20 or lesser than 20 or equal to 20, right? But what if I want that the age should be between 20 and 22? Then what will happen? Correct? So how do we solve that? To solve that, we will use this kind of operator which acts as a keyword. So we don't actually use the symbols or something, but we use a keyword to do this. When the condition has a range of values to be compared, we should be using between and operator. Write a query to display all the information of the students whose marks is in between 80 and 90 from the student table. So all the students whose marks is in between 80 and 90, we need to use between and. So select the star from the student where marks between 80 and 90. So all the student details who have got the marks between 80 and 90, the details are getting displayed, right? If you now look upon this particular screenshot, we have written select the star from the student where marks not between 80 and 90. Now we don't want those values which are in between the range, but we want those values which are outside that range. So we have to just use not between. Okay. So if you want the values to be inside the range, then we directly use between and. But if we don't want the values to be in that range, then we write not between. Similar case, if you use higher value first and the lesser value later, then you will get a result of no data found. Okay. See, you are writing between 80 and 90. That makes sense because 80 and then 90. But if you're writing between 90 and 80, it doesn't make sense to Oracle or to SQL. So it will say no data found. Now, whenever comparison has to be done with respect to set of values, we have to use the in operator. Okay. And in operator, what happens? We have to write a query to display all the information of the students whose age is 20 and 22 from the student table. So you want all the details of the students whose age is 20 and 22. So have a look. So in range, now understand the difference between and in. In will give you a range which will include only those data which you want to see. So in the bracket of in, you will only put that value which you want to see. There is no range as such. But in between and, we have a range. We have 80 to 90, 90 to 100, something like that. This is what is the difference between and in. Okay. So we use select star from student where age in 20 and 22. The students who is having the age of 20 and 22, we use in operator in that. Right? Okay. Now the next one is like keyword. Now like keyword is very interesting keyword. Why? Because this is very useful in many of the SQL queries. The like operator is used to search for a specified pattern in a column. So let's say that I have a particular student table in which there are many students' names. I want the student table to sort out. That means in alphabetical manner. So all the names starting from A should be above, then B, C, D, E, F. I want to sort it out. How we can do that? We can use like operator. Okay. So suppose I want all the A people names above. So how we'll use that? See, there are two pattern matching symbols in SQL, percentage and underscore. Percentage is also called as modulus. It matches 0 or more characters. So it either matches 0 characters or it will match more characters. Not 1. But underscore, it matches exactly 1 character. So suppose I have one particular name which is Raj and I have one particular name which is Ram. Okay. And if I'm writing RA underscore, so underscore is only taking 1 character. So in that case, RA underscore will give me Raj also as the output, Ram also as the output. Okay. But when you talk about modulus, then RA modulus, if you write Raj, Ram, then more names like maybe Rat, maybe some other name, those all things will come into picture. Let's take some examples. So write a query to display all the details of the student whose names starts with RA, right? So all the names which is starting from RA, we are getting the output, but we are not using underscore, we are using modulus. That means 0 or more characters, not 1. So either 0 or more characters. So we have 1 character M and in the another name we have VI, 2 characters, right? So more characters. Write a query to display all the details of the students whose name's 4th character is I from the student table. Whose name's 4th character is I. Only 1 character we need to find, so we need to use underscore. So select star from student where name like. So now we need to find all the previous 4 characters, but we know the 4th character is I, right? So we'll use 3 underscores and then a I. Why 3 underscores? Because we know that the 4th one is I. So the previous 3 letters we need to identify. And that is what we have done. So we are getting Ravi and Kavita because Ravi and Kavita is having the 4th letter I. This is how you will use the like keyword. Now next one is null. Is null, by looking into and reading the name, you must have understood what is it. Let's understand what is null. It is used to select only the records with null values in the column. Only the null values in the column will be there. Write a query to display all the details of the student whose age is null from student table. So let's consider a new table because in the previous table we are not having any null values. So in this table we are considering a null value which is in 125 USN and 126 USN. So we have a particular age value where null values are there. And we need to write a query to display all the details of the student whose age is null from student table. So what will be the query? The query will be select star from a student where age is null. wherever the age is null, that particular detail will be shown to you. Now, next one is logical operators. Logical operator, we already know in many of the programming languages we have and, or, and not, right? We also have this particular logical operators here in our Oracle and SQL. Then write a query to display all the details of the student whose marks is greater than 85. Now understand that this is one part of the question. Write a query to display all details of the student whose mark is greater than 85. And their names should be not start with R from a student table. Don't you think we should use here like operator? And don't you think we should use here the relational operator? Right? Now, there's one more thing which is AND. So we can use here logical operator AND. Right? Let's see what will be the answer of this. Select to start from a student where marks is greater than 85 and name not like R modulus, because we don't want the R names, the names starting with R, right? So we are getting all the names which is not starting with R and the names are scoring greater than 85, right? So these are the questions, these are the ways the question will be asked, and this is how we have covered the next topic, which was operators as keywords.
After exploring the powerful features of Oracle SQL, we are now going to dive into PostgreSQL. PostgreSQL is an advanced open source relational database management system known for its extensibility and standards compliance. Next, you will learn how to utilize your SQL skills within PostgreSQL, take advantage of its unique capabilities, and understand why it's a popular choice for many developers and organizations.
Now let's talk about databases. So what is a database? Database is basically a collection of data, but that collection of data is stored somewhere in a structured way. When I say somewhere, it might be on a local machine, it might be on a data center, it might be on cloud, it might be on a server, but it is stored somewhere in a structured way. So it's a collection of data. Now that data can be, cleaned, pre-processed, or you can store the data directly in a semi-structured or unstructured way as well. There are many databases using which you can store the data in a semi-structured or unstructured way as well. But majorly, database is a structured collection of data. It is stored and organized for some special purpose. And that purpose can be maybe the retrieval of data, maybe the management of data, or updating the data later on, or maybe to extract some information but by analyzing the data. So all these processes can be done only if a data is stored somewhere in a proper manner or in a structured manner. So that's all about database. Now there are different types of databases. Let's talk about them. So let's talk about relational database. So in relational database, the data is stored in the form of tables, right? There will be rows and columns. So in a tabular manner, the data is stored. There are other concepts like keys using which you will be able to access those data. So basically the structure of the data which is stored in relational databases, tables. For example, MySQL, Oracle. So these are the examples for relational database. Now what is NoSQL database? So NoSQL database is generally used for storing semi-structured and unstructured data. For example, MongoDB. The widely used database nowadays is MongoDB, which stores unstructured or semi-structured data as well. Then is your document database. The database which stores data in the form of documents. Documents can be a JSON document or XML document. So in this document format, if the data is stored, that is your document database. Then there is graph database. Graph database is generally used for representing relationship between the different objects, different classes. So that's your graph database. So basically it is used for representing complex relationship between objects. Then is your columnar database. Columnar database is used for storing the data in columns. So the accessing, storing and everything is in the form of columns. Then is your object-oriented database. So in object-oriented database, every data, or you can say some collection of data, is referred as objects. And in object-oriented database, there are relationships between those objects which are demonstrated. So in all these databases which I've talked about, for example, in relational database, there is not just one table in which all the data is stored. There are multiple tables and data is stored in a structured manner in those tables. Similarly, in document database, there might be multiple documents, right? In NoSQL database also, there can be the data stored in a different structure, in a different way, in multiple, chunks or multiple collections, the data can be stored. So this is all about your different types of databases. Now let's talk about what is PostgreSQL. As I said, PostgreSQL is also called as Postgres. This is an object relational database management system. Object relational meaning it's a relational database management system as well as object-oriented database management system. Meaning it provides you the features of both. Depending upon the application which you are working on, you can select or choose you want to go ahead with the relational database features or object-oriented database features. It's an open source software, meaning it is freely available. You just have to go to the official website of PostgreSQL, download, install it and get started with PostgreSQL. There is no licensing or anything required here. There is no trial period or anything. There is no billing or subscription fees. It's completely open source which you can make use of. It uses SQL query language. So the name itself describes this, that is SQL here. This SQL word is added in Postgres because of this feature only, that it supports SQL, structured query language. So if you are aware of the commands or the SQL query language, you will be easily able to work with PostgreSQL. Now, you must be wondering that if we have already so many softwares for, so many database management systems for SQL support, then why is this PostgreSQL? So there are certain features of PostgreSQL which outstands it from the rest of the database management system. Those features I'll talk in some time, but let me tell you which are the domains or application areas for Postgres. So finance and healthcare applications. So wherever there is a requirement for a secure, a reliable database management system, those areas Postgres is widely used. So definitely healthcare applications and the financial organizations, softwares which are developed, applications which are developed, require it to be highly secure and reliable as well. So that's the reason Postgres is widely used in these domains. Now, some advanced features of it supports data types from primitive to structured to document. Meaning, primitive data types, that is integer, real, varchar. So these are the primitive data types. These are supported by Postgres. Apart from this, it also supports document related data types. For example, you can have XML, JSON, documents as a data type, okay? Then there are geometry based data types also which is supported by PostgreSQL. So these are the features which makes PostgreSQL widely acceptable. Then data integrity. There are various integrity constraints that are supported by Postgres. For example, unique, not null, keys. So these are the integrity constraints which are supported by other relational database management systems as well. Explicit logs. So this is one feature which offers or which makes Postgres different or which makes Postgres widely acceptable, that is explicit log features. So this was all about your PostgreSQL. Now we'll talk about a little bit of history related to Postgres, like when was it invented, who invented it, how was the progress of it, and how is it being now used. So it all started when the person named Michael Stonebreaker, he started a project known as Ingress, and this was in the year 1986 at University of California in Berkeley. Michael Stonebreaker, along with few of its teammates, he started this project Ingress to develop a database. So it was basically a database related project. Eventually, he kept working on it, and in 1986 itself, the project was renamed as Postgres. Till now, when the project was renamed to Postgres, the features of a database management system on its own, like all the features of a database management system, was incorporated into this project when it was named Postgres. Now, going ahead in 1996, it was renamed as PostgreSQL. So the same person, he kept working on it along with the support of other people. And in 1996, after 10 years, a complete PostgreSQL database management system was developed. The name, as I said earlier also, that SQL is added at the end to display this, that SQL support is there in this DBMS. Post that, there were so many releases, but earlier from 1996 to 2000, the releases were very less. There were less enhancements being done, or even if the enhancements was done, that was minor enhancements which were done. In 2000, the first major release was done as a version 7.0, Postgres 7.0. The latest version which is there now was released on 14 September 2023, which is PostgreSQL 16. So in our hands-on session now, we'll be using PostgreSQL version 16 itself. So as I said, from 2000, the major release was done, the major enhancement was done. For example, I will tell you that in 2000, when the version 7.0 was released, the concept of foreign keys was added. Similarly, after that, then another release was in 2005, that is 8.0. Then in 2010, 9.0. Then it was in 2017 when the 10.0 version was released. Similarly, from 2017 going ahead, 2018, 19 till 23, every year some major enhancement is being done in PostgreSQL software, and the releases are there. So the latest one, as I said, is PostgreSQL version 16. So that was all about the historical improvements starting from 1986 till 2023. Now let's talk about the features of PostgreSQL. So as I said that, there are other relational database management systems as well as object-oriented DBMS in the market. So why is this PostgreSQL widely used? So to understand that, you have to understand the different features which are there for Postgres. So the first one is it supports multiple programming language. It supports the programming languages like Java, Python, C, C++, Ruby, .NET, PHP. So all these programming languages are supported by Postgres, and that is one of the very strong feature of Postgres. It's open source, means it is freely available. You just have to go to the official website of Postgres and download the software to make use of it. It is extensible. So when I say extensible, it means that Postgres provides you a support for creation of your own data types, custom defined data types. It helps you also to create your own indexes, right? So there are such kind of features which make this software or which makes this DBMS extensible. It's highly reliable and secure. So when I talk about highly reliable and secure, it's important to mention here that it follows all the ACID properties of a database. So ACID here stands for atomicity, consistency, isolation, and durability. So these features are supported by Postgres. Apart from this, to make it a secure DBMS, it supports wide range of authentication methods and also SSL certification based connection encryption option is there, which makes this Postgres highly secure. It also supports MVCC. So MVCC is multi-version concurrency control. So for the systems where there are concurrent transactions going on, it becomes very important to make sure that there is no deadlock and there is no problems in concurrent execution of transaction. It gets executed smoothly, meaning it satisfies the ACID properties when there are concurrent transactions being executed. So Postgres provides the support for that as well. It provides a multi-version concurrency control model using which you can execute multiple concurrent transactions simultaneously without any problem. So these are the features of PostgreSQL which makes it different and widely acceptable nowadays for different types of applications. As I said that there are so many features for it to be a secure DBMS, for it to be a reliable DBMS, and hence it is widely used in the fields of healthcare and financial organizations application. Now we'll be installing Postgres software on our machine, on our laptop, and then we'll go ahead with the hands-on session for the same. So before going to the actual installation steps, let me tell you in nutshell what basically I'm going to do. So first of all, you have to visit the official PostgreSQL download page. So the link is given here. You can directly click and go to that. Once we are arrived at the official website of Postgres, then you have to download the installer from there. Depending upon which operating system you are working on, Mac, Linux or Windows, you have to select that and then install. I'll show you as well how to do that. But in nutshell, let's understand first. Then you have to install the database. In the installation process, you have to select which all plugins you want of Postgres, as Postgres is a very heavy software. Different aspects are there for a Postgres. So which all tools, or you can say plugins of Postgres you want to install, that has to be selected in the process. Also in the process of installation, you have to select a password. This password you have to remember because later on it will be used every time when you log into either the pgadmin GUI of Postgres or the SQL shell. So let's go to the official website of PostgreSQL. I'll click here and directly go to the website, or if I'm pointing here, you can see that the website link is coming down, www.postgresql.org. You can go to the website as well, directly typing it in Google, and then go to the downloads option of it, and you will reach to the same place where I'll be reaching here by clicking. So you can see we have arrived here, www.postgresql.org, and in the downloads section, you can see PostgreSQL downloads options are there. So what are the packages and installers you have to select from here? And there are so many other additional information. So depending upon which OS you're working on, Solaris, BSD, Windows, Mac OS, Linux. So as mine is Windows, I'll be selecting this. Once you select that, you can see different versions of PostgreSQL, 16, 15, 14, 13. Depending upon which version you want to install or download, you can select. But as I'll be downloading the installer first, I would recommend you also to go ahead with these steps. So download the installer. So click there. So it will take you to this page. So you can see there are the options here for different versions, but let's install the latest version, right? This one. So this is for Windows. So 32-bit is not supported. It's only 64-bit. So the download has started. So once it downloads, we can install it. So we'll wait for some time. It will take some time for around 3 to 4 minutes to download, depending upon your net speed. So now it has downloaded the installer. Double click it to open. So now we'll go through the installation steps. Just click on next. So this is the installation directory. You can select this or you can change it. I'll leave it as it is. So HC program files, PostgreSQL folder is created. Then here is what I was talking about, the different tools or the different aspects of Postgres which you want to download or install. PostgreSQL server, pgadmin, stack builder, command line tools. So I need the SQL server, pgadmin and command line tools. So let's let all these be selected and go to next. So this is a data directory where it will be stored. Now here is the password which you have to select. So the password, you can select anything, but make sure you remember it because every time when you will be using Postgres, you need this password. So the port number by default is 5432. If you don't have any other softwares running on this port number, that is 5432 on your machine, no need to change it. But if you have other softwares installed and running on this port already, then you might have to change the port number. Otherwise, you can leave it as it is, 5432, and go to next. This also you can leave it default. Just click on next. So this is the settings which will be used for installation for all of these. So database, the port number will be this, the directory is this. So this is the detail which we have filled till now. Just click on next. Now you click on next, it will install. So it might take some time to install the software. So let it get installed. It might take some time for you to install as well. So it's now installing the database cluster, which will take a few minutes. So let's just wait. So yeah, the installation is complete now. Setup has finished installing Postgres on your computer. Okay. So you want to launch it or what? You can select accordingly and then finish it. Now this is a stack builder. So this process also, okay, you have to select the installation option. Select PostgreSQL 16 on port 5432. So you can see here the different aspects which need to be installed. We'll not go into details of it. If you want to select any of these, you can select depending upon your requirement. Then you can go to the database drivers. So depending upon which programming language you are working on, you have plans to work on, you can select. So I'll just select PGJDBC and NPGSQL. Okay, and let this also be there if at all in future you need it. Database servers, so anyone would do. So just this is already installed, right? It's showing here. You can have one more version or it was not needed. Registration, okay, we can have one here also. This is okay, GIS feature, the special extensions for web development. Let's have this. Okay, select all these. Depending upon your requirement, you can select or you can skip as well because the basic server and things have been already installed. Click on next. Now this will take some time to download and install. So whatever things we have selected, it will download all of those and then install as well. Okay, so all the softwares have been downloaded and it will now take few more steps to set up all the drivers or all the extra tools which we have downloaded just now. Just click on next. Let the installation directory be the same. So it will just install all those as the download was completed. Click on finish. Similarly, for all the tools which you have selected there from the stack builder to install, it will install all those. So once you finish all the installation for all the tools one by one, as I showed you right now for two of it, click on finish. Now let's check that the software has been installed successfully or not. So for that, just go on the start menu, type pgadmin. So you can see here it shows pgadmin 4, right? So go to the start menu and then you can go to the Postgres package which is installed here right now. Yeah, the PostgreSQL 16. In this you can see pgadmin as well as SQL shell. So we'll be working with these two. pgadmin is a GUI version of it where you will be having a graphical interface where you have to do minimalistic coding, or you can say minimalistic commands you have to write. And SQL shell is where it's like a command prompt where you have to write each and everything. I advise to work with SQL shell initially because you will even remember the commands which you will be typing and you will learn quickly. This is my advice. But if you are thorough with the database commands and you are well versed with SQL queries, then you can go ahead and use pgadmin as well. That is faster if you have to build an application. So here, once you open the SQL shell for PSQL, this will ask the server and localhost. Just click or press enter. Database, press enter. Port 5432, press enter. Username also you can press enter. Password you have to enter. So you remember initially I have told you the password. So you have to enter that password which you have entered or created while the installation of PostgreSQL. So once you enter that, so this will be the display message. So it means that the password was correct. Now to check that the correct version or has been installed, or any version has been successfully installed, you can type select version brackets semicolon. Okay. So here S should be capital, V should be capital, and select version, round brackets, semicolon, and this will display. So we have installed and downloaded PostgreSQL 16 version, like 16.0. So this has successfully installed. Now, this was the process of installation of PostgreSQL on Windows machine. You can follow the same steps, or I can say almost the same steps for Mac and Linux as well. Now, let us talk about the hands-on part of PostgreSQL. So, in this as I already said to you, that I'll be working on SQL shell as well as pgadmin. SQL shell is the command prompt or command line interface where you have to enter or type each and every command or SQL query to make it execute. And secondly is pgadmin, which is a graphical interface, which I'll show you how it looks like. Just by some clicks, you will be able to create a table or a database and run your queries. So one by one, first I'll demonstrate SQL shell. The same process we'll do it on pgadmin. I'll be demonstrating in this session all the basic commands. So few commands, if you are aware of MySQL or SQL queries, you might be knowing. That is basic commands like select, drop, create, insert, and update. But certain commands which are specific to Postgres will also be discussed, and that is offset, fetch, like. The other clauses, SQL clauses, I could say, like where, order by, is null, also exist in other relational database management system, but offset, fetch, and like are somewhat which is related to Postgres. So we'll be discussing all these in this session. So here is the command line interface. So as I already told you how to check that the correct version or the Postgres has been successfully installed. Now let's see which all databases already exist. So when we install any software or DBMS, some predefined or pre-installed databases are there. So let's check if at all is there or not. So /l. So it will list down all the databases. So you can see it's there, right? Postgres template 0. So these are the databases which are there. So we'll be creating our own database and trying to work with it. Okay. So to create one database, what you have to do is, okay, we'll write C as capital. Create database, maybe Postgres _ test. So you can see the database is successfully created. The name of the database is Postgres _ test. Okay. To make use of this database, what you have to do, /s, name of the database, Postgres test. No semicolon here. So you can see here it says connection to server at localhost. Okay, this failed. It says it does not exist. Okay, so we'll try again. Postgres test. So yeah, the slash was the backward slash actually before C, and then the name of the database. So now you are into this database. So in whatever you will create here, the table, the views or whatever will be inside this database. So you can work now. So I'll be creating a table. Now let's create a table by the name of employee. Okay. So the syntax for that is create table, table name, employee. All the columns which you want in this table can be listed now in the bracket. So open bracket. The first column we want is employee ID, which has to be an integer, comma, employee name, which can be of type varchar. Let's specify the limit to it or number of characters, I could say. Employee ID, employee name. Now, employee address, which also will be of type varchar 40. Let's have a column as salary, which will be of real data type. Close the bracket and semicolon at the end. So we have created the table. Make sure that all the commands, either you use it in capital letters or small letters. So you can see the difference here, right? that I used capital letter for create, it gave me an error. So the small letter has to be there for the commands. So going forward, we'll be using the small letters for all the commands related to Postgres. So the table has been created. Now, before inserting the values into it, let me show you how we can do the same steps in pgadmin. So go to the start. Okay, you can type pgadmin, click on it. So you can see this is the interface for pgadmin 4. Okay, these file, object, tools, and help, these are the menus option available. And then there are, this is the dashboard, the different properties. So these all will be available only if you start working. So here is the option for quick links like add new server or configure the pgadmin. pgadmin website, documentation, you can go to the documentation from here itself and read. We'll just go ahead and see, as soon as I clicked on the server here, it prompted to enter the password. So I have to enter the same password. Click on OK. So this is the GUI basically. We have entered into the server connection is established. And now we can see here the databases. So we have just now created this database, right? Postgres_test. So this database is here. You can create the database also from here on this GUI. But I'll show you how to create tables. So we have created a table, right, in the database Postgres. So if you go in this database, and you have to make sure you have to refresh the database. So if you right click here, there's an option for refresh. So once you refresh it, you'll be able to see all the tables or whatever activities you have done using using SQL shell will be reflected over here. So if you go to schemas option, and then under tables, you can see there's an employee table which we have created just now, right? If you have to create more table, you can right click on this and then click on create table. So I want to create it inside this database itself. Okay, so I'll go here, create the table. So to click on this, create table. The name of the table has to be specified. So I am giving a name as maybe company, or okay, fine, let it just be the company table. Schema will be public. Now from here you can select, this is the general properties which we set, right? And then there are columns, there are advanced property, constraints if you want any to be set. So I'll go and select columns and you can type the name here and data type, length, scale, everything. So let's insert. So the first column will be company name. The data type I want is your varchar. Okay, you can specify the length. You want it to be null, not null, primary key. I am leaving it to be default, whatever it is, not null, and I'm not setting it as a primary key also. Next, the another field I'm going to give here is registration, or let it be short form, registration ID. This I'm going to give it as integer. Okay, I'll make this as a primary key and this as a not null. Okay, the another column would be company address. Let this also be varchar. Specify the length to be 30. And that's it, 3 columns I want in this table. So let's save it. So you can see here, this is the company table, right? The columns, you can see company name, registration ID, company address, right? So this is how we create a table. This was so easy in pgadmin, GUI interface. So we saw how to create tables. Now let us go ahead and see other commands which you can execute. So once creation of table is done, let's see how we can delete a table or drop a table. So to drop a table, meaning the complete deletion of the table along with its columns and everything, can be done in SQL using the command drop. So now we have seen how to create a table using SQL shell as well as pgadmin. Now we'll go ahead and work with those tables created. So first I'll demonstrate you how to drop a table, that is delete a table along with its columns and everything. Then going ahead, we'll talk about deleting a particular row. Then we'll also talk about how to update the values in a table. So let's see all these three using the pgadmin itself. So here, to create or write a query, you need to create or start a query tool. So right click on the database. You can select query tool. So once this window appears, you can type your commands. So I'm going to drop a table and show you how we can delete a complete table. So let's see all of these three commands one by one. So I'll use drop table, the name of the table. So we have created employee table. Let's delete that and check. So drop table, table name, employee. So it says drop table. So we have to just refresh it once to see if it has been deleted. So you can see there is only one table now, that is company, right? Now we should insert the values now into this table to understand delete and update commands. To insert values, we have to just first create the table again. So I'll go to the SQL shell as we have created it here. So the commands is already there. So create table employee, enter. So it has created the table. Okay, so create table is written, that means it has created the table. Now we'll go back to the pgadmin and then just do refresh over here. You can see the employee table will be there, okay, with the columns as employee ID, employee name, employee address and salary. Now let's insert the values into it. So for that, the same SQL query command, that is insert into table name, employee, and then the values which was there. So we have, you go to this and see you have employee ID, employee name, address and salary. Make sure the data type specified, the data should be accordingly to the data type specified. So employee, the first one is employee ID. So I'll give as maybe, let's start from 2. And then there is employee name. So I'll write just my name itself. So this has to be a string, right? So you have to enclose it into a bracket, into commas, sorry. Then there is address. So let's write Bangalore. And then there's salary. The salary has to be a real value, right? So you just enter something, maybe 80,000, or you can just leave it. It will convert it also at the bracket. Now execute this. Okay, so the problem here was that we have not specified the columns in which we are entering the values. So along with the table name, you have to specify the columns as well. EMP ID, then EMP name, then EMP address, and then salary. Okay, into values, and this is the value. Now let's execute this. So this has inserted these values. Now we'll just copy paste and okay, so what we did here is to insert the values into a table, the SQL query has to be used, that is insert into, then the name of the table, all the columns which are there in the table has to be specified, close the bracket, values, and then the values which you want to insert into the row. So this is one row inserted. Now similarly, let's insert at least 3 rows so that we can work on few of the commands later on. So I'll just copy paste it and change the values here. Okay, and the name Let's change it to Priya and let this be as Pooja. The address, let's change it to something else, that is Delhi, and here I'll change it as Chennai. Let the salaries also get changed, maybe something like this. Okay, let's execute all these three. So this was already done, so let's execute these two. So yeah, the query has been successfully executed. Now let's see that what are the values in the table. So select star from employee, that is table name. So we'll execute this query. So you can see these values are entered 2, 3 and 4, employee ID, name, address and salary. Now to delete any one of the row, what you have to do, what is the command that has to be used? So delete from the table name where employee ID is. You can delete any one, maybe let's delete 3 where the employee ID is 3. So delete from employee where employee ID is 3. So let's execute this. So yeah, the query is executed. Now I'll again execute select star from employees to check that has it been successfully deleted. So you can see yes, only 2 and 4 is present, 3 is no more there. So this is how we work on delete. Next is your update. So if we have to update any values which we have already inserted for any of the row, for any of the data, then we have to use the command update table name where employee ID is equal to maybe 2. What you have to update has to be specified, right? Suppose I want to change maybe the the salary. Okay, so for employee ID 2, I want to change the salary as set salary to be, so earlier it was 80,000, now let's change it to maybe 85,000. Right, now let's execute this. Okay, so there's an error. Okay, so the error says that this has to be before. So just here, what you have to set should be specified before. So update employee, set salary as this, where employee ID is 2. Let's now execute it and check. So yeah, it gets executed. Now I'll run this query, select start from employees to check. So you can see yes, the value of salary is updated to 85,000. Right, so this is how we work with update command. So we saw delete, update, insert, select command and also drop table. Okay, so as we saw all the basic commands, right, that is insert, select, delete, update, drop. Now let's see some of the clauses in Postgres. So clauses, when I say, I'm talking about where clause, group by clause, then there is fetch, limit, all these clauses we'll be talking about. So starting from where clause. So using where clause, we provide condition on the activities or the selection which we want to do. For example, select star from employee where this should be star. So here I want to select all those employee details whose salary is greater than 60,000. Okay, so I'll write where salary greater than 60,000. Now let's execute this. Okay, there was an error. So just spelling mistake in employee. So there is only one employee. As there were only 2s because we have deleted 1. Now let me first insert few more values, and then we can go ahead and execute other clauses. Okay, so I'll be inserting the values here, 5, 6, 7. Let's change the name to Priya. Go ahead. The places will change it to Delhi. Let this be Chennai only. Bangalore. Salaries, we can change it to some value. Okay, let me now execute this 3. So yeah, it's executed. Let's see now how many values are there in this. So you can see 6 rows are there in this table now. Now if I execute this, select star from employees, you'll have 2 values here. Similarly, we can have other conditions also. Okay, I'll just copy paste this. Okay, select star from employees. Some other condition can also be there, where EMP address is equal to Chennai. Okay, now let's execute this. So you can see 3 people were there whose employee address was Chennai, so that is displayed. So where you can now understand it is for conditional selection. So wherever you want to specify the condition. So here I am using selection. So condition is for selection. If you are doing some other activity and then you are specifying the condition, that where clause condition will be for that particular activity. For example, if you are joining 2 tables. So if you are specifying a condition, so that condition will be for joining the 2 tables. So that's what where is all about. Now we'll see the order by clause. So for that, this is the query which I have written. Select star from employee, order by the salary in the descending order it should be arranged. So if I execute this, so you can see the output here. So salary is arranged in the descending order, 85,067 and then so on. The minimal is 40,000. So this is your order by clause. Now next we have to see is limit. So on this itself, on the same query, let's use limit it to 3. So I just want the 3 rows, the top 3 rows to be displayed. So that is how or for what we use limit. So you can see the top 3 rows has been displayed. So this is your limit clause. Now let's talk about the offset. So for offset meaning it will leave that many rows from top and then it is going to display the result. So if I write offset 3 or you can change this value offset 2, so it is going to leave the top 2 rows and then display the result. So you can see the top 2 rows of 85,000 and 67,000 is left, and then post that whatever was the output is displayed here. If I write here top 3 should be left and then execute, so you can see only the 55,000 is also no more now. So apart from the top 3 rows, whatever is the output has been displayed here. So that's why we use offset. So these 3 commands or these 3 clauses we studied. So we talked about the basic commands: select, drop, create, insert, update. We talked about the clauses where order by, okay, is null is still to be discussed. Offset, fetch and like has to be discussed. So let's go again to the PG admin. Okay, so let's see now first is null clause. So for that, I'll write a query: select star from employee where salary is null. So the output for this should be nothing, because we have value for salary in all the rows. If any of the rows is left blank, as for salary, we have not specified that it cannot be null. So it can be left blank, that is null. So if at all that was the case, then there would have been a row displayed. But as we have salary value for all the rows which we have inserted, that's the reason the output is blank, nothing. Next is your fetch clause. So for that, I'll just use this query. Order by salary, descending order. Okay, suppose that we can write fetch okay, so this should be first 3 rows only. Okay, so just execute this. So you can see here, it fetches the first 3 rows only after ordering the salary in descending order from the employee table, and it is selecting everything, so displaying each and every column. You can write here you want the first 4 rows. So fetch is basically for fetching that number of rows from the complete output which could have been, or from the complete table. So this fetch clause is null. Next is like. So for like, we can use select star from employee, where so like is used for pattern matching, I could say. So if you want to select all those employee details whose name maybe starts with P, okay, so you can use where employee name like, then in comma you can write percent, or starts with P, so P and then percent. Right, let's execute this. The employee table should be double E. So you can see all those details of employees where the employee name was starting with the letter P is displayed. So like is something for used for pattern matching. So starting with P, if you want some ending with P, or you want some characters in between, that should be there. So for that percent, then those characters percent. So beginning and ending can be anything, in between those characters should be there. Or you want that something should be in the beginning but it should end with P, or it should end with A. You can write accordingly percent and then A inside the comma. So this is for what we use like clause or like operator, you could say. So this was all about the basic commands in Postgres. Now let us talk about some advanced concepts in Postgres, that is aggregate functions and other different functions which we can use or work on different rows of a table. So let's go to the pgadmin interface. So here, to work for aggregate functions, so what are aggregate functions? So there are some inbuilt support for functions which can be worked on numerical data. For example, count, that will count the number of rows. Second is minimum. You can find the minimum of the certain range of values. You can find maximum. You can do the sum or find out the average of the values. So all these are aggregate functions in Postgres. So let's see few of the examples. Select minimum of salary. Okay, you can use as keyword or as command to display certain value or certain output as some column or as some heading name. Okay, so I want minimum salary to be displayed and the name of that output or the column should be minimum salary. Okay, from employee table. So minimum salary as minimum salary from employee. Let's execute this. So you can see the minimum salary is displayed. The heading for this or the column name is minimum salary. Right. Similarly, you can have max salary also. Max salary, and this I'll change it to maximum salary. Let's execute and check. So the maximum salary value is displayed. You can have the average of it or the sum of it. Anything is fine. So I'll write average. And then this name can be final salary. Okay, from employee. Let's execute this. So this is some average value to some double precision is used. Okay, so 57833. This is the average of all the salaries combining all the rows. So these were the sum of the aggregate functions. Now talking about other functions which are also there, which you can work on. For example, you can find out the mod of a given number. You can find out the square root of a given number. So these kind of functions support is also there in Postgres. For example, select mod of some number, maybe 60 to the base 2. Okay. Okay, it gives 4. Let's change this value to 10. Might give us the answer. Now let's change this value to maybe 64 as we are getting the mod answer for 0 for all. So now you get 4 as an answer. So you can find out the mod of a given number to any base. Okay. You can also find out the square root. So SQRT, square root of 64. That is 8. So these kind of other functions are also there in Postgres. So all the SQL functions, basically, that support is there in Postgres as well. So you can find out the mod, square root. The other functions could be, you can find out the least, greatest, ceiling function is there, floor function is there. So all of these functions, similarly like how I executed mod and SQRT, square root, you can implement all those functions as well and get the output. So this was all about the different commands, the basic commands we discussed, like select, drop, create, insert, and update. Then we discussed where, order by, is null, offset, fetch, and like operator. Then we discussed some aggregate functions which you can work on a given table. Then different functions support is also there in Postgres, which we saw with the help of example.
Now that you're familiar with the capabilities of PostgreSQL, it's time to apply your skills in a practical project using MySQL. Do you want to have hands-on experience with SQL? If so, then do subscribe to our channel and learn more about Broadband Database Management System with us. Next, we will dive into the Broadband Database Management System project, which involves managing and analyzing broadband service data. This project will provide you with hands-on experience in using MySQL to solve real-world problems, demonstrating how it can enhance your data retrieval and manipulation capabilities. By the end, you will have a deeper understanding of how to implement and manage complex data structures within your SQL queries.
Broadband Database Management System. So there will be a proper broadband management database. You will have your, customers, you will have your broadband connections, you will have your package, and we are going to talk about all these things, right? And what we are going to do, I will show you how can you make your diagram in MySQL Workbench, right? I hope you are interested to learn the project, and we will solve some queries with the questions as well to understand how the whole concepts we have learned so far, how it's gonna work, right? So let's go to MySQL Workbench and let's have a look at how we can start with this project. Now we are going to talk about one project using MySQL, that is Broadband Database Management System. Before start the project, I will show you in the MySQL Workbench how can you see your diagram in MySQL Workbench as well. So let's get started with the project. So for this project, I am going to make my own I am going to make the SQL script, a new SQL script, because we are going to do a huge database. And this time I don't want to make this the before whatever we have done. I just want to use all of them, and I just don't want that our database will be a mixed up one, right? So here what I did, I just create a database called internet, right? I have created before as well. So what I did, I just said, hey, I just want to drop my database. So I will start from the scratch. What I am going to do, I am going to write create database, and my database call will be, the database name will be internet, right? Let me just execute that. We all familiar with this command, as we have learned so many things in MySQL. So first, anything you have to start with, you need to create your database, right? So this will be like a recap for you guys, and it will help you to understand how you can start from a scratch to make a whole total database, right? So I have created my database. Now what I need to use, I said, hey, I have created a database called internet, and now use internet only, right? Let me just do that. Yes, now it's gonna use the internet database. Now if we want to see how many databases we have, show databases, right? The way we write, and then semicolon. Don't forget to put the semicolon again, right? Now you can see we have lots of database like ABC, ABC2, BMS DB. Let's just scroll it down. You will see the other databases as well. You can see internet database is also there. So your database is created and in use. You can start creating your tables. Now, as we have done about join table, we did some tables, right? We make some tables. Now, what we are going to do, I just want to see the year diagram for that particular database, right? How can you do that? So if you want, you can go to that particular SQL script, and I have use my final one, if I am not wrong. Yeah, it's gonna use my this database. And now what I need to do, go to database, right? Then reverse engineer. Go to reverse engineer. Wait for a few seconds. It's gonna take some time. From there, you can see my host name is 127.0.0.1. Port is 3306. Some of the cases, if you change your port, be sure that, okay, I have changed my port and this is my port number. You have to very sure about all these things. And your my username is root name, and if you have changed your username, put that, right? Then press next. You can see it's just gonna ask you your password. For my case, 1, 2, 3, 4, 5, 6, 7, 8. My password. Your password is you can save your password whenever you are going to install. So I have shown you in the installation process. Then that time you have to give a password. So whatever password you are going to give, you need to remember that, right? So my username is root and password is 1, 2, 3, 4, 5, 6, 7, 8. Okay. Then okay. Yeah, it's gonna take few time. Yes, retrieve schema list from database, check common server configuration issues, everything is done. Go next, and you can see your database list, all the database you have. So I am going to use, okay, my database name was my final database. Where is it? I am not gonna get that. Okay, let me just go down. Okay, my demo final one. This is my database name, right? Then go to next, and you can see next, check result. Okay. Okay. Right, then execute. Let me just, it's gonna take few time to make the year diagram. It's already there. 2 tables, 2 views from my demo final one, right? We have 2 tables and 2 demos, right? If you can look at here, where is my table? Yeah. Can you see the relationship we have? This data of customers and account, they both have. Can you see this? Whatever we have talked about, one to many, one to one, right? Can you see this? This is something, the symbols we have over here. If I can make it bigger, no, I cannot. So these are 2 views. These are not tables, right? So we have talked about the tables and the views. So yes, this is about the views and the tables. Now we are going to see what are the tables we are going to make in this database called internet, right? So in our database, we have already created a database called internet. How you can create that? Create database, and then you have to give the name of your database. So for case of this database, I have named it as internet. And then again, we are going to use internet. Why we are using this in Notepad? Because I just want to make you understand what are the table and what are the attributes we are going to use. And from there, we will make our year diagram. And why we are doing this? First, here we are going to make the table. So already I have done the year diagram for this. So as I just want to show you how can you make year diagram using MySQL Workbench, right? We have done for a small database, but here we are going to do for the full database, the database we are going to make called Internet for Broadband Management System, right? So here we are going to make a table called customer. In this table, we are going to have few attributes. What are those few attributes? We are going to have customer ID, first name, then last name, birth date, join date, city, state, street, main phone number, secondary phone number, fax, like if you have fax, then fax, monthly discount, package ID. So here customer ID is a type of integer, first name is a type of varchar, last name is a type of varchar, and the length will be 25. Birth date is also type of varchar. You can make it date as well. Join date is a type of date. City is also varchar. State is also varchar. Street is a type of varchar, and the length is 40. Main phone number will be varchar 12 with the like the code 10 plus 2 numbers of digit code. Then you will have secondary phone number, that is also 12, will be varchar. You can make it int as well if you want, and if you want to make a plus sign, so you need to go for using varchar. Then we have fax varchar 12 and monthly discount, that will be in decimal. It can be float value, right? Decimal value. So decimal 4,2. 2 is basically the after point, whatever the like digit you can have. Then package ID, that is int, right? And here we have the inserting customer values. So right, what we need to write, insert into what? Insert into customers, then values, then you have put down all the records you have. Be sure you maintain the proper sequence you have maintained when you make the table. All the time, if you don't make the proper sequence, then you will get an error. We will do all these things in MySQL Workbench as well. Now we will move and we will see what other tables we have in this. So here we have create table package. So one table we are going to make called package. There we are going to have attributes called package ID, that is integer, speed of your package, that will be varchar, start date, when you start the package, that will be in date format. Then we will have monthly payment, the payment you need to do monthly. If you take that particular package, then it will be integer. Then we will have sector ID. So sector ID will be int, right? Now again we are going to insert these values into package table. We are going to make this first we are going to discuss all the tables we have in this database. Then we will go to MySQL Workbench and we will execute all these commands, right? Now, if you come down, then we will have a table called sector, right? In the sector table, we have only two attributes. One is sector ID, that is int, and second one is a sector name, right? That will be varchar 10. Okay. Now, if you want to insert them, insert sector values 1, private. So sector ID is 1, sector name is private, right? And some of the cases sector can be business as well. Like the way we use broadband connection for private and for business purposes. Is it for business purposes? Then it will be different, right? Now we are going to talk about the table called pack grades. So your grade of your package, right? There will be grade ID will be there, grade name will be there, minimum price, maximum price. And if you can look into this, we have inserted one. The grade name is basically very low. Yeah, sorry, grade ID will be 1, grade name is very low, minimum price is 0, maximum price is 10, right? In the case of second one, you can see it's low 11 to 20, then medium 21 to 40, then high 41 to 80, then very high 81 to 150, right? So these are the table we are going to have. So now let's go to MySQL Workbench and let's have a look at how we can execute these commands, and then we will have lots of query to solve, right? We will come back here. We will do all the basic commands we have used over there. We will do that. We will see our tables, we will see our databases, and all the select star from the table name. Fetching all the data from the tables, and then we will do all these queries to understand the concepts we have learned so far. So let's go to MySQL Workbench. Now we come to MySQL Workbench. We are going to create a database. If we have this database already internet, let me just drop it. Yes. So again, if we are going to create a database, then we need to write create database, and the database name is internet over here. Let me just create it. Yes. Now I said, hey, I have created an internet database. Now I just want to use that particular internet database. Let me just do that. Yes. So I am going to use this internet only. Now, if you want to see how many databases you have, you again need to write show databases. So you can see I have lots of databases, and in that I have internet as well. Now, what I need to do, now we are going to create a table called customer that we have seen before, right? So let me just create it. We know what are the attributes we are going to use over here. Let me just execute this. Yes, right? It's running and this is already done. Now what we are going to do, we are going to insert all the values for this particular table. Okay, I have already written down all these things because otherwise it's going to take a lot of time to write it. And in the later section, we will see how can you import, how can you use Excel sheet as well, right? Okay, so you can see we have already inserted all the values. Now, let me just write select star from customer. So why do we use this select star? We use select star because to get all the data from your particular table. Okay, it's giving me, okay, it's customers. Okay, so always be sure whatever the table name you are using. Yes, can you see your customer ID, first name, last name, birthday, join date, city, state, street, everything is there, your attributes and all the details are already inserted, right? Now we are going to create the table called package, right? Let me just execute this. Yes, and I am going to insert all the values in the package table. So if you talk about then this package and this customer will be your entity, right? According to the ER diagram, right? Okay, we have lots of package. Okay, let me just do that. Yes, it's getting inserted. Yes, it's already inserted. Let me just write select star from packages just to check all the all the values or all the data we have inserted. It's inserted or not? Yes, it's inserted already. If you look at it, we have speed 750 kbps, start date is 2012/5/12, monthly payment 79, sector ID 1. Can you see this? This is a package ID, this then speed, then start date, monthly payment and sector ID. Now we are going to talk about creating a table called sectors. So if I execute this, and we only have two sectors maybe, one is for private, one is for business. So it's already there. Again, if you want to see that it is already inserted to your sector table or not, select star from sectors. I will always suggest you to, after create a table, check that table is created or not. Then after inserting the value, always write the basic command that select star from that particular table to check whatever the data you have inserted, it's already inserted or not, right? So you can see for our sector, it's already private and business is already there. Now what we need to do, we need to create one more table called package grades, right? And here, yes, we are going to insert all the values to pack grades. Let me execute this. Yes, it's already there. I have written down over here that for the select star, yes, you can see our all the values is got inserted. Grade ID, grade name, mean price, max price. So if you have all the all the values, all the tables, so then you can write this. Now I am going to say, hey, show me all the tables I have in my database. Let me just execute this. Can you see? We have customer, package, grades, packages, and sectors, the fourth table. Now, if you want to see the year diagram, because I don't use any, constraints. So in that case, if you want to just see that what year diagram you get, so for that, you need to go to database. From there, you have to go to reverse engineer. And you can see you need to go for next. You need to give your password. We have talked about that. What is your password will be. So yeah, for my case, 1, 2, 3, 4, 5, 6, 7, 8. And then next. Then you have to mention which database you want to go for. Right. I have lots of databases. Maybe here. Where is my internet? Yeah. Can you see? This is my internet. Then next. Then next. Okay. Okay, why this next is okay. Then next, and then you can see 4 total objects, 4 selected. Okay, execute. Let's check how we are going to get your diagram. Then next, finish. Can you see? If you can look at it, this all this this is your year diagram. Sectors, packages, and package grades, right? Your customers. These are all your entities. And if, as we didn't mention any, primary key and foreign key concept, so we just don't get any relation over here. Can you see? Right. So this is how you can go for your year diagram. So if you already have, you can see year diagram is already there. ER diagram over here in the MySQL. So in MySQL as well, you can make your inner diagram, right? Okay. So we came back to our. So now we are going to solve few queries. Why we are going to solve few queries? To understand these concepts more easily. So here we are going to first look at the query and then we will solve that to MySQL Workbench. So what first query we got? In the first query is saying, hey, create a query to display the customer number, first name, last name, primary phone number, secondary phone number, and package number from customer table, right? Let's go back to MySQL Workbench, right? So what they said, create a query to display the customer number, first name, last name, primary phone number, secondary phone number. What you need to write, you don't need to get all the data from customer table. So basically it already said you need to have customer ID, first name, last name, main phone number and secondary phone number and package ID, right, from customers. So you need to write select, can you see? Select customer ID, your first name, your last name, main phone number, secondary phone number, package ID, and from customer, right? So you can see all of them is there, okay? Right. So this is the very basic one. This is the fetching the data according to like the using the attributes. Now let's go to that notepad and let's see what we have for the next query. So here we are going to say, hey, create a query to display first name, last name, join date, monthly discount after an addition of 20% and monthly discount after reduction of 20% from customer table. How can we do that? Yes, you need to do some of the mathematical, computation over here. All right, we are going to talk about this again. So I have already done this solution and we will talk about this solution again. Just a second, let me just take this up. Okay. So these are the basic thing you can do with MySQL. This is, I cannot make it more. Okay. So you can see what they said. Query. Just break the query first. What they said, first you need to have first name. So I said select, I have first name. Then they said you need to have last name. Yes, I have selected last name. Then they said you need to have joined it. I said, okay, I have joined it. Then they said you have monthly discount. I said, okay, I got the monthly discount. From there, they said, okay, now as you said, you are okay with everything. Now I make it more, more complex. How can we do that? Monthly discount after an addition of 20%. So what you will do? So 20% is 0.2. 20 by 100, that is 0.2. Just write monthly discount into 0.2 as discount, right? Then it's already said an addition of 20% and monthly discount after a reduction of 20%. So what you will do? Monthly discount minus 0.2, that is 20 by 100. 1 will be into 0.2, 1 will be minus 0.2 as reduction from customers. And let me just execute this particular query. So in the query itself, you can do mathematical computation as well. Just to do all this, because just to make you understand how you can do the query, how can you do the manipulation, how can you do the mathematical computation as well. If you can look over here, we got first name, we got last name, join date, monthly discount, and reduction. Can you see? We got it. So your monthly discount is 6 and discount is 1.2, reduction is 5.80. Right? So this is how we can do the mathematical computation. So I hope you understand this, how you can do that. Let's go to the next query and let's have a look at what we have next. Right. So why we are doing this? Okay. Let me just do that. So we have few more queries, almost 20-25 queries we are going to solve in this. And we will try to understand how we can do this different type of data manipulation part, data fetching part. And from the data itself, you can get some other, you can make some other attributes, right? Just the way we did like discount and reduction. We did not have this in our table, but we can make it using some mathematical computations as well. So what we have right now, let's see. Create a query to display the package number, okay, speed, start date, the date when the package become available, right? So start date is something that, okay, when the package become available. Then monthly payment and monthly, okay, then monthly payment into 12, right? So yearly payment, you can say, name the last column as a yearly payment as we talked, right? You can see it was saying, okay, give the monthly payment and I just want to see the yearly payment as well. So you will get it from package table. Let's do it, right? How to do it? Select packet ID, okay. Then they ask for speed, then they ask for start date. Then they ask for monthly payment, right? Then they ask for monthly payment into 12. You can directly write monthly payment into 12. Then you need to give a alias. The alias concept we have learned, as they said, you need to give, hey, as yearly payment. So you need to write as that particular attribute name as yearly payment. From where? From packages, right? So this is how we are going to use the concepts. Slowly we are trying to use those concepts we have learned so far in the tutorial. Yes, can you see? That packet ID is there, speed is there, start date is there, monthly payment is there, yearly payment is also there. And okay, let me just execute this once more. Okay, monthly payment is there, yearly payment is also there, that is 948. 79 into 12 obviously equals to 948. Right? So this is how we are like solving these queries. Now let's see what else we have. Okay, so here we are going to talk about create a query to display the last name of, okay, let me just copy this and go back to MySQL and try to evaluate what they are saying. Create a query to display the last name concatenated with the first name separated by space and main phone number concatenated with secondary phone number separated by comma and space. Oh my god, there are lots of things we need to do. Name the column, heading full name and contact details respectively customer table. Oh my god, let's break this out fast. First, what they said, create a query to display last name concatenate with first name. So first your last name will come, then you have to concatenate that with first name, but there will be a comma separated value, right? Sorry, they have to be separated by space. Okay, first last name, then first name, and you have to name them as what? Full name, right? Then you have to concat. So concat is basically we use to add two different attributes. Then you said, okay, your main phone number, then comma separated value, the secondary phone number. That will be as contact details from customers, right? So what we did, select. Concat is a full function. You call function called concat. Then the round bracket, you say it first last name. Then you have to break them or separate them, use space, right? In the, yes, in the, okay. Yes, we have done. We have write the space over here. If you can look at it, let me just make it big. Yes, concat, last name, then space, then first name, right? Then that is known as full name. You can write as or you can just directly write full name, right? For the case of main phone number, again we are using concat. Okay, it's got check. Okay, concat. Then we have written the main phone number. Then I said it will be have a comma separated value, comma, and then secondary phone number. And then it's known as contact details. That attribute name will be contact details. All of the attributes we are making over here, right? Can you see full name Smith Alvin? So if you say it as, we always write as. You can write as. If you don't want to write, then also it's a way of doing. Okay, all the time you need to write. You don't need to write as for aliasment. You can directly name the attribute as well. Right? It said Smith Alvin and then contact number is this. Then John's Joes and then the contact details is this. Then Williams Stewart and then the contact number, the two contact number is like this. So this is how our concatenate function works, right? Now we are going to talk about the seventh query. Let me just create, okay, let me do that. Let me just create 3-4 at a time. So we do not need to pin back every time and try to copy and paste it. Okay, right. Okay, where was we? Let me just try this out. Okay, 6. Now we will start from 7. So what? If you can look at it, like the commenting. So our questions are our comments. Like they are not going to, execute my question. So in that case, I have used this particular symbol, right? So this is how you can comment your data on MySQL Workbench. Now, what we need to do, we said create a query to display unique cities from the customer table. So you want to see what are the cities you have in your customer table. To get the unique cities or to get the, particular distinct cities, you need to use a function called distance. We have talked about earlier as well. So if you write select and then if you call the distance function and the attribute, the particular attribute you want to be unique, to see what are the unique attribute values you have. So you need to write distinct, then CT, then from customers, right? So this is how you are going to get all the CT. And if you can write, I don't know it's gonna take or not, right? It's gonna give us error. Okay. After distinct, maybe we can write. I don't think it's gonna take, because at anyway to give you more. No, it's not gonna. It's like normal distincts only, it will give the CT, right? So no. So basically we can write one thing. Okay. I can show you how can we do that. Select count CT, right, from customers, right? And can I use to function over here? Yes, we can. I just want to show you the difference, right? Can you see it's 20? And if we use distinct, how much? It is also 20. Oh my god. Okay. So we have all the distinct value itself, no repeated value. Okay. So yeah, if you can look at it, you can see all the CT we got, that is distinct. There is no, yes, there is no repetition. So distinct function is basically going to give you all the value that is distinct, that is unique in your table. There will be no repeated value will be there. Now we are going to talk about a new query. Create a query to display unique states from the customer table. Now you see all the CTs. Now you want to see all the state, right? Then what you need to do? Again, write select, then distinct, then your attribute called state, okay, from customers. So you will get all the distinct state from your customer table. Can you see all the state you got? Yes. So this is how our distinct function works with the in order to get the unique value from your attributes. Now we are going to talk about create a query to display unique combination of CTs and state from customer table. Now I want combination of CT and state as a combo of CT and states from customers, right? But that will be distinct, okay? Not like, hey, I want the combo of CT and state, but that will be in a repeated way. No. So you are going to use two functions at a time. You are going to use distinct function. You are going to use concat function, right? So here what we are going to do? We are going to write select distinct function, then concat your function with CT. There will be a space in between, and then state as combo, as is your alias, right? Your attribute name will be combo. From where? From customers. Can you see? New York, Los Angeles, California, Chicago, Illinois, okay? Houston, Texas, right? Philadelphia, and so on, right? So this is how we got it. So this is how we got the CT, we got the state, okay? Right. Now we are going to talk about create a query to display the last name concatenated with state separated by space. I know it's like making weird combinations, but yes, it's always I will always try to make you understand how this function are going to work and how you can use them and you can merge them and you can separate them using comma or space, right? Yes. How can we do that? Just write select, then called concat function, then what they say, last name concatenate with state. So last name, then comma, space, and then your state attribute. That will be known as customer and state. You can write as well. Otherwise, you can skip it. From customers. Let me just execute this. Can you see? Smith is from New York. Jones is from California. Taylor is from Illinois, and Williams is from Texas, right? So this is how you can create these queries, right? And we will do a few more queries on this database management system to understand these concepts more well. Now we are going to talk about the next query we have. Create a query to display the first name, last name, monthly discount, and CT, then concatenated with street, separated by space. Name the column headings if in, alien, DC, and full address respectively from customer table, right? Okay, so here what we need to do, right? Let me just try this out. Okay, can you see? First we have written concat, first function, first name, then give a space, last name, give a space, monthly discount, then gives a space, then write city, the city you are belonging, then space, then street. That will be as. Now we are going to use few more alias for one concats, right? As, if in, alien, DC, and full address. That too is from customers. Let's just have a look at how can you use one concatenate function and you will give lots of alias for them. Can you see? We got the result. Okay, let me just go here. Can you see? As we have written FN, alien, DC, and full address. Full name, last name, DC, and full address. Right? So this is how you can use a big alias for a full concatenate, right? For a full concatenate result you got from your attributes in the table. Right? So you can see you have first name, last name, monthly discount, city, street, and that too the name will be for the alias is if name, alien, DC, and full address, right? Yes. Now again we will go back to our question part and let's see, we will answer a few of them again. Okay, from 12 to take, okay, take till 10. Okay, right. Oh no. Okay, let me just take this again from here. Where will it be? Okay, so we have completed till, it's confusing actually, 11. So we need to take it from 12. Okay, let me just take all of them first. Okay, so take till 12 again. Okay, now what we are going to do, right, we did till this part, right? Yes, now we are going to talk about this 12th one, that create a query to display uniquely monthly discount from customer table. Again, if you need to do unique one, you need to use distinct function. Select distinct monthly discount from customers, right? Let me just execute this. Can you see we have what monthly discount we have? 28. And if you just write, I think here it will be different. Monthly discount from customers. Can you see? These are all these things you have. 28. Is there any repeated? Yes, 28 is there. Let's have a count of this, so you will understand the difference between them. Okay, let me just. Count is 16 for distinct value. Let's see what will be the count. $13. So can you see this count of monthly discount without distinct is 16 and count of distinct of monthly discount is 13. So this is how your unique values comes if you use distinct function. So in the query itself, they say they want all the unique monthly discounts in customer table. Now we are going to do one more query, create a query to display unique packages, that is packet ID in customer table. If you again need to display unique packages, you need to write select distinct, then package ID from customers, right? Let me just execute this. Can you see package ID? Yes, this is all the distance package ID you have, right? If we are going to do the same thing, select count, and if we are going to write pack ID from customers. Can you see that? And if we do the distinct function and then count, so if you can look closely, you can use two functions at a time for one attribute, right? So this is why we are doing it. It's 12. It was here, it was 20, here it is 12. So your distinct count of package ID is 12. Now we are going to use the where clause exercise, right? How we can do this where clause conditions. So where clause condition for first question we have display the first name, last name, package number for all customers now. Now the streaks will be there that package number of all customer whose last name is King. So you want all the customer whose last name is King. How can you do that? So in that case, what you need to write, select first name, last name, package ID from customers where. You are going to put that where condition the way we used to write where clause. Where lower, like lower last name. So why do we make lower last name? So we are making our last name to lower when we are writing King. So I just don't want like my query to be confused with the capital letter and the small letter. So I said lower, make it my last name lower, as when my last name is equals to King. King is basically the lower in the small letter we have written King. Can you see there is no particular name in my customer table whose last name is King. So before that, let's just write select last name from customers. Smith we have Johns, Williams, we have Wood, written Watson. What else if I write Watson? Maybe we will get one. Okay. Can you see we got one record when we write Watson? So basically, whenever you are going to put where clause, if your condition is not matching, it is going to give you null values, right? It's not going to give you any, yes. Okay, it's not going to give you any, answer for that. Or your query is like, hey, I have no condition matching with your query. Now we are going to say display all the data from packages table from packages whose speed is 5 Mbps, right? So I want to see all the packages whose speed is equals to 5 Mbps, right? Okay. So for that, what I need to write? Select, before that, let's just write that, this one. Select star from packages. Can you see we have package ID, speed, start date, monthly payments, and sector ID, right? And for speed, we have 750 kbps, 1.5, 2.5, 5 Mbps, right? Let me just try this out. How much we have? Yes, all the speed we got, that is 5 Mbps, right? Total, you can say where lower speed is equals to 5 Mbps, right? So why make it lower? Again, it will make everything in a small letter, and there will be no problem for when you have used this for a capital, or like if you can look at it, AM is capital, BPS is lower. So in this case, I make it all lower. Okay, so this is just a no confusion. Just not if you are be sure that you are not missing any value because of this capital and small data. All right. So this is how we are going to get all the speed of 5 Mbps. Now we are going to talk about the third one. Display the first name, last name, package number, and monthly discount for all customer with monthly discount less than 30. Right? When your monthly discount is less than 30. Okay. So here, what we need to do again, I just want to print all the data we have in customer. Execute that. Okay, it will be customers. Every time I'm writing a misspelled table name and I'm getting error. Wow. Okay, so can you see? We have customer ID, first name, last name, monthly discount will be there, right? That is less than 30, I said. Okay. Whenever your monthly discount is less than 30, I just want that record. How to do that? Just whatever the attribute you want, select first name, last name, package ID, monthly discount from customers where monthly discount is less than 30. Can you see? We got everything. Like Alvin, Juice, Stuart, all of them, monthly discount is 28, 12, 17, 11. Now, if we can make it greater than 30. Can you see there is no records you have that is greater than 30 or greater than is equals to 30? Can you see you have greater than monthly, greater than, or you don't have anything greater than, but you have equals to 30. Herland and Hassel, right? You have 2 records for that. So this is how you can use this 2 operator at a time again, right? Now we are going to look at some few queries again that we are going to do with the using of the same database management system, right? So now here we have a question called display all the data from customer table for all customers who joined the company before January 1st, 2007. So how can you do that, right? So these are the very basic data manipulation by just to do that, to understand this manipulation technique more well, right? So now what we are going to do, they are saying fetch all the data for customer table for the customers who joined the company before January 1st, 2007. So your condition will be, okay, when your join date is equals to 2017-0101, right? This is the format SQL maintains for date, right? So yeah, so you want this like, you know, the employee for this table who joined 1st January 2007. So what you will write? You will write select star. You want all the data information. So select star from customers where join date. Before that, maybe we can again just try to fetch all the data to check what is the joining date and how we have used this customers, right? So here we just need to execute that. Yes, can you see this? And the joining date is this 20120512, right? This is the way of writing the, you know, joining date. Now, as I say, the 1st January, I just want till the 1st January. Only the 1st January. So there is no employee we have, or there is no customers we have whose join date is 2017 1st January, right? So if we go back to here and if we just check that what we have, maybe we have 2012. So if I can write 2012 and maybe 05 and then 12, right? Okay. So let me just check this out. If it's gonna work, then we will understand. Yes, you can see all of them, all the contacts we have, the join date we have is 2012-0512, right? So yes, this is how your where conditions is gonna work, right? Now what we have next, we have display the customer's number, first name, state, city, and package number for all customers, right? But there is a condition whose package number equals to 2828, 2128 or 14. This will get from customer table. So as we have talked about in operator, right? So what you said, hey, I want to get all the data of customer ID, first name, last name, state, city, package ID from customers, where package ID, right? Your package ID in, when you say it in, it will just go for 21, 28 and 14. As we have already mentioned, if you use between, it will start searching for 21 to 18, 18 to 14, right? I mean 14 to 21, 21 to 18. This is how it's gonna work. But as you said in, it will just specifically go for 21, 28 and 14. Again, we have no records for this. If I am gonna write select star from customers, right? I'm gonna write that. Let me just execute this command and let's have a look at what we have. So pack ID, as we talked about, let me just scroll it down here a little bit. Yes, we have 18. We have 31. Okay, so if I write over here 18, and if I write it 31, right? What else we have? We have 13 as well. Let me just check this out. Okay. Now, if we go and execute this command, let's see what is going to give. Oh God, no. Okay. So let me just check what is going to give us. Yes, it's give us the idea. I mean, if you can look at, only 18 is there, 13 is there, 31 is there. Other than that, no contact details or no data is given over here. So when you have used in, so in basically in what will happen, it will give you that particular numeric values or whatever the values you have mentioned, right? So this is how this in works. Like if you start working with this more and if you start exploring new queries, there are lots of sites and we do have lots of courses on SQL. Maybe if you start solving more SQL problems, that time maybe you will getting to understand, okay, these are the operators and how we can manipulate them. How can we use this mix and match as well? I mean, we use two functions at a time for one attribute and we try to figure it out one particular result. So you can understand that using lots of functions and in a same attribute, you can actually manipulate your data as well, right? Now, what we are going to do, we are going to go for display the customer number, first name, state, city, and package number for all customers. Let me just call it down. All customer whose package number is not equals to 2710 or 3. So this is a trick. When we say equals to, when we say not equals to, right? So let's get back to here. Right. Now what we say, same customer ID, first name, state, city, pack ID from customers, right? Where pack ID not in. So we have used not. Now we are using both two together. Not in, right? So if I just go and do the same thing, select star from customers, right? Let me just execute this one to check what are those customers we have. If we go in there, if we scroll down, so we do have 3. No, we don't even have 3. We just have, they say 2710, or maybe I can write 23 just to understand. 23 then 13, right? And then maybe 39 we can use over here. So these are the things we don't want when the pack ID is equals to this. Let me just execute that. Can you see? We only get 18, 31, 7, 1, 42, 37, 7, 34, 27, 31, and so on, but not in 23, 39, and 13, right? So whatever the data we have, 23, 39, and 13, we did not get it, right? So this is how our not in, okay, this is how our not in operators works, right? Now, what we are going to do, we are going to display the last name, main phone number, monthly discount, and package number for all the customers whose customer number equals to 703, 314, or 560. How can you use this 703 or 314 or 560? I mean, when you have 3, okay, and you are saying or, right? I mean, you give 3 options, right? And from there, we need to find it out. we are going to do the same thing. Select last name, main phone number, monthly discount, pack ID from customers where customer ID in where 703314560, right? So basically, when we use not in, when we use in, I hope you understand. When you say, I don't want this 3 particular number or this 4 particular data, I don't want that. That time you need to write not in. When someone's saying, hey, I want this 3 numbers or this 3 data, wherever you have in your data set, please fetch me all the data. That time you need to use in operator, right? Okay. Now we have written select name, main phone number, monthly discount, packet ID from customers, where customer ID in 703314560 and 560. Let me just execute that. I don't have any customers who have this customer ID in, right? Again, let me just select star from customers, right? It will give me all the data every time I am doing that. Okay, I only have customer ID in 20. Okay, so I can say 13. I don't want. I want basically here 21 and maybe, okay, 10. 21 will not work again. So maybe 16. Let me just execute this. What we will get here. Can you see we got only 3 answers? 13, 16 and 10. I can say one more thing. I want to check the customer ID as well. Okay, it's already here. There is no point of writing it. Okay, so just to make sure whatever it comes, it's right. Can you see 10, 13 and 16 we got? Not other one. Yes, this is how our not and in operator works. Now we are going to talk about display the first name and monthly discount for all customers whose first name, it's interesting, first name ends with an E. Oh my God. So we are going to use the pattern matching technique, what we have learned in the part of the section, the like one. So what I said, select first name, monthly discount from customers where first name like, right? What it says ends with. So if your pattern is say, hey, it's gonna end with, so you are not going to give any percentage sign. But if you say there will be somewhere you will have E in the name, so that time you need to use both side percentage sign, because in front of E you will get some data, after E you will get some letters, right? So your pattern will anyway you want E in the any part of the first name, but here it's specified that after E there will be nothing, right? So this is where we have written percentage E. Let me just execute this. Josh, Lawrence and Pasquale's, right? So these are the person we have their names ending with E, right? This is how your pattern matching works. And for pattern matching we use what? We use like, right? For pattern matching we use like command. Now we are going to talk about display the last name and the package number for all customers where, this is again interesting, where the second letter of their last name is D. Again, if you want this data to be second letter, how can you do that? Right? So in that time, you need to write select last name, right? Package ID from customers where last name like underscore. You have to give one for one character, one particular character, you have to give underscore D and then percentage. Why? First there will be something, then D will be your second letter, then you will have percentage. After that, anything can be there, right? Let me just execute that. Can you see we don't have anything? Again, I need to search for what we have and from there I need to find it out. Select star from customers. Let me just check this out. Oh my God, what I have written for from. Okay. Okay, so let's see. Maybe we have E or O or mark. Let me just put it out as A. Let's see what we will get. Can you see? We got lots of data. We got Taylor, Davies, Walker, Watson, Jackson. So can you see? We got what we got. The second letter is A. The first one is underscore. You said, hey, any letter can be there. Then your A, the particular one, the letter you want after that, and then percentage sign. So after all, percentage is basically, after this pattern, anything can be there. I am okay with that. But I want this pattern to have to be there in my results. Right? This is how this like or pattern matching works. Now, okay, we are going to talk about display all the data from customer table for all customer who have the letters L, J or H in their last name. Order the query in the descending order by monthly discount. Oh my God, there are lots of things to do. First, break the query. First, write, select star from customer. You will get all the data where you need to make everything in a small letter. Lower last name. Like, now what you have said, like one, it's L, L percentage, J percentage, H percentage. So whatever the name is contained with L, J and H, right? Then order by, in what order? Order by in a monthly discount order, which is also in a descending order. So for descending, we need to write DESC. So here, if you look at how many we are using where? We are using lower function. We are using like for pattern matching, we are using OR. We are using order by and as well as DESC, right? Let me just execute that. Can you see? We got it. We got that where we have L, we have J, we have H in the last name. And as well as if you look at monthly discount, if we just scroll it down over here, so 17 and then 6. And for others, it's null, right? So this is how our pattern matching with OR, with order by, with lower function, everything works together. This is how you can mix and match all the concepts you have learned so far, and you can just fetch your data from the database. Now we are going to look at the next query where they are going to say, hey, display the first name, join date, monthly discount, and package number for all customers, right? Who don't have the letter A in their last name. Order the query. Okay, so how we can do that? So anyway, if you want to display first name, join date, monthly discount and package number, that is nothing new. But for all the customers where you need to you need to matches the pattern, right? So you need to write, select first name, the next they asking for join date, right? After that, they were asking for monthly discount, right? From there, they ask for package ID. From where? Which table? From customers table. Where they say the last name should not contain A. I mean, anywhere A will not be there, right? That time, if something is saying not, they don't want that. That time you need to use not, right? And with the like pattern, like command, which is pattern matching, right? So what you are going to say? Select first name, join date, monthly discount, package ID from customers, right? Where lower, first you will lower your last name, right? Make them in a small letters. Lower last name, not like, then in the quoted, you need to say percentage. I mean, before A, you can have anything. After A, you can have anything. But A will not be there in the last name, right? So in that case, you need to write percentage A, percentage, right? So you got it, how we do the pattern matching. If it's like the only one letter after a particular letter you want, then you need to write underscore, that letter, and then percentage. If you say, hey, I want this letter, this particular letter to be in the last, after that, nothing will be there. You need to write percentage, then that letter. That's all. After that, nothing will be there. So someone said, I want this particular letter to be in the particular last name, right? A will be there after and before anything can be there. So you need to write percentage, A percentage, right? So this is how this like and pattern matching works. Before execute this query, let me just write select star customers, right? I just want to see how many they have which has the last name. So you can see in the result, Williams is there where A is there in the name. Then we have Davies, we have Evans, we have Thomas, we have any other name? We have Watson, Jackson, right? So this name will not be there when you execute the query, right? Can you see the 12 rows returned before the 20 rows was returning now to 12 rows? Why? The first name is there. Okay, I did not write the last name. Let me just write over here last name. As you can see that, right, the record number of record is less. That means some of the record are being, deleted, or just say, no, you are not for this particular query. Let me just do that. Yes, Smith, Johns, Brown, Wilson, Roberts, Johnson, Lewis, and so on, right? No one has the A in their last name. So this is how this like or pattern matching works. Now what we are going to say, let's see the next query. So they are saying display all the data from customer table for all customers without a package, right? Where package number is null. So basically you need to find it out the null value. How can you do that? Same, select star from customers where package ID is null, right? And don't forget to put the semicolon, okay? Let me just execute this. Nothing, every customer has the value of package ID. Let me just try this out once. Select star from customers. Okay, let me just print it out. Yes, can you see? No, you cannot. Let me just scroll it down. Package ID, everyone has the package ID. So everyone has the package ID. So in that case, you cannot say your package ID is null. So there is no value it's going to return when, as we see, the package ID is already there for all the customers, right? As we can see, there is no customer is without package ID. So we can do one more thing. Just change the query using not. What will happen if we use not? So writing select star from customers where package ID is not null. So it's gonna give you all the result where the package ID is not null. For this case, we will get all the result, but when you have lots of data, if you want to see what are the customers with package ID is not null, they are actually your customer. So in that case, you can use this. Can you see here? Yes, all the package ID is there and it's not null. So this is how our not function works and how this null function works as well. Now we are going to see create a query to display unique month discounts in customer query. Right? So in this case, you want to see the monthly discount in a distinct way or a unique way. Again, you need to use distinct function to see that. Select distinct monthly discount from where? From customers, right? Let me just execute this. Can you see this? All the monthly discounts are there, right? Who are distinct. So if you don't say, hey, I don't want to see distinct, I just want to see all the monthly discounts. Let's see what will happen. So basically it's just to cross check your query is working fine or not. Right? Not all the time you can do that, but as it's a very beginning time, you can do that, right? Okay, again, I did not write the, okay. All are 20 rows are returning because all of them are monthly discounts are, they are not similar to each other, right? So in the first query, they have given us the distinct one. Like if you have so for my case, all the monthly discounts are same, right? Not for same for all the customers. They are different for each of them. But if you have any repeated monthly discount and you will say, hey, I just don't want to see the repeated one. I want to see the distinct, the unique one. So that time you need to use distinct function. Now we are going to talk about the next query. What is it? Let's see. Display the first name concatenated with the last name separated by space, right? And monthly discount for all customer whose monthly discount is not in the range between 20 and 30. Order the query in ascending order by full name customer table. Oh my god, there are lots of things we need to do over here. So let's have a look at first break the query. First, what you need to do, display the first name concatenated with last name separated by space. Which one we are going to use? Again, the concat function. So select concat first name space in the quote, then last name as full name, right? Next, what they said monthly discount for all customers. So I'm gonna say monthly discount from customers, right? Then what they say, whose monthly discount is not in range between 20 and 30. Okay, so what you need to write, where your condition is started, monthly discount, right? Monthly discount not between. So we use between to get something between two range, right? So 10 to 12, 12 to 13, right? So you need to give a start range and the end range. So you said where monthly discount not between 20 and 30. Now they said they want all the result to be in an order by ascending order, right? So if you want to make your result in an ascending order, so you need to use order by, and then they said order by full name. So your full name, right? So as you make this is as full name, the new attribute, right? So in that case, let me just execute that. This is a very easy query if you break this query in a part way. So you can see already there, right? DEGLLM stored, right? And the monthly discount is, you can see, not between 20 and 30. So this is how this query works, right? So first select concat, then first name, then last name, like you can make it as full name, then monthly discount, and then you said, hey, my monthly discount will not be between 20 and 30. So whatever the records you have, not between 20 and 30, return me those in a ascending order by full name, right? So if you look at the full name, you can see the first name, then space the last name. This is how concatenate function works. Right, now we are going to talk about the next query. Display the first name concatenated with last name separated by space. Again, the same thing. The main phone number concatenated with street. Okay, your main phone number will be concatenated with street. Then they will separate it by space. And monthly discount for all customers whose monthly discount is in the range between 11 and 27. Name the column heading full name, contacts, and DC respectively, right? Customer table. What they are asking to do that. First, you need to write, first let's break it. Again, break it. So if you see any query in a very complicated format, there are lots of things you need to do. Why don't you break it? Break it and do one by one, right? If you need to write even two query, use subjoin, use full outer join. But yes, full outer join of any types of join you can use, but first break the query, right? So display the first name concatenated with the last name. The same thing we are going to do. Select contact first name space last name as full name. Then they said contact main phone number space with street number, right? We did it. The both is done. Now what they are saying? Then they are saying then monthly discount for all customers whose monthly discount is in the range between 11 to 27. Name the column heading full name at like the alias already you need to do concat and DC respectively, right? So you said already my phone number and street is concatenated, right? That is known as contacts. Now monthly discounts, right? The monthly discount you have then called as DC. Put it as DC. From customers, right? Where you are going to give the condition monthly discount between 11 and 27. right? Your monthly discount will be between 11 and 27. Let's have a look at what we will get as an answer. Can you see? Full name, Josh and Jones. Contact is there. Then space, then your street, then DC. The monthly discount, the 12.00. So all of them you can see between 11 to 27, not more than less than 11, not more than 27. So this is how our between works, right? Next, jump to the next query. Display all data from customer table for all customers who live in New York and whose monthly discount is in the range between 30 and 40. So you have to have two conditions. One, the state or the city will be New York, right? Then the monthly discount will be between 30 and 40. You need to write, select. You want all the data start from customers and you are going to give two different conditions. One is where lower the city. First you need to lower the city and then check if it's New York. And monthly discount you need to say between 30 and 40. And you want all these records for that. Let me just execute this. Okay, there is no such records we have. Let me just try this one. Yes, if you can look over here, let's have a look at all the city, New York, with monthly discount. Let me just scroll it down. It's 28, right? Not 30 and 40. So let's have a look at what 30 and 40 you have. You only have 230, right? When you have 230, but they are not from New York, right? So why don't you say this is from 20 and 40? Then you will get some of the results. I'm just doing back reverse engineering. But trust me, it's just like I have not have lots of data. If you have lots of data, all the query will match your conditions, right? This is how it works. No, this is also not coming. Okay, why? It was there in the New York. For the case of New York, what is that range? Monthly discount is 28. Yes. New York is there. Okay, first let's do one thing. We just try to make this a condition working out, right? Just write this. Let me just check what are the customers we have in New York, right? Okay, we have written New York. So how can we get that? Okay, let me just try this out. We have Alvin, right? And here if we write the same command, let me just try this out. Yes, we got Alvin. So we have Alvin that if you can look at, the city is New York and the monthly discount is 28, right? So this is how this condition works. So you put that city should be New York and monthly discount between 20 and 40, right? Okay. Now we are going to look at this query. Let's have a look at what this query is saying is here. So they are saying display the package number, speed and sector number for all packages whose sector number equals 1. That you will get from package table. So what do you need to write? Just a normal where clause, right? Select package ID, speed, sector ID from packages where sector ID equals to 1. Right? Before that, let me just print all the record from packages, right? So for that, we need to write select star from packages. Right? Let me just do that. Okay, I have written, okay, PSKAGS. Why it's getting? Okay, no database is selected. Okay. I just need to use internet, right? As you do not use which database you need to work on, that is why it's giving you the error, right? Okay. Now what we are going to do? We were in the 20th one, right? Yes, this one. Now if we write select star from packages, so you can see this is the sector ID you have. You have sector ID 2 as well. So if you just select it and execute this, can you see you got all the result where sector ID is equals to 1 and you got package ID, speed and sector ID, right? Now we are going to look at the next query. The next question we have, display the package number, speed and sector number for all packages with internet speed of 5 Mbps or 10 Mbps. You will get it from package table. So what you need to write? Select packet ID, speed, sector ID from packages, then where you need to make them lower, right? As we know that we don't want to go for the confusion with the lower and the capital part, right? So we make its speed as lower and then we say it is equals to 5 Mbps or lower speed is equals to 10 Mbps. If you look closer, you can see we are going to use OR, right? The OR operator we are going to use over here. So this is how we are actually using all the concepts we have learned so far. We are doing all the query every time. Why we are doing it? Why we are solving this query, right? Because I just want you to be more more with these queries, more practice. If you start practicing this part, right, so you will start understanding how you can start using those concepts. Learning a concepts and like doing this in a proper way and doing the application is total whole different story, right? So in that case, what we need to do, we just need to solve as much query as much possible, right? Now, what we are going to write, select packet ID, speed, sector ID from packages where lower speed is equals to 5 Mbps or lower speed is equals to 10 Mbps. Let me just execute this. Yes, can you see? We got all the speed of 5 and 10 Mbps. So if you are doing the same thing, let's have a look at what are the Mbps we have in our total table, in our total records from, right? From packages. Let me just execute this. Okay, so we have 750 kbps, we have 1.5 Mbps, we have 2.5 and 5, 10, 12, 13. Not 13, 12, till 12. So we are getting repeat. So we are getting only the records which are 5 or 10 Mbps, right? Now what we are going to do? In the next question, we are asking us to display the last name and the monthly deposit for all customers live in Orlando, right? You will get this from customer table. So just write select last name, monthly discount from where? From the customer table where again you need to make lower, or if you want you can make it upper. That time you need to write all the thing in the upper like in the capital word, right? Then just write the city Orlando, right? Now let me just execute this. What are the customers we have for Orlando? No customers we have. So in that case, maybe we can write select star from customers and we will pick a city from there, right? Okay. We have, if I'm not wrong, New York. We have Chicago. So what we have in the table, we have New York. We have California. We have Texas. We have Arizona. So if we write Texas, what will happen? Let me write Texas. Right? Okay. Still it's giving. Okay. Why it's giving me this error? This is just something. I just write the wrong name. Okay, it's calling the city. Oh my god, I can write Chicago. I just make the state. Oh my god, how can I do that? Okay, Right. Can you see? We have the last name Taylor and the monthly discount is null. So this is how we are using where clause, where the Chicago and the city name is Chicago and the last name and the monthly discount of that particular customer is shown. Now what we are going to do, we are going to solve the next query. What they are asking to do. Display the last name and the package number for all customers whose package number equals 9 or 18. Perform the exercise once using in operator, once using or, right? So let's have a look at how we are going to do that, right? So if we write select last name package ID from customer where package ID in. So we have used in so many times. If we just execute this, we have Smith that is 18. Now if we just maintain the same procedure, select star from then where customers, right? Let me just execute this. Yes, you have pack ID. In that case, let me just do that. We have packed ID team 31 7 27 39 and 1. Okay, so in that case, if we write or, right, let me just check what we are going to get here. Okay. Okay, sorry, I just got the error. Let me just do this. Okay, I just need to write it. Okay, so we are going to repeat from the in, right? Okay, so as we can see, we are going to use in operator over here. So in that case, what we are getting? We are getting the only Smith whose packet ID is 18. So if we write something 23, let's have a look at if we have something for 23. If we don't, let's just change the number again. It's just trying to understand whether the data we have in our database. Okay, for 23, we have two. We have Williams, we have Watson, right? So in is basically if we have something between 18 or 23. So that time you will get that result. Now display the first name, main phone number, secondary phone number for all customers without a secondary phone number, right? Secondary phone number is null. So in this case, you need to get all the customer whose secondary phone number is null. What you need to write? Select first name, main phone number, secondary phone number from customers where secondary phone number is null. That's all, right? So in that case, your is null function is gonna work over here. Can you see? So in this case, we have Charlie's, Glenn and Demarcus, right? They have the secondary phone number as null. So you have only three part or the three records who does not have any secondary phone number, right? So this is how you can use that. Now we are going to talk about the 24th one. Display the first name, monthly discount and package ID for all the customers without any monthly discounts. So we need to check if we are display the first name, monthly discount and the package ID for all customers without any monthly discount, right? So your monthly discount will be null. So in that case, what you need to write? Select first name, monthly discount, package ID from customers where monthly discount is null, right? Let me just execute this. What we will get where you don't have any monthly discount. We have all total 4. We have Amado, we have Pat, we have Brain. Pasquale is basically they don't have any monthly discount, right? Now we are going to jump into the string functions for how to solve the query for string functions. Now we are talking about the string functions. So what question we have? Display the customer number, first name in lowercase and last name in uppercase for all customers whose customer number is in the range of 80 and 150. So what we are going to do over here, this is exciting, right? Select customer ID and then you need to do it in the lowercase. Just put lower and first name. Then you need to do it in the uppercase, then upper and last name from customers, where customers ID between 80 and 150, right? Let me just do that. Right, we don't have anything again. So here I am just going to write 1 and 2. right? This question maybe they have a lot of data, but we did not insert a lot of data. It's taking a lot of time. So yes. So you can see for Alvin, the first name is in the lowercase and the last name is Smith is in the uppercase. And the customer ID is 1. When we talk about Josh, that time lower, the first name is in the lowercase and Johnson is the uppercase and customer ID is 2, right? So this is how we can do that. Now let's go and check the next question. Generating email address. Oh my God, how can you generate email address? This is really interesting to do that. So for all customers, display last name, first name and email address. The email address, okay, the email address will be composed from the first letter of the first name, concatenate with 3 first letters of last name, concatenate with string @mail.com, right? For example, Ram Kidam, if you have, then you will get rked@email.com, right? How we are going to do that? Let's look at it. It's not that complicated. If you know all the functions, then you can do that, right? So what we are going to say, we said select first name, then last name, then we are going to do concat. How you can do the concat? We are going to use substring function. So what is substring function? Substring function is basically going to like split your string. So you said substring upper, you want your first name to be in the upper, okay, upper and then 1,1, right? Then what you are going to say? You are going to say substring last name 1,3 as we see it in the first letter. Can you see? Composed from the first letter of first name. So you said it will start from 1, it will go till 1. And then it said of first name and concatenate with 3 letters of last name. So it will start from 1 and it will go till 3. Then comma @mail.com from customers. So this is how we are going to make the email, right? And again, the substring is basically used to take. Okay, let me just make a simple substring for you to understand how substrings works. Select star, not star, select maybe sub str. It already came. What you are going to say, suppose first name you have, then you are going to say from where it will start, comma 1, comma 1. From where? From from customers, right? Let me just execute it. Can you see you got all the first letter? If you write over here 2 or 3, suppose we are going to write 3. Let me execute that. You get all the first 3 letter, okay? If you make it upper, what you will get? Right upper. What you will get? Okay, you will get an, okay, fine, it's giving you a error. But why it's giving the error, right? You need to complete it over here, right? And then just, okay, right, just do that. Okay, then also we are getting, okay. Oh, we need to write one more thing. So first we need to write substring and then upper, right? Sub str, then put the first bracket, then upper, first name and then, right? Then it's going to work. So always remember, first you need to write substring, what substring you want, then which one you want to make it upper. So substring, then upper the first name, then it will go till 1 to 3, first character to third character. Can you see? It's going from first to 3. So this is how it's going to make the @gmail.com or the email for all of them. Alvin Smith, you can see it will take A and SMI. It is taking SMI. Ashmi @mymail.com. Then Josh Jones, it will take J John @mail.com. Then if you see Amado Taylor, it will take ATAY @mail.com. This is how you can start using substring. Substring is basically splitting your all the string or the character. Then concat is basically like concating all the character, right? So this is how you can start using them. Now, if we came to the second one, then for all customers, display the last name, first name and email address. The email address will be, so you can check this one. No, we were there. This one we make. Okay. So for all customers, display the last name, first name and email address, the email address will be what? They are saying something different. Let's see. Composed from the first letter. Okay, I need to just scroll it down. Will be composed from the first letter of first name concatenated with the 3 letters of last name concatenated with the string my@mail.com. We just did it, right? Okay. So here, what they are going to say? They are saying concat substring upper 1 and then you can use this part as well. -3 to 3, right? Why? They are going to say the 3 last letter. This time they were saying the first 3 letter. Now they are saying the last 3 letter, right? Let me use the minus part of the substring, right? Then you will understand how it's gonna work. Let me just execute this part only, okay? So if we write it over here, we just need to write select then this from where? Customers. Let me just execute this. Okay, can you see? Okay, before that, what can we do? We can say last name. Right, let me just execute this. Can you see we have Smith? You will get ITH. How you will get that? So it starts from -3 to 3, right? If you write it's from -4 to 3 or -4 to 4, you will get the last 4 character. Can you see? MITH. This is how you can use the minus, the negative string concepts we have in Python. Like the same way you will do that, right? So what you need to do? -3 to -3. I want the last -3 from customers. So if you just do this, so you can look at, you can see AITH, and the last one, AITH@mail.com, Alvin Smith. Josh Johns, it will be JNES@gmail.com. Then we have Amado Taylor, it will ALOR@gmail.com. This is how we can use substring function for the negative indexing and concatenation function for concat something, right? Now, in this part, we are going to talk about display the last name and the length of the last name for all customers where last name's length is greater than 9 characters. How can you do that? So in that case, we are going to use a new function called length. So we are going to say select last name, length of last name from customers, just to check if whatever the filter we have added or whatever the condition we have added, it's working perfectly or not. From customers where length of last name is greater than 9. Let me just execute this. Can you see? There is nothing. So I can add greater than 2. Right? Okay. Let me just execute this. Can you see? The total name Smith, Johns, okay, we can use still 5. So if we can use 5, okay, say we are going to say, hey, we want, just a second. Let me just execute that. We said, hey, we want a last name, length of the last name is greater than 5, then only show me the last name and the length of the last name. If you can look at Taylor, Williams, Davies, Wilson, Thomas, all the last name is more than 6, more than 5, right? So now if you put more than 6, then more of, few more records will not come because they are equals to 6. Can you see we got only 1, 2, 3, 4, 5 records. So Williams is 8, Roberts is 7, Johnson is 7, Robinson is 8, and Thompson is 8, and Jackson is 7. So this is how we can use the length function. Now in the next query, we are going to see, okay, display the first name, last name, main phone number, and the new phone number using the replace function. In this new phone number, replace all occurrence of 515 with $sign. Okay, that's little tricky. Let's have a look at how can we do that. So they already said you need to use a function called replace function. So you said, hey, I want my first name. I want the person's last name, main phone number, and now we are going to do the replacing part. We are going to use replace function. Now, what do you want to replace? The main phone number. With what part you want to replace? 515, if you have any 515, that will be replaced with $sign as new phone number. Then from where? From customers. Let me just execute this. Yes, can you see, like my new phone number, no one is replaced, right? So if we can say, if you have suppose 52 with $sign, only 2 I want to replace. Let me check if it's gonna work. Can you see, this is already replaced. 52 we have 2352. So Josh is already replaced. 520336 is already $sign 0.336, then $sign 2.50. So this is how we can use replace function to replace something from a particular data, and you can make a new attribute from there, right? And we use as the alias we know, and we give this new column name as for new phone number. If you don't write alias, let's have a look at what you will get. Okay. You will get replace the full name, the replace main phone number with everything. So that is why we use alias to say, hey, I don't want like the full condition I have given. I just want to make a new column, and your new column will be phone number, new phone number. Now, next query we are going to do. Okay, right. In the next query, in the next query, we are going to do display the first name, last name, main phone number, and new phone number using the replace function, right? Using the replace function in the new phone number, replace all prefixes of 515 with $sign. And only if the first 3 digits of the phone number contain the digit 515, replace those digits with $sign. Okay. So what we are going to do? Now we are going to say, hey, select first name, last name, main phone number. Now we are going to use a case. What case? As we learned about case when left. It's going to take the left, right? Why we are going to take the left? If you look at this, you can see phone number using replace function. In the new phone number, replace all prefixes, right? All prefixes of 515. That is why we use left. 515, then replace main phone number 515 with $sign. Else main phone number. Otherwise, main phone number will be main phone number and then end, right? We use end the case as new phone number from customers. So as we know that 515 most probably we will not have, so we can use 52. Let's see what we will get over here, right? Let's see. Let me just execute that, and then we will break the query and I will show you how it's gonna working, right? Do we get anything? No. Fine. So what we need to do, we can do this part, right? Let me just show you how it's going to work. Select, then put this one, right? From customers. Can you see you got this? And if you look at the phone number, so you need to write main phone num, right? So you can see what actually you are getting. I will show you what this left stands for. Can you see 56, 52, 52, 53, 58, right? Then what you have said, if you have, okay, I did not change here. That is why we did not get anything. So now, if you look at this, so left is basically from the left, you will cut it out. Like left from, you said left from where? The column name is main phone number. And how much left? The first 2, right? Let me just execute this. Can you see that Alvin's main phone number is Josh Jones 520.336.8373. That is replaced with $0.336.8373. And the case of next one, Amado Taylor, at 522.501.6331, you will get $2.501.6331. So this is how we are actually combining all the new functions. If you look at this query, what are all combined? we combine case, we combine when, we combine left function, we use replace function, we use as, that alias part, right? So first we have learned about all the functions we have. Then what we did all the demo for that, right? From there, we are solving all the questions and we are using all the concepts together to understand that, okay, this is how you can combine all the concepts. If you ask me why do we need to do that, but there is a difference between, your knowledge and the experience, right? So your knowledge is okay, you know how these things are working, but you don't know how to merge them, how to use them in the proper place, right? So this is why we are solving this part, to understand how you can merge all the concepts, how you can solve the problem using all the concepts you know till now, right? Now we are going to do a numeric function query. How can we do that? Right? So in this case, from customer table, for all customers, display first name, monthly discount after addition of 19.7%, monthly discount after addition of 19.7% expressed as a whole number, that is a round one. Then monthly discount after addition of 19.7% round down to the nearest whole number floor. Then monthly discount after addition of 19.7% round up to the nearest whole number ceiling, right? So if we do that, how can you do that? Select first name from customers. We will do the first one first. Then monthly discount from customers. Select monthly discount from customers. How can you do the discounts part? To select 1.197 into monthly discount from customers. If you do that, can you see? You have all these things. Now, if you want to use a round function, you will get the round, right? So, the same thing you are doing and you say 0. So, basically, you don't want any number after the decimal. Okay. Now, if you want to use floor function, you can use floor, right? The floor function and the same thing. Okay. You can use them. After that, if you want to use ceiling function, you can use the ceiling function as well. Right? So this is how we are using all these functions. And if you want to see all of them together, just use all the function together and select all the functions. Let me do that for you. Okay. If you want to convert these to one particular query, you just need to do one thing, right? This first name first. All right. We are going to take the first name first. Then comma. What do you else want? I want this monthly discount. Let me let me just copy this monthly discount. Now, comma, what else you want? Why you want this part? 1.19 cent monthly discount. Let me do that. Okay, I can do that. Now, I want this round part. You can actually then tally all the numbers together. Okay. Now round is done, then floor. We want to take the floor part. Then we are going to take what? We are going to take the last one, the ceiling part. Let me just completely copy this. Can you see? We got all of them together. Yes, this is how we are first breaking all of them, and then if you want, you can You can actually make them in a one particular query. So you can say for Alvin, monthly discount is 28, then 1.197 into monthly discount is 33.5, then round it will be 4, then floor monthly will be 33, right? And ceiling will be again 34. So this is how we can use them. Now we are going to talk about the next query. What we have now, we are going to work with the date function. How can we work with the date function? So the query is from customer table for all customers, display the first name, join date minus 10 days, join date plus 1 month, and the date difference between join date and the current date. How we can do that? So first, let me just execute the table details, the all data we have. For that, we need to write select start the basic query from where the customers table. Right? Let me just execute that. Yes. So now what we are going to say, as you see, first name is there. join date is there, right? So you first need to write first name, join date, then you need to write date add, right? The date add function we have, then we need to say join date, from where you need to add from join date interval minus 10 days, right? As we said, the join date minus 10 days. Then the second one was date add, then join date interval 1 month. Okay. Then date difference, so current date and the join date, right? So first we will do that, and then we will use a what? We will use a alias for this, right? Let me just do that. Can you see Alvin, the join date 2012 5/12, and yes, the add date, the interval of minus 10 days will be 0 to 05. So May 2nd May 2012. This is May June 12 June 2012, and the difference is 3061. Within a days we will get this, right? So if you add as alias as you can say 10 days less, or you can write as 1 month added, or here you can say add as difference. All right. Okay, I am getting one error. So, okay. Few days left. You cannot put, okay, I can say 10 days less. Right. And if I'm not wrong, to put this. Right. Okay. Now I can write 1 month added, right? Yes, this is as difference. Let me just execute this. Can you see 10 days less, 1 month added difference? Before we used to get all the what? All the condition we have given, that will be your column name. So I said, no, my attribute name will be the name I want to give. So that is 10 days less, 1 month added, or difference. That is from customers. Now we are going to use the next one. What? So if you look at this query, we are using two particular functions. One is date add, one is date difference. So these two functions can be used when we talk about if you want to say, hey, I want 10 days lease or 20 days lease. And if you want to say, okay, interval of 1 month, interval of 2 months, you can use date add. Now comes the date difference. So this is basically will give you the difference of date, like from the current date to the join date, right? Now we will go for the next query, that display the first name, birth date, and age for all customer who is older than 50, right? What do you need to do? We are going to say select first name, birthday, round. We are going to do the round, date difference of current date, comma, birth date. So you want the date difference from current date and birth date, right? Divided by 365. Okay, so you will get the age, okay, as age from customers where date difference of current date and birth days is greater than 50 into 365, right? So how will we do that? First, let me just do the first part. You will understand what we are doing, right? We write it over here and put the semicolon. So if you use that, what you will get? You will get the age. Can you see 58, 53? How actually we are getting this? For date difference, you are giving current date. It's going to take, okay, this is today's current date. From there, it's going to take the birth date. The birth date you gave, right? So it will give you the difference in date. As we see the difference in date, if we divide that into 365, we will get the years, right? And we make it as round because we don't want is a point, the float, or the decimal number. And we say it as age. Now, if you look at here, you can see we have written the date difference, right? 50 into 365, which as you can get in the day, we said if it's greater than 50 into 365, then only gives us the data. So as we can see, Alvin, Josh, Amado will come, right? Let me just execute this part. I hope you understand how this date manipulation is working. Right. Let me execute that. Yes, you can see Alvin 58, Josh is 53, Amado is 55, Mark is 50, right? Merlin is 59 and so on, 51, 60, 58. So this is how we can manipulate the date function. Now we are going to talk about the display all the data from customers table for all customers whose birthday is today. Okay, so if the birthday is today, then just send me all the details. How we can do that? We need to write select star from customers where month of birthday is equals to month of current date, right? And day of birthday is equals to day of current date. This is how you can understand if that particular customers, right? If that particular customers whose birthday is today or not. As you can see, we do not have any customers whose birthday is today, right? So for the current date, we use current date function. If you want to get the month from the date, you need to use month. If you need to use date from the date, you need to use day, right? So maybe we can say not the and part. Maybe we can see here. Let's see if we have anyone whose month is today's month, not the day. So basically when we go for the day, it will see if there is, okay. So Mark is there, right? Uska like birthday is 09, right? September. So as we are working with the September, you can see September, the mark is there. But if you put this particular part, you will not get the answer because the today is the day of any customers or the birthday of any customers is not today. Right. So this is how we use. You just, if you can see, if you want to get the month, you need to use month function and then you need to provide the column. Right. And if you want to get the month of the current date, you need to use again month and current date function. And if you want to get the day, you need to use day and birth date and day and current days, right? Now we are going further for the next query. Display the first name, join date and the difference in years between join date and the current date for all customers where today have passed exactly 5 years since they joined the company. Okay. So as you can see, they said current. So you need to use current date function again. Select first name, birth date, that you are going to say do the round of date difference, current date and join date from customers where date different, current date, join date equals to 5 into 365. As they say that exactly 5 years, that is equals to. Here, if I'm not wrong, you will not get any data. Right? Maybe we can say greater than. Maybe we will see some of this data for that. Okay. So if you look at here, you can see that select first name and birth date is okay. Now you are rounding date difference. How? So current date is today's date, comma, join date, the join date you have that you will get in a days, now divided by 365, 0 from customers. Now you said where date difference of current date, join date is greater than what? 5 into 365. Then you will get all of them in a what? In a days format, right? So this is how this works. If you look at this, okay, you can make this as, I don't like to see all these conditions. So I always prefer to go for alias giving a particular name for a particular attribute as anniversary, work, experience, maybe. Not work experience, sorry. This is internet, right? So it will be experienced customer, right? Okay. Let me just add that. Yes. Now I am going to execute the same query again. So your experienced customer is 8 years, right? No one is less than, is anyone is less than 5 years? Okay. If I said greater than 5 years, now I'm gonna say less than 5 years. Let me execute this. No one is less than 5 years. Okay. So all are very experienced and past customers they have. Now we are going to use conversion function. How this conversion function works. Display the first name concatenated with the table with the join date, last name concatenated with the monthly discount for all customers. Solve this exercise using cast function. Okay, now we will see how this cast function works. Right, now we are going to use concat, the first name, comma, then space, cast, join date as char. Concat, last name, then cast, monthly discount as char from customers. Let's see what we will get. Can you see? We got it as Smith 28.00. As you can see, name concatenated the join date and the last name concatenated the monthly discount. Right? So here, if you can do this cast function, it is like basically converting your join from date to character. That is why I use cast function. And this cast function is known as conversion function as well. So if you look at it, then you can see select concat first name, and then there will be the space, then cast, join date as char, concat, last name, comma. Again, there will be a space of cast, monthly discount as char from customers. What we will get? We will get the first name Alvin with the join date, then last name Smith with the monthly discount. So this is how it's gonna work. Now, what we are going to do? We are going to the next query. Let's see what we will have. From customer table, for all customers whose last name start with A, D or K, display last name. As we know how to do that, we are going to say select last name from customers where you need to make them in lower and then you need to slice it, right? What we will use for lower, to make them lower in a like small letters, we need to use lower function. Then we are going to use substring function to slice them. For slicing them, we are going to use substring. Then what you need to slice? The last name. Then how much you want to slice? The 1, right? So it's like start with ADK, the first one in where A, comma D, comma K, right? So let's have a look at how it's gonna work. So you can see the time works, right? We are doing what? We are actually making the thing more, complicated, and we are using combinations of functions. So if we write over here, select star from customers. As you can see, what we have, they are saying only Davies, right? Let me just check as well. Okay, I need to write customers. Okay, Smith is there, Johns is there, Williams is there, Brown is there, Davies, Evans, Wilson, Thomas, but ADK is very less. If we write W, what will happen then? Maybe we will get few more data. Yes, we got Williams, Davis, Wilson, Walker, Wood, White, Watson, Wright. We have lots of W, right? So first, what you are doing, we are making it lower, as there will be no problem for, if it's your word is capital letter or is in a lower letter. Then you are using substring function to slice your data. Yes, so we were using substring function. Then in the substring function, you said what you want to slice? You want to slice the last name. Then you said how much you want to slice? 1, 1. And then you are checking that if there is there in, we are using in to check in a list of words, then A, D, K, W. If they are matching with any of the alphabet, then it will give you the result. Right? Now, what we are going to do, the second one, state in uppercase concatenated with customer number. Right. How to do that? Select concat. Now we need to do uppercase. You need to write upper. What you need to upper? Make the capital. You need to upper the capital. You need to make the capital at its state. Then convert customer ID, comma. How to convert? What to convert? Char. From customers where lower substring last name 1, 1 in ADK. Right? Okay. So first, these are the two. These are the two conditions you have. Let me just execute this. You have ARI, maybe here I can write W as well. Right. Let me just add that. Now, how to do that? We just need to do one thing. Right. You have an SQL syntax error. Okay. Right. Let's see what we are having a problem, right? Let me just execute this. Maybe I make this W in a capital one. That is why we are getting the error. Yes, right. So again, when you are saying lower and you give it itself W, it's going to give you the error, right? Okay. How to do that? So you can see concat upper state, right? So state, it takes us, right? Convert customer ID as cat 4 from customers, well, substring, the last condition we have used, right? This is the combination of two conditions. So first one is I want the customers with the last name starts with ADKW. Then what they said, if you get those customers, then please concat their upper state and with the customer ID. Right. So in this case, I am going to concat upper. We are going to use three functions over here. One is concat, one is upper, one is convert. Right. Concat to concat all the things, upper to make them capital, convert to converting customer ID into character. Right. This is how we are going to do that. And you can see we got this, right, for all of them. One for California 8, one for California 13, one is Texas 15, one is Texas 18, right? Now, the third one is join date concatenated with birthday. Solve this exercise using convert, and in the where clause, instead of using like, try to define filtering condition using substring. Okay, let's see how we can do that. So again, the same thing we are going to do. Now we are going to concat join date and convert birth date to date, right? Let me add W as well. Right, so we are going to concat join date with the birth date, right? So let's have a look at how to do that. Can you see it's already there? So what you will get, maybe you can add one. It's just not written in the question, but maybe it's like, maybe you will understand more easily how to do that. So you can see we first got the join date, then the birth date, right? So this is how we will first get join date and birth date. From customers, again, this will be your condition that lower substring last name and sassing the last name, and then we will see it is in between A, D, K, W or not. Then you will get the answer, right? So these are the three types of questions we have solved for one particular condition. Now we are going to talk about null related function or phone number report. Display the first name, last name, birthday, main phone number, and secondary phone number for all customers whose package number equals to 27. Replace every null value in main phone number or in secondary phone number with any. Right? So what you need to write? Select first name, right? Last name, birth date, coalescing, right? What is this? This we need to understand. Right? So how we are going to use coalescing? So basically what you need to do, maybe we are going to take, and when we took it and when actually we don't need to use it. So that time we can see that. Now we are going to use coalesce. How to do that? Select first name, last name, birthday, and maybe I will show you differently why we are using it. Right? We need to write, coalesce, then this is the same thing we are going to use it, right? I am not going to change it, right? How to do that? Control C, and I need to copy paste. Okay. From customers, right? Let me just execute that. Can you see if there is any value, right? Yes. Can you see? This is actually saying birthday, main phone number is set for all customers whose number equals to 27. Replace any null value. Replace every null value in main phone number or in secondary phone number with any. So basically what is going to do, if there is any null values will be there, then that will be replaced with the what? Any value. Right? The null will not come. Any value will come, right? Let me just try this if there is anything in the secondary one or not. right? So this is why we use null values, like coalesce, right? This is why we use. Let me just execute this. Yes, can you see this NA and this NA? Because we have few null values over here, right? And this is why we are saying, okay, we have few null values, and that's why I want this to be like this. And you say pack ID equals to 27. So if it's a pack ID equals to 27, that time only, right? Let me just add this as well as the outcome. So I want to see if the pack ID equals to 27, so then you need to use this function to replace all the null values with any, right? Can you see pack ID equals to 27? And I said, hey, I just want to replace all the main phone number or the secondary phone number if it's null with any. Now we are going to see this next one, right? How we can do that? They are saying display the first name, last name, birth date, main phone number, secondary phone number for all customers who was born in 1972. Replace every null value in main phone number or in secondary phone number with any, right? How to do that? Okay, how can we do that? Select first name, last name, birth date, coalesce, main phone number, which will replace by any. If there is any null value will be there, then coalesce secondary phone number, and again that will be replaced by any if there is any null value from customers where birthday equals to 1972, right? Let me just execute that. No, there is no such cases where birth date equals to 1972. So maybe we can write select star from customers. So here maybe we can check. So basically the condition you will get when you have a lots of data, right? So in this case, maybe the data is less. That is why we were not getting the answer, right? Yes. So when we write birth date is equals to 1962, we got 2, Alvin Smith and Merlin Evans. Okay. So, but there is no null value in their birth date. So if we see, is there any null value for, yes, that is 1971, right? 1971. So if we write over here 1971, maybe we will get something which will need a null value for main or secondary phone number. Yes, for 1971, Demarcus Brown, 1971, 1202, and the coalesce is 584. The main phone number is there. For the secondary phone number, it becomes any, right? So this is how we do that. Now we will see some case function, how case works. From the customer table, for all customer, display the first name, last name, monthly discount, and the discount grade based on these conditions. If the discount is between 0 to 10, discount grade level is A. If the discount between 11 to 20, then the discount grade level is B. And if the discount is between 21 and 30, discount grade level is C. For any other value, discount grade level is D, right? So here how to do that? So what we need to have, select first name, last name, monthly discount. Now we are going to use case when monthly discount between 0 to 10, then A. When monthly discount between 11 and 20, then B. Else C end as discount grade. So the attribute name will be discount grade from customers. Let me just execute this part. Okay. Okay. I just need to check this. Right. Let me just execute this. Yes. Can you see? For Alvin, it is discount C. For Josh, it is, yes, sorry. For Josh, it is B. For Amado, it is C. For Elroy, it is A. Right? So this is how we use our case concept. When we have lots of, conditions and we try to put them in an order or in a particular attribute using some conditions, that time you need to go for using case. And case is basically just like, when and between and then, right? We are using when function, we are using between over here and then. right? So we are using lots of function in one particular query where we are writing, right? Now what we are going for? Now we are going for join. So we will first start with inner join, right? So what they are saying, customers and internet packages, that customer and internet package we are going to use, write a query to display first name, last name, package number and internet speed for all customers, right? So first what we need to do, we just need to have a look at select star from where? From customers, right? Yes, let me just execute that. So basically we are going to print both the table. Then we will try to find out what are the new attributes we need to join. So for the customer, you will get first name, last name. That's all you will get. But if you need packet ID and speed, you need to have another table. So select star from packages. The table name was packages, right? Let me execute this. Yes, so for the table packages, you will get package ID and speed. So when you have package ID and speed, and what will be your, foreign key? So as we have packet ID in customers and we have packet ID in packages as well, we can say, hey, packet ID can be our, like you can say it's a foreign key, right? So what we need to do in that case, we are going to say select C dot first name. Why? For customer table, we are giving a alias, customer alias, that will be C. So basically it will help you to understand, okay, you want first name from customers. So C dot first name, C dot last name. But although in this table, there is no, contradictory or no repeating first name. So as you have customers in first name, but for the packet you don't have. But some of the cases, maybe both of the table you have the same column. So you just want to specify from which table you want which column. That is why we use this alias, right? So C dot first name, then C dot last name. So you want first name for customer table, last name for customer table again, packet ID from packages table, speed from packages table as well. Now we are going to write from customer C. So basically you are saying, hey, I have used C, that will be the alias of customer table. So from customer C, inner join packages P, right? So you are saying the packages table will have P on C dot packet ID equals to P dot packet ID, right? Your foreign key, like the way you need to join the table. Okay, so you can see you got first name, last name, packet ID and speed. So this is the way this whole joins works, and we know the inner join is basically when you have both the table have the common data, right? So that time you have to do the inner join, right? Okay. So here, as we have done the inner join, you can see we got packet ID, speed, first name and last name in a tabular format, but all the attributes are not from only one table. So we already talked about what is inner join and how this is going to work, right? Yes. So they are working perfectly. So in the table you got first name, last name, packet ID and speed. Now we are going to talk about the next query. Write a query to display the first name, last name, package number and internet speed for all customers whose package number equals to 22 or 27. Order the query in ascending order by last name, right? How to do that? So here you can see we are going to use what, right? We are going to use C dot first name, C dot last name, C dot packet ID, then P dot speed. As we know, packages has the speed column, then from customers, right? From customer C, join packages P on C dot packet ID is equals to P dot packet ID. This is the foreign key to join two table, where we are going to use a condition that C dot packet ID, the customer's packet ID in 22, 27 ordered by C dot last name, right? So what we have done, so package ID should be in 22 to 27 and this will be ordered by the last name. Let me just execute this, and maybe after that we will break the query and we will do separately as well. So if we just take this part, right, what we will get? Let me just do one by one, right? Okay. Now, if we don't use the condition, we see we want first name, last name, packet ID, and we want the packet speed from customers and packages that will be equals to this. So you got first name, last name, packet ID, speed, right? Now you said if the packet ID in 22 and 27, then only give me an order by. Why do we use order by? To make our order in a sorted manner, in ascending or a descending. As we did not mention, it's a default, it will be a ascending order. So you can see we got Lino and Pascal, Jackson, Lewis, packet ID equals to 27 and speed equals to 2.5 Mbps. Right, so this is how you can use join as well as a different type of condition to filter your data, to fetch your data according to your uses. Right, now what we need to do, there is a next query we have, internet packages and sectors, right? So now we say display the package number, internet speed, monthly payment and sector name for all packages. Select p.packetid, p.speed, p.monthly payment, s.sector name, right? From packages P, join sector S, right? Okay, before that, again, just have the question again, display the package number, internet speed, monthly payment and sector name for all the packages. So package number you will get from package table, internet speed you will get from package table, monthly payment and sector name you will get from sector ID, right? Monthly payment also will get from package, but sector name you will get from sector table. So how to do that? Select p.packetid. So you say packet ID is from package table, p.speed. So basically the speed is from package table, p.monthly payment. So monthly payment is from again package table, s.sector name, right? Your sector name will be from s, that will be your sector table. So from packages P, you say, hey, my alias for packages of P, join sectors s, like your table will be sector and s on p.sector id is equals to s.sector id. Let me just execute this one. Can you see? You get all the data from here. You got packet ID, speed, monthly payment and sector name. Packet ID 1, 2, 3, 4, 5, 6, 7, 8, speed 750, monthly payment you got and sector name, private or business or whatever it is. Alright, so this is how you join two table. One is packages and second one is sector. Now let's move on to the next question. Display the customer name, packages, package number, internet speed, monthly payment and sector name for all customers. Package and sectors table. You will get this from customer packages and sector table. Let's see how we can actually connect three table at a time. You say contact, select contact c dot first name, comma c dot last name. You want that as your full name, as customer name, right? Then p dot package ID, p dot speed, p dot monthly payment. You will get all these things from packages. Then sector name is s dot sector name from customer C. Join packages P, right? How? On p c dot packet ID equals to p dot packet ID. Then again you want to join sector, so you say join sector S on p dot sector ID equals to s dot sector ID. So you can join three table at a time as well. Can you see? You got all of them. You got Alvin, packet ID, speed, monthly payment and sector name, right? And Josh, it's basically packet ID is 31, whereas the speed is 5 Mbps, monthly speed is 109 and sector name is private. You got all the data from three different tables. Now we will look into the next query. What we will have? Display the customer name, package number, internet speed, monthly payment and sector name for all customers in the business sector. That you will get from customers, package and sector table. Again, you need to write, if someone saying the customer name, that time you need to give the first name and the last name both. So automatically you need to use the concat function c dot first name, comma, space, c dot last name as customer name. Then you have written p dot packet ID. You will get packet ID, speed and monthly payment from packages table. Then s dot sector name and from customers join packages speed. So your customer C is basically the alias of C, then join packages P on C.packID is equals to P.packID. This will be your foreign key. Now, as you want to join sector with packages, then you say sector is on P.sector ID is equals to A.sector ID. So, okay, you have said, okay, if the person is from the sector is business, then please, I want all the record then only, right? So your condition is that. So you make them lower and then you have written sector name equals to business. Let me just execute that. Yes, you can, you got Alvin, Amado, Mark, Elroy, lots of people, right? Who are the business sector name is business and you got their customer name, package ID, speed and monthly payment. Now let's forward to the next question. Display the last name, first name, join date, package number, internet speed and sector name for all customers in the private sector who joined the company in the year 2006. How to do that? Right, select C.last name which is from customer table, C.first name which is from customer table again, C.join date which is from again customer table, P.packet ID, packet ID is from packages, P.speed, that speed is from package speeds, package table, then S.sector name, your sector name from customer C, write your customer C, join packages P, right? On C.packet ID equals to P.packet ID. So your foreign key will be packet ID, as we know that customers and packet ID can be merged using, join using packet ID, right? Yes, right, we have into this one, right? Okay. But when we do that, like yes. So as you can see over here, the sector name for all customers in the private sector who joined the company, who joined the company in the year 2006. So you can see we have again joined two more table. We are going to join three table at a time, the sector, packages and the customers one, where we say C.join date equals 2006 and lower S.sector name equals to private. If you view closure, you can see we are using join date from customers and we are using sector name from sector table. So we are using two different attributes from two different table and we are putting two different conditions. So if you want to give two different condition for two different attribute which are from different table, that time you need to call the alias, right? So the sector name is coming from sector table and join date is coming from customer table. There is no such records for that. Maybe we can use this as 2012 as per I remember. Yes, so, like all of them are from most probably from 2012, right? Yes. So you can see this 2012 and the sector name is private, right? So this is how you can start using different type of joins, different type of attributes from different type of tables and different type of condition you are going to give, right? Now we are going to use non-equi join. What is that? Display the package number, internet speed, monthly payment and package grade for all the packages, right? Package and package grade tables. So what you need to do? Select P.packet ID, P.speed, P.monthly payment, G.grade name. So G is basically your packet grades. So you say G.grade name from packages P, join package grade, pack grades G. Only on P.monthly payment between G.mean price and G.max price, right? How to do that? Can you see you got it? The package name, grade name, package ID, speed, monthly payment, right? Yes. So this is how you can use a non-equi join and you can fetch different attributes from different tables as well. Right. Now we are going to use outer join. How outer join works? So here we are going to use customers and internet packages. So we are saying, hey, display the first name, last name, internet speed and monthly payment for all customers. Use inner join to solve this exercise. How to do that? Select C.first name, C.last name. Again, speed is from packages, P.speed, P.monthly payment. Then from customer C, then you are saying, hey, I want an inner join from packages P. Packet ID will be your foreign key, right? Let me execute that. Can you see you got it? That first name, last name, speed, and monthly speed. So you got your first name, last name, speed, and monthly payment, right? Okay. So now we will go for the next question. Modify the last query to display all customers, including those without any internet package. Okay. How to do that? So your customer will be your whole one. Okay. And from the packages you want who has the packages, right? So you say select C dot first name, C dot last name, P dot speed, P dot monthly payment. From customer C, left join packages P on the way we actually the relation, right? You can see we got the output of first name, last name, speed, and monthly payment, right? So it's saying modify last query to display the all customers, including those without any internet packages, right? Okay. Now what we are going to do, we are going to use the next one. Next question is modify the last query to display all packages, including those without any customers, right? So we just try to understand that who does not have customers, right? So in this case, you need to use right join. Okay, as we know, right join means we will get all the data from right table and the matching data from the left table. Right? So you say it's C dot first name, C dot last name, P dot speed, P dot monthly payment. Then customer C, you will get the matching data from customer table, right? Join packages. So for packages, you will get all the packages details. And for the primary, for the foreign key, you will have C dot packet ID dot P dot pack ID. Can you see you got the customer's details, but who are matching with the packet ID, right? Can you see? Yes, this is how our right join works. Now we will see the next question. Modify the last query to display all packages and all customers. So you want all from everyone, every table. So it will be like an outer join. Or you can use union as well. Okay, how to do that? So select C dot first name, C dot last name, P dot speed, P dot monthly payment from customer C. Then you are saying left join this one, the first one, like the first way we did. Then you said, hey, I want a union. Then select C dot because after MySQL certain version, we cannot use, outer join keyword. We need to use union. So we said select C dot first name, comma C dot last name. We are going to use P dot speed, P dot monthly payment from customer C, right join. So basically you are taking left join as well as right join. So you are taking the full outer join, right? Can you see? You got all the data, you got all the customer as well as all the packet ID as well. Yes, this is how we do our outer join. Now we are going to do cell join. As we know what is cell join, I am not going to repeat what is cell join. So basically join between one table only. There will be no other table. What they say, display the last name, first name and package number for all customers who have the same package number as customer name as Amado Taylor customer table. Right? What you need to do? You said, hi, I just need to have select C1 dot last name, C1 dot first name, C1 dot packet ID from customer C1, join customer C2 on C1 dot packet ID equals to C2 dot packet ID. Why? You have only one table, but you have two different LRs. Right? Now what you have said? Now you said where lower concat C2 dot first name, comma, space C2 dot last name equals to Amado Taylor. And lower concat C1 dot first name, comma, space C1 dot last name, that is again the Amado Taylor, right? Let me just execute this. You just get Roberts and Rudolph packet ID 7, right? So this is how our cell join works. Now we will do the last query on this project, and maybe after that we will go for a new project. And on the last in the section, we will do the how can you connect SQL with Python as well. So display the last name, first name, monthly discount for all customers whose monthly discount is lower than the monthly discount of employee number of 103. How to do that? Select distinct. Distinct we use basically for what? We use distinct for getting the unique data. Select distinct C1 dot last name, C1 dot first name, C1 dot monthly discount from customer C1, join customer C2. This is a self join. C1 dot monthly discount less than C2 dot monthly discount and C2 dot customer ID equals to 9. Right? Let me execute this. Yes, you got all the data, which actually going to match with your conditions. Right, so we almost came to the end of this particular, project, how to make a broadband connection management. Later in the section, let's see, and let's go back to presentation. Let's have a look at what new project we are having, and we are going to implement that too in MySQL Workbench.
Having completed the Broadband Database Management System project using MySQL, where you managed and analyzed broadband service data, it's time to advance to an exciting new area, that is generative AI in SQL. This next step will involve integrating SQL with generative AI techniques, allowing you to leverage AI capabilities to enhance data analysis, automate tasks, and generate insights. By the end, you will have a deeper understanding of how to implement AI-driven functionalities within your SQL queries. Generative AI has taken over in most of the fields and domains, be it programming languages, content writing, etc. SQL is not different. Generative AI in SQL is an innovative approach of use of technology that integrates artificial intelligence to enhance and automate various aspects of SQL queries and database management. This advanced AI can understand the context of your data and queries, providing intelligent suggestions, automating routine tasks, and predicting potential issues. Next, we will see how generative AI simplifies the database work. The very first factor is automating routine tasks. So, in this particular factor, what happens is that it can write SQL queries based on natural language descriptions, saving your time and reducing errors. So here, you need not sit and write these SQL queries by your own. In plain English, if you give whatever you want to write in the query, that will be converted into your actual query. That is how we can reduce the errors. The second factor is optimizing queries. So AI can suggest or automatically apply optimizations to improve query performance. So there is this option called optimizing queries, where your queries will be optimized automatically and it will improve the performance. So the next one is predictive maintenance. It can predict potential database issues before they become crucial, allowing for proactive management. So the issues with the SQL queries can be analyzed in prior and that can be rectified by this predictive maintenance. Therefore, it allows for proactive management. Imagine you are managing a large e-commerce database and you need to generate a report showing the total sales for each product category over the last month. Traditionally, you would write a complex SQL query for this task. With generative AI, you can simply describe what you need in plain English. Generate a report showing total sales for each product category for the last month. The AI processes this request and converts it into an optimized SQL query. This query is then executed and you receive your report without having to write a single line of SQL code. Benefits of generative AI in SQL. 1. Efficiency. Speeds up the query writing process. 2. Accuracy. Reduces the risk of errors in SQL syntax. 3. Proactive management. Helps in maintaining database health with predictive analytics. Generative AI in SQL is a powerful tool that enhances productivity and accuracy, making database management more accessible and efficient. By leveraging this technology, you can focus on more strategic tasks while AI handles the repetitive and complex aspects of SQL querying. After exploring the innovative capabilities of generative AI in SQL, we will now turn our attention to GitHub Copilot for SQL. Are you interested to know more about GenAI and GitHub Copilot? Then do subscribe to our channel and you will find more videos on these. GitHub Copilot is an AI-powered code assistant that can help you write SQL queries more efficiently by providing intelligent code suggestions. This tool can significantly speed up your workflow and enhance your coding experience.
You need to understand exactly what GitHub is to understand GitHub Copilot. Before understanding GitHub, you need to understand what is Git. Because, GitHub is based on the foundation of Git concepts. So Git stands for Global Information Tracker. So Git was initially developed to do version control system, and it's a distributed architecture. Version control system meaning, suppose you have developed a software or a project. Now that was the initial version. Now you did some updation, some functionalities were added or maybe removed, and the next version of the software is created. So somewhere the older version should also be stored, right? Should be worked upon, and then the newer version should be installed. So how or where you can do all these? Git provides that platform. Okay, so it's a distributed version control system where you can keep your code, that is, you can store your code, you can manage it, you can modify it, update it, and release the newer version of it. Initially, Git was created by Linus Torvalds, the creator of Linux operating system kernel as well, and this was founded in 2005. Now, I'll talk about some functionalities of Git. These functionalities are also carried forward to the GitHub concepts. That's why it's important to understand this here as well. So Git has a distributed architecture. It means what? So there is an architecture where, it's called centralized architecture, where suppose you've written a software code and it is stored at one place, you are able to access it on day-to-day basis. But distributed architecture meaning it is stored at a place, but every developer's machine or a laptop is able to access it or keep it, a copy of it on their own laptop as well. Okay, so that's your distributed architecture provided by Git. Second, it helps you run a parallel version. Now, suppose that 2-3 developers are working on the same piece of code, or same software or project, and they're using Git to store that software or a project. All 3 developers can run or do the modification of that code in their local machine and keep on doing the updations parallelly. So the same code will have 3 different versions on 3 different developers' computer. Parallelly, it is maintaining all these versions so that the 3 developers can work independently on their machine for the same piece of code. Next, it maintains history. So all the metadata related to, modification or updation of a code, like who updated the code, what was the changes done, when was it done, all these metadata is also being maintained on Git platform. That's what it is, that maintains history. Next is collaboration and conflict resolution. So how is this, doing conflict resolution? So same piece of code, as I said in an example, that 3 developers are, accessing it and updating it, right? Now, suppose all 3 did the modification in the exact same piece of code. Which code will be stored back, in the original copy? How to resolve this conflict is also handled by Git. There are different logics behind which is used to take care of all these conflict resolution things. Next, coming to performance-wise, Git is fast and secure. I said fast because, it provides, person to access it on their own machine, and that's how, it is faster. And Git is faster because it can handle even large code base. Even if your code file is very large, you can efficiently handle it. And it's also secure. It's open source, means it is freely available. So not just, GitHub is Git is freely accessible, but also you can access the code or manage your project freely. There is no subscription charges as such. Then integration. Git can be integrated with various IDEs. It can be integrated with various online platforms like GitHub. So here GitHub comes in picture. So GitHub is an online platform, or I can say a web-based platform for Git. So all these functionalities which I just now listed down for Git is applicable to GitHub as well. And apart from this, GitHub offers some more functionality, some more features, as it is a web-based platform, and it provides version control for various systems. Now, coming to what is GitHub Copilot. So you got an idea what is Git, what is GitHub. Talking about GitHub Copilot now. So as GitHub, a web-based, version control system, which was already allowing you to store your projects, your software codes, basically, and access them also freely. So associating, Copilot with GitHub would have been beneficial, because a lot of training data is freely available. When I say freely, it is open source. It is freely available to train the model. So as I said, GitHub Copilot is an AI developer tool. So it is an artificial intelligence based developer tool. So the programmers, the software coders, or the developers are going to use this GitHub Copilot to write down a code to create a software. It is based on generative AI model, which I spoke about, and it is developed by GitHub, OpenAI, and Microsoft. As I said, initially it was founded by GitHub and OpenAI, but as Microsoft is one of the investors here, the name is associated in the founders. Okay. Talking about some of the features of GitHub Copilot, the first one is it provides sharp and intelligent code suggestion. Meaning, when you use GitHub Copilot, the moment you start writing code, it will help you to, suggest you the next line of code or the next few words of that code. For example, suppose you're writing a for loop. Okay. So for loop, if you write just the for keyword, it will automatically give you the brackets, the what has to be written inside that bracket, those curly brackets and everything. Now this example, I've taken it from Java. If it is a Python code, it will suggest you accordingly. Or it is any programming language code, it will suggest you accordingly. Okay. Next feature is it auto completes the code. Now, why the software developers are loving this GitHub Copilot? Because for talking about, Java programming language, like I am a Java programmer. So when it comes to Java programming, there are so many, syntaxes which has to be keep in mind. That is semicolons, the curly brackets, the round brackets. So where curly brackets will be there, where round brackets will be there. Should I put a semicolon at the end of for loop, or should I put it after curly brackets? There is no semicolon required. So these kind of lot of small things are there which has to be kept in mind. I'm very sure that other programming languages are also having these kind of syntaxes which has to be learned. But if you're using GitHub Copilot, you need not learn those, or you need not Google every time after writing a single piece of code. Because GitHub Copilot will automatically complete your code with the right syntax of the same programming language in which you are developing your software or writing a program. It codes faster. Now, why does it code faster? Because as I said, if you're writing just the first few words of the program or first few keywords of the programming language, it is going to suggest you what should be the next few lines, and you just have to press tab or enter, and it will write down the code in a fraction of a second. So that's the reason it codes faster. So it understands all the file types. If you have created a file, you're using GitHub Copilot there, and you've created a file with .py extension, it understands that it's a Python code file. If you have created it with .java extension, it will understand that it is a Java code file. Right? Similarly for other programming languages, and it will suggest you the code or the next few lines of your program on the basis of the programming language or the file type which you have stored that file of. Okay, so that's the feature that it understands file type. Next, cloud code understanding. So not just the basic programming concepts, it also has concepts of cloud. Suppose you're writing or developing a software that uses a cloud platforms, that may be using any cloud-based platforms. It will suggest you, according to that, the next lines of code. Okay. It also has database understanding. May it be any database, MySQL, Oracle SQL, PostgreSQL, or MongoDB. depending upon which database you're using, it will suggest you, or I can say it will help you write the query in that particular database programming language. IDE integrations. It can be integrated with lot of IDEs, integrated development environments. Lastly, but not the least, it gives you the best suggestion. As this, GitHub Copilot is based on AI, generative model, and this model is trained on lot of freely available codes, that is open source available codes, and hence it provides you the best suggestion possible for that particular piece of code which you are trying to write, or a program which you are trying to write. There are disadvantages to it as well. About that I'll talk in a little bit of time, but this is all about the features of GitHub Copilot. So what all you can do with the help of this. Okay, you will get a more clear understanding of this once we'll see the demo or a hands-on session, that how exactly is, it is auto-completing the code which you're trying to write, or how is it understanding even what is there in your thoughts. So let me be very clear here that it will not read your thoughts, what's going on in your mind, but yeah, what you are trying to write from the keywords which you have already written on the GitHub Copilot platform, it will help you to write the complete software. Now let us talk about what are the languages and IDEs that are supported by GitHub Copilot. Before getting started with hands-on sessions of GitHub Copilot, you need to know what programming languages you can use on GitHub Copilot. So the list is infinite, although not limited to this. Python, JavaScript, TypeScript, Java, C#, C++, Go, Ruby, PHP, and many others. As I said, the list is not limited to just these programming languages. Some might be added more, or it can add in the future. Initially, the language on which GitHub Copilot was developed and the first test was done was JavaScript. So later on, you will see that with JavaScript programming language, you can utilize all the features of GitHub Copilot. When I say all the features of GitHub Copilot, meaning different versions are there, or different subparts are there for GitHub Copilot tool, which you can fully utilize when it comes to JavaScript programming language. But yeah, other languages are also supported. So this is the list which you can go through, and depending upon the programming language you want to work upon, you can choose GitHub Copilot. Talking about the IDEs supported by GitHub Copilot. So from the official announcement on the GitHub Copilot website, basically, you can see that it mentions that GitHub Copilot integrates directly into your editor, including NeoVim, JetBrains IDE, Visual Studio Code. Right? So these are the 4 IDEs, integrated development environments, on which you can use GitHub Copilot. I will be using Visual Studio Code to demonstrate you the codes and also the SQL queries. But why I have selected this? So there's no such strong reason. But yeah, initially when the GitHub Copilot was developed, it was tested and developed on Visual Studio Code. And as the first always gains a preference. So that's the reason I'm using Visual Studio Code. And also, as this, GitHub Copilot was developed using this tool initially, it will be fully fledged supported or seamlessly supported by Visual Studio Code. And that's the reason I'll be using Visual Studio Code going further for demonstrating the hands-on session. Let's talk about the advantages and disadvantages as well. I have spoken a lot about advantages, right? Like, it helps you to develop and write faster code, because you don't have to, now keep remembering the small syntaxes or small keywords of the programming language. GitHub Copilot can suggest you what should be the next keyword here, or what is the advanced syntax which you are missing here. Why is your code even giving an error? That also can be pointed out by GitHub Copilot. So using all these features, you are able to write the code really quick, right? Even if suppose in the comment, just as a comment of any programming language, you write what application you're trying to develop, it will give you a basic code or basic idea. Suppose you want to write a program for linear search. You just write in a comment, program of a linear search. And within a fraction of seconds, it is going to demonstrate you or give you the code snippet for a linear search, right? If you want to develop a GUI, you want to create a graphical user interface with suppose 2 text boxes, 2 buttons, 2 labels, right? Just write down this as a comment. It will give you the basic or I can say it will give you the complete code of what GUI you want to develop. That might need some customization depending upon what exactly the GUI you want to look like. But yeah, it will help you to write down the basic at least, right? But there's a disadvantage to this as well. As I said, first thing is that, GitHub Copilot is not going to read your mind. It's not inside your brains. So definitely you have to give a proper prompt. You have to properly write down the comment, what you exactly want GitHub Copilot to help you with, right? And as it is trained on the freely available programs, it might give you incorrect results sometimes, right? Suppose I said, I want to write a program for searching an element in an array, okay? And to search an element in an array, GitHub Copilot has suggested you a logic which is somewhat like linear search, but you wanted to write binary search. So right, there's an ambiguity here, correct? Suppose you wanted to create a GUI, as I gave an example right now, and there you want 2 text boxes and 2 buttons. It provided you the text box, but it didn't provide you the label, right? So text box should be associated with the label. What exactly has to be entered into the text box is provided as a label, right? So these kind of incorrect results might be produced by GitHub Copilot. So it's not exactly incorrect, but it's incorrect when it comes to the reference of what exactly you wanted to write code with or code for, right? So you have to be a little bit of intelligent programmer in software. So you need to have a understanding or a knowledge of the software programming language to just check and review that whatever code suggestions are given by GitHub Copilot, is it right or wrong? So that's the smaller disadvantage. But yeah, as I said, if you have knowledge of it, you might not be affected with this disadvantage and convert this disadvantage to your advantage. Now let us see some hands-on session for the different aspects of GitHub Copilot, starting from the installation and also executing MySQL queries. So let's get started with how to install GitHub Copilot. And in the process, I'll also tell you how to, integrate it with Visual Studio Code. So just go on Google and there you can write GitHub Copilot. Okay. And once you press enter, the very first link, if you see here, GitHub Copilot, your AI pair programmer, you have to click on this. Okay. And then the link opens up. This is the link here, right? Now, you can see all the details about, GitHub Copilot is over here. You can see here the .ts file, how the GitHub Copilot is helping. A small, GIF is here, wherein as a comment, the developer writes that determine whether the sentiment of text is positive, use a web service, and it automatically generates this code within a fraction of a second. Similarly, you can see with the Go programming language or Python or Ruby or whatever programming language you're comfortable in working or you want to develop a software, the same thing applies. Coming to the different plans which are available from GitHub Copilot. So one is that you can use a 1 month free trial. So to give it a try, you can go with a free trial. And that's what I'm going to do it right now here. So you can click here, start a free trial, and it will give you a 1 month free trial, which you can utilize. Or there are 2 different plans. One is for individual, one is for business. So depending upon your account, your GitHub account, if it is an individual account or it's for corporate account, you can, leverage this benefits. So for individual, this is the plan per month or this much is per year. For business, similarly, the other plans are there. You can go with buying it. Trust me, guys, you're not going to, disappoint if you are taking these plans for individual and trying to use it. I'll show you also how, it is helping in writing a software. Then maybe you can get a clear idea that I should go with the plan or not. Similarly, you can see or go through this complete page. It also tells you here down the lane that, how it is helping the developers in the entire world. The research has found GitHub Copilot help developers code faster, focus on solving bigger problems, stay in the flow longer, and feel more fulfilled with their work. So this is some data, research data, which has been put up over here. And similarly, down you can see somewhere it is also mentioned which all, So you can see it writes the program for if you want to draw a scatter plot in JavaScript. This is how quick it is writing down. So you can see just with a blink of an eye, it has written the complete code. You can go with Python and how to write drawing a scatter plot in Python. just within seconds. Similarly, you can go for, other program related to memoization, or you can fetch tweets, or writing the program for fetching the tweets can be written within fraction of seconds. Right. So this is example how Copilot is helping you write code better. Now coming to how to install it. So as I said, you have to click on GitHub Copilot link. That is the very first link when you type GitHub Copilot in Google. And here you can click on start a free trial. So if you click on this, it will take you to the login page of GitHub. So you can see here that it is already logged in. So my account, this is Pragya Prudent here. If you are not logged in, or for the first time you're using it, maybe you have logged out, it will ask you to log in. Else you can, if I go back to that page, as I said, if you click here, or you can just before itself, you can sign in from here. So as I've already signed in, it's showing my, profile icon here. But if you have not, it will show you the option to sign in or sign up. Okay. So I'll go back again there, clicking on a start a free trial. And as I have not yet taken any plan, or I'm not using the account which has plan associated. So this is the free version which I'm using right now to demonstrate you. And in this, if you can go here and see, there's option of billing. Yeah, here, billing and plan. So if you go on this, plans and uses. So you can see right now it is saying it's due by September 8 because recently I've taken the free trial version. If you want to buy it right now itself, you can go here and do the upgradation. And you can see what benefits are there and what is not included. So these many things are supported right now in my GitHub Copilot, account. So you can see GitHub Copilot, it is there with the GitHub. Now, how to link it with Visual Studio Code? So I'm going to use an IDE, Visual Studio Code. You can use all the other IDEs also, which I have mentioned to you, which GitHub Copilot supports. And the reason I'm using GitHub Copilot with Visual Studio Code is that because that was the platform and IDE on which GitHub Copilot concept was initially developed. So for that, you should either have Visual Studio installed in your laptop or system. If not, then again, you can take help of Google and you can just directly type here Visual Studio Code and the very first link here. You can click on this. It will take you to the page of Visual Code Studio. You can go to this download option here and it will show you the option. If you are using Windows, Mac, depending upon your Ubuntu or whatever, Red Hat, whatever is your operating system, you can download it from here. So if you click on Windows here, it will download. You see, thanks for downloading Visual Studio Code for Windows. Actually, I have already downloaded and installed the IDE. So I need not install it again, but guys, it's very simple. So you can, once it downloads, so it's still downloading. So once it downloads, you have to just click on it, click on I accept the terms and services, and just clicking on next, it is going to install it, right? So it will take maybe 2 to 3 minutes hardly to install once it gets downloaded. Now, point is how to connect Visual Studio Code with GitHub Copilot. So let me show you that. As I said, I have already installed Visual Studio Code. So here is the terminal for it. So once you install it and open Visual Studio Code, you will see that something of this kind of a screen will come in front of you. So I have also created a project folder here and a file. That's the reason it's showing it. But if you have not and you have opened VS Code for the first time, these options won't be here. You have to create a folder and a file separately later on. Okay. So you can actually go from here, create a new file, or you can open some folder and then inside that you can create a file. So these options are here, which you can do. But before that, how to integrate now GitHub Copilot with VS Code. So for that, you have to go to this extensions option. Okay, that's also the marketplace. So here you have to search the extensions in the marketplace. So I'll just write GitHub Copilot. Okay. Now again, GitHub Copilot has various versions. Okay. So GitHub Copilot Labs, GitHub Copilot Night, different versions are there, which has different features. And also some are used for different activities, different kinds of, activities related to software development. Depending upon your use, you can, but here I'm going to just show you the very first basic version of it, that is GitHub Copilot. So once you write there, the very first option which you see with a tiny bear kind of an icon, you can click on this. So once you click here, like as I have already installed it for a faster demonstration here, but if you have not, in place of this uninstall, it will ask you to install. You just have to click that install, option. These reload, require, disable option would be there. There will be only one option given to you here, install. Okay, for the first time if you have not installed. Click on that. It will install here itself with a fraction of a second. It won't take you to any other page or anywhere. It will just simply install. And then it is going to pop up asking to authorize VS Code by GitHub to use GitHub Copilot. Right? So authorization from GitHub is required. So if it doesn't automatically pops up, then in the notification center, you can click here, and definitely here there will be a notification saying kindly authorize GitHub Copilot to be used in VS Code. Okay, so you have to just click on that notification. It will take you back to your GitHub account, and it will ask you here to, it will pop up message here saying that editor VS Code is trying to access GitHub account. So you have to allow it and authorize it. So you have to click on authorize button, and that's it. It will link there. And once the link is completed, here you can see this small icon here. So this is the icon for Copilot, okay, GitHub Copilot. So once this is active here, if it is not installed properly, it's not active, then there will be this icon with a cut mark over it, like a slash on top of this bare icon. It means it's inactive right now. If you want to inactivate or deactivate, you don't want to use it right now, you can click on this, and then you can click on disable globally. So disable globally is for disabling it for all the programming languages which you are using on this VS Code. If I am using some programming language, suppose Java, then it will ask you that want to disable for only Java. Okay. So depending, if you want to disable it for some time or you are finding it irritating, you can disable it as well, but good to use it. Fine. So this is done. So you have to just close it. And if you are using, if you have to run Java codes here, so VS Code supports Java programs, right? So you just have to install the JDK in your machine. So make sure that JDK is installed. If not, you can again install the JDK or the extension for Java from here and install it in the same way how I explained you for GitHub Copilot. So you are able to run Java programs also properly. Now, coming to already I have, okay, so once you have installed Java, you have installed the plugin of GitHub Copilot, you can go ahead with creating a folder here, or you can open a folder if you've already created or it's there in your system. And then in this, you can create a new file. I can give it a name. Suppose first program.java. Okay, so just click enter. You can select the folder. So it's already selected. VS Code folder is there, and Java project folder I have already created. So you can just create the file. So it created, the file firstprogram.java, right? So you can see J here. So it's a Java file, right? So that was all about your installing GitHub Copilot, installing VS Code, integrating GitHub Copilot with VS Code. Now let us see how we can use GitHub Copilot with MySQL in Visual Studio Code. Right? Now moving ahead to MySQL. So what we should do here is that you have to first install the plugin related to MySQL in your VS Code, and that you can do in a very few simple steps. That you can just go to the marketplace, installing extension position, and here in the search you can write MySQL. Okay, and here the second one, this if you see here this this database icon, you have to click on this and install it. As I have already installed, again it's showing me uninstall option. Otherwise it will show you install option here. Just click on it. It will install you without asking you any accept, reject or next option. It will simply install here. So MySQL, once it is installed, so these icons, if you see, are on the left side, database, NoSQL, these will not be until you have installed MySQL. So once you have installed, these icons will be visible to you. So if you click on these icons, which is visible here, so if you click on database, right now I have already connected it with the database. So it's not asking me any option to connect. But for the first time when you are, integrating MySQL with VS Code, it is going to, a pop-up window will be here where you have to fill the connection name Okay, and now what is that connection name and password, which I'll tell you. So let me open MySQL for that. So you can see here I've opened MySQL Workbench, which was already installed on my laptop. So you make sure that you have MySQL Workbench already installed, already logged in. So you can see here 2 connections are there, local instance MySQL 80, and then Pragya, by my name, I've created a connection. You can create a new connection from here. And then if you click on this, you will be prompted to enter a password, right? So you can keep whatever password you want. Now, here, when I come to Visual Studio, here when you will click for the first time this database part, it is going to ask you to connect this VS Code to the database MySQL connection here. Okay, this one. So to connect, what you have to do, you have to fill few details. As that pop-up window is not displaying here because I've already connected, I'll just tell you what details you have to enter. You have to enter the connection name there and the password. Apart from that, you need not change any field there. Okay, need not alter anything, and just click on connect. So once you click on connect, all the database which you have created in that particular connection on MySQL Workbench will be shown over here. Okay, if you want to create a new database, you can click on this plus icon and create new database. If you want to select any one of the database, suppose I have selected this employees database. Okay, so these are the tables which I already have in my database, right? So I can use any of these. You can see customers, employees, office. These are the tables. If I want to see what this customer table is all about, you can click on this dot and it will show you. So you can see here employees database. There are few entries here, and then there are these are the columns here. Similarly, you can go to the customers and you can see that as well. It's taking time to load. So once it loads, it can show. So you can see here customer name, customer number, contact, last name, and all these details are there, which has already been created. If you want to create new, you can do that as well. Now, our main motive here is to see how, GitHub Copilot is helping us to run MySQL queries. So for that, you can just go here in the query also. Okay, I've already created these 2 files. That's why it's showing here the name. Or you want to create a new file, you can just press Ctrl-Shift-P, the shortcut. This will be displayed. You can click here notebook. So you can create or open a notebook. So if you open a notebook, it will create a new notebook if none is created, right? So I've clicked on that. So you can see this notebook is created here. You can write your queries over here as well. Or the another way is that you can click on this query option, and then here you can click on plus icon, right? So this new dialog box will come here. Here you can make or write which database you want to use, right? For example, use or you can just write any name here as well. The query file name, this is basically. Okay, so I can write, start with. So this is just going to create this file. And now here you can write the queries now. So the first query is I have to specify which database I want to use. So I'm going to use here classic models. Okay. Now you can see here automatically it is giving me some suggestion. So this suggestion here you can see is from GitHub Copilot. Okay. But if I want to use, well and good. If I don't want to use, then I can write my own query as well. So suppose I want to select, I'm writing a simple query to select everything from a table. Okay. So select star from, so it's showing me some output, right? But if I don't want to display everything from customers table, I want it from employees table. So if I write just this, it will show me an option, right? Star from employees where last name is something like this. But I don't want that also. I just want this much. Now you can execute it. You can see here the output, right? All the data which is there in the employees table is being demonstrated, right? Similarly, we can write, I'll write some complex query here. For example, let's write a query to join 2 tables. Okay. So if I write select customer name, so you can see here it's showing already customer number, customer name. So I'll click tab, but not select everything from customers is fine, where So I have to join two tables, right? It's not giving me automatically here the suggestion. But if I would have written as a comment that I want to join these and these tables, it would have definitely given me the suggestion. But I want to show you that line by line how on the basis of the prompt or whatever text you have written, GitHub Copilot helps you. So where if you write here, or let's join the two tables, right? So it is inner join. So I just write inner. So you can see now it is giving me the suggestion, right? Inner joins on customer.customers and orders table automatically it is combining. If I want some other table to combine with, I can write that as well. Okay, let me just now hit enter for this. And you can execute. Okay, so it says that the customer number field is ambiguous, right? So you can see how clear suggestion is there for even the error. It means customer number should be either specified from which table I want it to be displayed, or I can just remove it for time being. Okay, let's execute the query. So you can see it has demonstrated only the customer name. If I would have written customers.customer name, it would have definitely displayed the result. Now, if suppose I want that query for calculating sum of all the orders for each customer, or maybe for, you can write any query here depending upon what is your requirement. So you can see it is, I've just written the simple English statement and it has demonstrated me the result. Select customer name, sum, quantities ordered into price of each as total, displaying it as total from customers, inner join, order on customers.customer number equals to orders.order number. Again, it's inner joining with order details because the details of order, like the price which we are calculating, is there in order detail table. Now, if you want to execute, you can execute, but you have to delete this line, okay, because it will throw error. So if I execute this, you can see here some name of total is being displayed here. For each customer, what is the quantity ordered, total price for that is being displayed, right? So you can use aggregate functions, you can use inner joins, and without spending much of a time, you are able to run and execute queries. The various complex concepts like subqueries can also be executed with ease. If you want to create complex queries like creating a subquery, that also GitHub Copilot is going to help you with. Okay, I'll give you an example here. Suppose I want to create a subquery. So I'm writing select star from employees where employee number in select. So now you can see it is automatically complete that I want to write a subquery. It automatically understood, right? So the subquery by default it has written is that select reports to from employees where reports to is null, right? Meaning it's something like a self join, or it's referring to I'm trying to fetch all those employees details who is reporting to someone from the employee set only, meaning the reports to is null. Tab and enter, right? And then you can execute it. So you can see it is executing the subquery successfully. So as I said that you need to know the concept, basic concept of any programming language or query language which you are using. And depending upon what you want to write, depending upon the prompts or the text which you have already written, GitHub Copilot is going to suggest you the next line of code or the complete program. We saw the various examples for SQL queries, MySQL queries, and also as a Java program. Now let us see how we can use ChatGPT in Visual Studio Code. And also I'll tell you something about GitHub Copilot Labs. Okay, so we are here at Visual Studio Code window. Now here, if I want to use ChatGPT, so till now maybe you would have used ChatGPT to get some useful information, and the version of ChatGPT which you might have used is 3 or 4, depending upon if you have a valid subscription of it or not. Now, how can you use the functionality of ChatGPT here in VS Code? So for that, again, you have to install. You just click on the extensions, and then here you have to click GitHub Copilot Chat. Okay, GitHub. You have to write here GitHub Copilot Chat. Okay, the very first option, if you see here, you have to install it again. as I've already installed, it's not showing me the option to install it. But if you haven't, you'll be asked to install it first. So install it. Again, you have to authorize this from your GitHub account. So once you have installed, you can go to this notification center and you can see that, it is asking here, a pop-up is there in the notification that you need to authorize this GitHub Copilot chat. And so just have to click on that dialog box, which will appear. It will take you to your GitHub account and ask you to authorize there. So just click on authorize from there, right? Sometimes, like when I tried using GitHub Copilot chat, what happens is that it added me to a queue and it said that they'll get back to me and notify on my email when I'm let in to chat, use this chat feature. Okay, so it took around 24 hours for me that they came back sending an email saying that, you have been allowed to use this feature of GitHub Copilot chat. So that might take time for you as well. That's the reason I've already installed and I'm just demonstrating you over here. So once you do this, installation and all the authorization part, you'll see this icon over here. Okay, so this icon, this is the chat option. Okay, you have to click this. Earlier, this option won't be here, but once you have installed GitHub Copilot chat, you can see. So here you can ask anything related to the program. Okay, suppose I want to know why is main method used in Java. So just write your question and hit enter. It is just saying that the GitHub Copilot is thinking, and then it will write down its answer. Right? The main method is used in Java as the entry point for any Java program. It is a method that is executed when the program is run. The main method is where the program starts executing. This is this, and without a main method, a Java program cannot be run. So this is basically why I have asked is main method used, right? You can ask any such question which you don't know. So if you want to know what is collections in Java, you can ask. You can write question related to any programming language. I'm just referring Java here because that's what we have talked about in this course. Okay, so you can see what the collection refers here, what are the different collection classes in Java, all these information is giving. So the chat GPT feature, you can use it in VS Code using GitHub Copilot chat. Okay, now let me also tell you about GitHub Copilot labs. Okay, so what is GitHub Copilot lab first of all? So GitHub Copilot lab is your laboratory features, meaning if you want to play with your program, play with a piece of a code. For example, you want to test that code or you want to convert that code into some other language, like you have written in Java, you want to convert it into C, or if you are not understanding what this piece of code is, please explain me. So all these kind of laboratory activities, if you want to do on a piece of code, you can do it using GitHub Copilot lab. But that also is a plugin which you have to install. So you have to write here GitHub Copilot lab. Okay. So you can see here GitHub Copilot labs is the first option which is there. You have to click on install again. As I've already installed it, it's asking me to uninstall. So you do click on install, done. This will also ask you to authorize it from the GitHub account. So the same process, you need to authorize it. And once done, this option will be visible here. So before this small bear option was only here at the down taskbar, but now it will be visible over here. So this is about GitHub Copilot lab. So you click on this icon. So you can see here, for any piece of code, you can understand why this is. So for example, suppose I am taking the example for the Java code which we have written. So, okay, I'll take another example which I have already written here. So this is a demo.java file where a program of exception handling is written. So public static void main try A5. If A is less than B, then it is throwing an exception. And then it is handling in catch by just printing a caught keyword. Right? Now, I want to run lab or use the features of GitHub Copilot lab on this code. So you can see here the first option is explain. So if you want to understand certain piece of code which you're not understanding, for example, if I put this try catch statement, select this, okay, and so this is automatically displayed here in the explain below explain tab. The option is here. So you want to explain it, the code, you want what the code does, so you want to some example based on this code already existing code, you want some examples. So all these can be done here. So if I go to explain code and then you hit on Ask Copilot, it is going to explain you. So you can see below, here's the result, the explanation for the code above. So each and every keyword and line what is being done will be explained here, right? You can see here all the explanation is done, what this class demo is doing, and then created in which the exception is thrown. So the correct explanation is given. Now, language translation. So this code is written in Java. Now you want to translate it into some other programming language. Like I want it to translate into Python. And I want to ask Copilot. So you can see here it has, converted into a Python code. Try catch, how is this exception handling done in Python? Correctly it is done, right? You want to convert it into some other programming language. See how many programming languages is there. You can do the same. But make sure you select only for those where it's possible. Like you cannot convert a MySQL query to a Java code, right? So, make sure you are intelligent enough there to decide. And then there are these brushes. You can fix bug, you can debug your code, you can clean or delete certain codes if you want. So all these options are there. Then there is the last option called test generation. So you can see here that test generation is currently supported only for JavaScript and TypeScript, because JavaScript was the language, the very first language on which this, GitHub Copilot was developed. And that's the reason it's only right now supported for this. But maybe in later future, it will come for other programming languages also. Then you can use test generation. So for a given particular piece of code, you can just click on this, suggest a new test, and it will generate a unit test for the given piece of code.
In this tutorial, we have explored the world of databases and SQL, starting with the basics of databases and their significance. We distinguished between a simple database and a relational database management system, that is RDBMS, then mastered SQL. We gained hands-on experience with MySQL, including basic commands and subqueries, and explored Oracle SQL for enterprise applications and PostgreSQL for its extensibility. A practical project is the Broadband Database Management System project, which involves managing and analyzing broadband service data. We also dwelled into generative AI in SQL, automating and enhancing queries, and introduced GitHub Copilot, an AI assistant for efficient SQL query writing. This tutorial has equipped you with the skills to manage complex databases, write optimized queries, and leverage AI for enhanced productivity. Don't forget to like, share, and subscribe to our channel for more tutorials like these.